Welcome to Learning Apache Cassandra. Let's take a look at what we're going to be doing in this course. In Unit 1, Introducing Cassandra in the course, we're going to first talk about what is Cassandra and what are people using it for. Then we're going to get set up for doing the exercises in the course. So we'll talk about the system requirements, how to download the working files folder, and get our main virtual machine set up and open. In Unit 2, Getting Started with the Architecture, we're going to learn the basics of Cassandra's architecture. We need to do this because as we go forward, we're going to be very much in hands-on mode, and we need to know the basic foundation of how Cassandra works, so that when we're writing an expression like replication factor 3, we know what that means. In Unit 3, Installing Cassandra, we're going to go through the steps for installing Cassandra. In Unit 4, Communicating with Cassandra, we're going to go through the different ways to communicate with Cassandra, and then we're going to go on to use CQLSH, which allows us to write Cassandra query language commands on the command line. Then, in Unit 5, Creating a Database, which, by the way, in Cassandra is called a Keyspace, we're going to learn how to do that, and we're going to make a couple databases. In Unit 6, Creating a Table, we're going to learn how to do that. We're going to make a few tables. In Unit 7, we're going to learn the options for inserting data, and then we're going to go ahead and insert data. In Unit 8, Modeling Data, we're going to learn what is the best way to model data in Cassandra. In Unit 9, Creating an Application, we're going to create a couple applications. Let's take a look at those. One of them is our Alarm System Status application. This is going to allow a homeowner to enter in their home ID and see the activity for their home alarm system. In our second application, this is for a rental car company to be able to track the location of their automobiles. Let's say that somebody hasn't returned a vehicle and we want to find out where is that vehicle. We could go ahead and enter in the date and the vehicle ID, and it would show us exactly where that vehicle is located. In Unit 10, Updating and Deleting Data, we're going to learn how do we update and delete data in Cassandra, and what's really going on in the back end when we do that. In Unit 11, Selecting Hardware, we're going to look at selecting hardware for production. CPU recommendations, RAM, type of storage, those are the sorts of topics we'll be looking at in Unit 11. In Unit 12 and onwards, we're going to be creating a multi-node cluster. So up to this point, we've got a single node cluster, but in Unit 12, we're going to be adding nodes, going through the steps and how to do that. In Unit 13, we're going to look at tools for monitoring a cluster. Unit 14, repairing nodes. Unit 15, removing nodes. What if a node dies? How do we remove it from the cluster? Or what if we want to remove a node? Maybe we don't need as much capacity at this point in time. So we'll be doing that in Unit 15. In Unit 16, redefining a cluster for multiple data centers, we're going to make it so that our cluster is across more than one data center. And this is a common feature and reason people choose Cassandra. They want to have a database that provides high availability so that if one data center gets wiped out, the other one can continue to serve requests. And then finally, in Unit 17, Resources for Further Learning and Wrap-Up, we're going to talk about various resources available, such as the documentation, various blogs, especially those from committers on the project, how to look at recordings of events such as the Cassandra Summits, how to post questions, and the various meetups that are available so you can meet other people in the Cassandra community and continue learning. Let's get started. So what is Cassandra? Cassandra is open source. It's an Apache project. Cassandra is a NoSQL database technology. You may or may not have heard of NoSQL. It's a relatively new expression. For most people, it refers to not only SQL, meaning an alternative to the traditional relational database technologies, such as Oracle, MySQL, SQL Server. Apache Cassandra is a distributed database technology as well. Instead of the database only being able to live on one server, it can actually be spread across multiple servers. This is huge. This allows a database to grow almost infinitely because it's no longer restricted to having to fit all on one server. Cassandra is a big data technology which provides massive scalability. I'm aware of some instances of Cassandra where the cluster is 1,000 nodes, 1,000 servers that make up a cluster that the database is spread across. That's a lot of data. And Apache Cassandra is commonly used to create a database that is spread across nodes in more than one data center for high availability. Not only can your database live across multiple servers, but those servers can be spread across more than one data center. This is a reason that people often choose Cassandra over other database technologies because they want to make sure that if one of their data centers goes down, that another one can continue to serve requests so that their application is always available. And finally, if some of this seems familiar to you, it could be that you are familiar with Amazon Dynamo, which is a distributed database technology, or Google's Bigtable, which was created for storing huge amounts of data. Cassandra is based on both of these technologies. Let's go ahead and take a look at the Apache Cassandra homepage so we can learn a little bit more about Cassandra. If you'd like to follow along with me, you can go ahead and open up a browser window. To go to the homepage, you can enter cassandra.apache.org. This is the homepage for Apache Cassandra. And here it mentions linear scalability, which, like it sounds, is the case with Cassandra. You can add more and more nodes to the cluster, and it will still have top performance. It will still be highly performant. There's not a degradation of performance as you're adding additional nodes. Fault tolerance. Each node, each server in a Cassandra cluster has the same functionality as the others. You don't have to worry about a master node going down and the whole thing stopping to work because Cassandra doesn't work that way. It works in a way so that each node has the same capabilities as the others, which makes it easy to add additional nodes and makes it so there is not a single point of failure. Also here, we see commodity hardware. That's another great selling point, is that you do not have to buy specialized servers in order to run Cassandra. You can use commodity hardware. I'm going to go ahead and scroll down a little bit here. There's a nice section down here. Talks about fault tolerant. We were just talking about that. Highly performant. Cassandra is highly performant, and it's for creating real-time applications. It's not to be confused with analytic technologies like Hadoop, where they run at night, they run in batches. Those sorts of applications are not designed for real time, whereas Cassandra is. Making that differentiation between a real-time, highly available technology as opposed to a batch process analytic type of technology. Decentralized, as we mentioned, no single points of failure. I'll mention this is the last one. Highly durable, as we were talking about. You could have an entire data center go down and your database could still go on. So this movie was getting you started with what Cassandra is. It's a highly scalable, fault-tolerant, distributed database technology that provides high availability. Let's now take a look at what Cassandra is being used for. Cassandra is being used by over 1,500 different organizations for a variety of purposes, from sensor data to recommendation engines, to gaming, to fraud detection, to location-based services, to online financial products. Many organizations choose Cassandra for projects that require massive scalability and or high availability. Let's take a look at some of these. I'm here on Planet Cassandra. If you'd like to follow along with me, open up a browser window and go to planetcassandra.org. Once you're here on Planet Cassandra, over on the right, go ahead and select Read Technical Use Cases. On this page, we could scroll down through well over 100 different use cases that have been written up, or we could take a look at a few by going through these tabs, through these categories. Let's do that. Let's go ahead and select Product Catalog / Playlist. And if we scroll down this list, we're going to see some familiar names like Comcast, Hulu, Netflix, Sky. Netflix chose Cassandra not only for its scalability, but also for its high availability. With customers accessing Netflix at all hours, Netflix needed a system that could always be available with no downtime. Netflix is a huge Cassandra user. I'm going to scroll back up and choose another category, recommendation / personalization. So I've got a number of use cases in this category as well. Outbrain is used to provide you with content that's relevant to what you've been clicking on. You might notice that when you go to some websites and you're clicking on links related to a topic, that you might then see advertising start showing up related to that same topic. And that could very well be provided by Outbrain. They reach 86% of the US online population. Fraud detection, another category here. I'm going to go ahead and call out Barracuda Networks. If we want to see more detail about any of these use cases, we can click on the Read Use Case link. And if we scroll down through, we can learn more about why they choose Cassandra and how they're using it. In the case of Barracuda Networks, they've been wanting to track all of the malicious websites on the internet. And in the past, before Cassandra, when they had a relational database, they were limited by how much data they could store. So as a result, when a malicious website was inactive, they would go ahead and take it off their list because they had limited storage space. But the problem is that that site might later come back and start being active again. And they were running into that quite a bit. And they were referring to these malicious sites that were coming back as zombies. They had been dead, but now they're back alive. Now, through Cassandra, they don't have that problem anymore because they have the ability to store massive amounts of data. They don't have to worry about throwing any of these off the list and then having them come back to haunt them. I'm going to go back to our page here of use cases. Messaging. Lots of companies are using Cassandra as part of their messaging platform. Another category I'll mention, which is quite hot, is the Internet of Things / sensor data category. Being able to make measurements, let's say devices in your home, and maybe you have different devices in the different rooms in your home that are measuring your temperature. And maybe they're measuring it every minute or every second. Imagine millions of homes with millions of devices, and let's say they were being measured every second or every minute. That's a huge amount of data that needs to get written to a database that can handle that volume, all those writes coming in. Cassandra is a great database for that type of situation. This was just a quick little look into some different companies and how they're using Cassandra and why. So I encourage you to take a couple more minutes and look through this. Click on Read Use Case for some of these companies that look interesting to you and might be similar to how you're thinking of using Cassandra. Let's talk about the system requirements for doing the hands-on exercises in this course. One option that you have as we go through the course is that you could just watch, and that's certainly an option. However, another option, and one that I would encourage you to do, is to do the hands-on exercises with me. If you'd like to do that, let's go through what's needed. We're going to need a 64-bit operating system, so you can use a Macintosh, Windows, or Linux machine. It just needs to be a 64-bit operating system. You're going to need a machine that has 8 gigabytes or more of RAM. You're going to need 30 gigabytes or more of free hard drive space. The reason that we need a lot of RAM and a lot of free hard drive space is because we're going to be working with virtual machine images. In order to create our cluster of 4 nodes, we're going to be using 4 virtual machines. Each virtual machine is going to have 1.5 gigabytes of RAM, and each one is going to take up about 7 gigabytes of space on our computer. Hence the requirements we have listed here. One more thing that we're going to also need, because we're working with virtual machine images, which were created with VMware, is that we're going to need the free VMware player installed and set up on the computer as well. What we're going to do now is we're going to go through and look at this from the point of view of if you're using a Macintosh, then we'll do Windows, and then we'll do Linux. Depending on which operating system you're using, feel free to jump ahead in this video. On the Macintosh, if you happen to be using a Mac, the first thing you're going to do is you're going to go up to the Apple menu and you're going to choose About This Mac. When you do that, a window is going to open up, and in here, you're going to look to see what the processor is. Then you're going to check the processor against this chart here to make sure that that processor is a 64-bit one. Next, to check to see how much RAM there is and make sure there's at least 8 gigabytes, we're going to also be in that window About This Mac, and we're going to look at the amount of memory. This is one with 8 gigabytes of memory. And then to check to see how much hard drive space there is on the Mac, you're going to select your Macintosh hard drive, and then from the File menu, choose Get Info. That's going to open up this window over here on the right. And in here, we can see how much space is available. So in the case of this computer, there's 46 gigabytes available. And then the last thing we need to do on the Mac is we need to have the equivalent of VMware Player. VMware doesn't actually create a VMware Player for the Macintosh. It just doesn't exist. But what you can do is that you use VMware Fusion. VMware Fusion is VMware software for the Macintosh, and you can get it either as a 30-day trial or you can purchase it. If you're working with a Windows computer, what we'll do is first we want to check to make sure it's got a 64-bit operating system. It kind of varies exactly where to go to find these things depending on the Windows operating system, but basically you want to locate My Computer, which you would generally find in Windows Explorer. So you're going to right-click on My Computer and select Properties. And once you do that, you can see the system type. And here, as you see in the screenshot, we see that it's 64-bit operating system. Next, we want to make sure that we have at least 8 gigabytes of memory on our Windows computer. Also, this was under right-clicking on My Computer and selecting Properties. Here we can see that under Installed Memory, RAM, we have 16 gigabytes. That's plenty. Next, we want to check that we have at least 30 gigabytes or more of free hard drive space. We can do that on our Windows computer by right-clicking on C and selecting Properties. And then we can see the amount of free space we have on the drive. And in this case, it tells me I have 32.9 gigabytes of free hard drive space. Lastly, for the Windows operating system, we need to get the VMware Player. This is free to download. You can get it from vmware.com, and you're simply going to go here, get the player, click on the download button to download the installer, and then double click on it and follow the next button prompts to go ahead and install VMware Player. If you're using a Linux computer and you need to check to make sure that it's 64-bit, you can open up a terminal window and you can run the command getconf space long_bit. If you have a 64-bit machine, then it's going to go ahead and display 64. Next, on our Linux computer, we want to check to see that there's at least 8 gigabytes or more of RAM. And to do that, we can run the command top in a terminal window, and it'll then display the amount of memory that we have. In this case, you can see that this particular machine just has 1.5 gigabytes of RAM, and certainly that wouldn't be enough for our exercises. We need to use a machine that's got at least 8 gigabytes of memory. Next, let's check to make sure that our Linux machine has at least 30 gigabytes of free hard drive space. So to do that, we can run a command in a terminal window, and that command is going to be df space -h. And once we do that, we can see how much hard drive space is available. In this case, you can see that the machine I'm using at the moment only has 14 gigabytes of free hard drive space, which is not going to be enough for completing all the exercises in the course. So we would want to look to free up some space or use a different computer. Finally, for our Linux machine, we're going to need the VMware player. And this is free to download from vmware.com. In this movie, we open up our main virtual machine. In your working files folder, we've got a couple zipped virtual machines. The one we want right now is virtualmachine1.zip. The other one we'll be using later when we go to add additional nodes to our cluster. But right now we just need to unzip virtualmachine1.zip. I'm going to double click on it. I'm on a Mac, and double clicking is how I unzip. If you're on Windows, you might be right-clicking and choosing Extract All. If you're on Linux, you might be on the command line using the unzip command. Once this unzips, on the Mac, I'm going to have just a single file, and that's going to be my virtual machine image, which I'll be opening up. If you're on a Windows computer, what'll happen most likely when this unzips is that you'll end up with a folder of files. Within the folder of files, this is if you're on Windows, you'll be looking for the file that has the extension .vmx. And the icon, 3 little turquoise boxes overlapping each other, we're going to be double-clicking on that file. Here's mine. I just have a single file, as I mentioned. And if you're on Windows, you'll have most likely a folder. You'll be going into the folder, looking for that .vmx file, and double-clicking on it. The virtual machine should go ahead and launch. If you have an issue with yours, like it's not opening, it's probably because you don't have VMware Player installed on your computer. And if that's the case, you'll want to go install it. If you're on Windows and you've done that and it still doesn't open, it could be that you don't have virtualization technology turned on. This is something that's set in the BIOS of your computer. It's often already turned on, but this does vary from computer manufacturer to computer manufacturer. If you're not able to open up the VM at this point, it is most likely that. What you'd want to do is Google on the name of your computer manufacturer and enable virtualization technology, because the steps vary from computer to computer. I'm guessing most of you probably are here. You've opened up the VM and you're just waiting to log in. Let me give you the password. It's Ubuntu in all lowercase. So that's UBUNTU. And then I'm going to hit enter. Here we go. And as you might see in here, we're using Ubuntu as the operating system. Ubuntu, Red Hat Linux, and CentOS are all very popular operating systems for running Cassandra. That's why we're using Ubuntu in here. And so there we are. This is how to open up our virtual machine, which we'll be using as we go forward. So this unit was introducing Cassandra in the course. Just for fun, to wrap up this unit, let's do a couple pop quiz questions. Number 1, which of these is not a reason to select Cassandra as a database technology? Is it A, massive scalability, B, no single point of failure, C, proprietary software, or D, high volume of writes? If you chose C, proprietary software, that's correct. Cassandra is not proprietary software. It's in fact open source software. Question number 2. Which of these scenarios would be appropriate for Cassandra? A company that needs to store every minute the temperature of rooms in millions of homes. B, a company that wants to store the online user behavior of millions of customers to provide recommendations. C, a high volume shipping company that needs to be able to trace the status of a package in real time. Or D, all of the above. If you chose D, all of the above, that's correct. These are all great scenarios for choosing Cassandra. Let's talk about the fact that Cassandra is a distributed database. In a distributed database, rather than being constrained to having to fit all of the data onto only one server, the database can be spread across multiple servers, allowing for massive horizontal scalability. In Cassandra, we call a network group of nodes, which in effect are servers, a cluster. Within a cluster, there are no master or slave nodes. Each node has the same functionality as the others, which, combined with replication, which we'll be learning about shortly, allows for a distributed database with no single point of failure. In addition, a Cassandra cluster can easily be spread across more than one data center, allowing for data availability even if one data center completely goes down. Let's now go take a look at documentation that's available on Cassandra's architecture. So if you'd like to follow along with me, I'm going to go to a browser and in the address bar, enter www.datastacks.com/docs. That should take you to this page here. DataStax is a company that is heavily involved in the Cassandra community. DataStax offers an enterprise version of Cassandra, as well as professional services, as well as documentation. Let's scroll down to see the types of documentation that are available. If we go down to the Common Tasks category and look under General, we see Cassandra Architecture, which is what we're looking for right now. Let's go ahead and click on that link. And we're here on the landing page for Architecture in Brief, which provides us with an overview of Cassandra's architecture. In addition, over on the left, we see various related topics, which we'll be learning about, such as gossip, data distribution and replication, partitioners, snitches. I encourage you to take a moment and browse through these topics to see the sorts of things we're going to be learning about as we go forward. In this movie, we learn about Snitch. If there's no master node in a Cassandra cluster, which is true, and if all the nodes have the same functionality as the others, which is true, how do the nodes know about each other? How do they know about the topology of the cluster and which nodes are in which data center, and within each data center, which nodes are in each rack? They do that through Snitch. So Snitch is how the nodes in a cluster know about the topology of the cluster. How do we define Snitch? We have some options, including dynamic snitching, simple snitch, rack inferring snitch, property file snitch, gossiping property file snitch, EC2 snitch, EC2 multi-region snitch. Each of these is detailed in the documentation, but let's go ahead and talk about a couple of them. The first one I'll mention is simple snitch, simply because it's the default. So when you first install Cassandra on a node, on a server, the snitch by default is defined to be simple snitch. That's fine, except the problem or limitation with simple snitch is that it can only be used with a cluster that is only in one data center. And that's the negative, because often with Cassandra, we're creating a database. We want it to be spread across more than one data center for high availability. In that case, we're going to want to look at one of these other snitch types. Let's talk about property file snitch and maybe a bit about gossiping property file snitch as well. We're going to be using that later on in this course. Let's take a look at property file snitch. For each one of these snitch types, there are configuration files that go along with it. And those configuration files go on each node in the cluster because every node needs to be using the same snitch type, which makes sense. So in the case of property file snitch, the way it works is that in this properties file, you would list the IP address of all of your nodes in the cluster, and then you would also specify which data center and which rack that node is in. So in this scenario, we have a cluster that's across 2 data centers with 6 nodes in data center 1 and 4 nodes in data center 2. And we see that in the case of this cluster, there are 3 nodes in rack 1 of data center 1, 3 in rack 2, data center 1, 2 in rack 1 of data center 2, and 2 in rack 2 of data center 2. This is one option. The thing about this particular snitch type, though, that's maybe not as handy as the gossiping property file snitch, is that when you add a new node to your cluster, you would have to go to every existing node and add into its properties file. You'd have to add in the IP address of the new node, the data center, and the rack that it's in. If you just have a few nodes, like less than 10, that's not such a big deal. But what if you had 500 or 1,000 nodes in your cluster? That would be kind of tedious to have to go into each one of those and add in the new IP address with its data center and rack information. What we could do is we could instead use gossiping property file snitch. And we're going to be doing that later on in the course when we change our cluster from being in only one data center to spanning across more than one data center. So this movie has been an introduction into Snitch, which is how the nodes in a cluster know about the topology of the cluster. Let's talk about gossip. Gossip is how the nodes in a cluster communicate with each other. Every 1 second, each node communicates with up to 3 other nodes, exchanging information about itself and all the other nodes that it has information about. Gossip is the internal communication method for nodes in a cluster to talk to each other. For external communication, such as from an application to a Cassandra database, CQL or Thrift are used. And we'll be using CQL a lot as we go forward in this course. Before we jump into learning how data gets distributed and replicated, let me ask you just a couple questions. Number 1, how do the nodes in a cluster know about the topology of the cluster, the data center and rack that each node is in? A, through the slave node, B, through the master node, C, through cassandra.apache.org, or D, through Snitch? I bet you chose D, through Snitch. That is correct. Number 2, gossip is how a client application talks to a Cassandra database. Is this true or false? Trick question. It's false because gossip is really just used for the nodes to talk to themselves. For external communication, we're going to need to use something else, such as the Cassandra query language or Thrift. Last question. Gossip runs every is it second, minute, hour, or day? That's right, it's second. Gossip runs every 1 second, where each node is talking to up to 3 other nodes, exchanging information about itself and the other nodes it knows about from previous exchanges. Let's talk about how data gets distributed in a cluster. Data distribution is done through consistent hashing to strive for even distribution of data across the nodes in a cluster. Rather than have all of the rows of a table existing on only one node, the rows are distributed across the nodes in the cluster in an attempt to evenly spread out the load of the table's data. Let's look at an example. This is a table of data from our home alarm system application that we're going to be creating. And in the first column is the home ID, the date and time that an event happened with the alarm system, the event, and the code that was used. Now, what happens in terms of storing these rows of data in a Cassandra cluster is that the value in the first column is actually hashed. It's turned into a value within a range. And then, depending on the values that each node is responsible for, the token ranges in each node, that's going to determine which node each row gets stored on. Let's look at this in more detail. To distribute the rows across the nodes, a partitioner is used. The partitioner uses an algorithm to determine which node a given row of data will go to, and the default partitioner in Cassandra is murmur3. Murmur3 takes the value in the first column, and I have an asterisk there because even though this is a very common scenario to use the values in the first column, depending on how you design your table, it is also possible to have more than one column used for this. But for our example, and trying to keep things normal and simple here, we're going to look at the values in this first column. And what happens is murmur3 generates a unique number between -2 to the 63rd power and 2 to the 63rd power. So at a very wide range of values. Looking at our example here, so this first row, its value, let's say it gets turned into this number here, this -74563, etc. number, a very, very small number. And then the second one here, let's say that this row gets hashed by the partitioner into -2487, so also a negative number, a small number. And then let's say this third one gets hashed into 639400, etc. So a very big positive number. What happens is each node in the cluster has an endpoint value assigned to it. This is something that you manually do. What happens then is each node is responsible for the values leading up to it and including its value. Where do these numbers come from? How would you know what numbers to assign to the nodes? There's a couple ways to do it. You can use a formula on the command line. You could do Python -c print string 2 ** 64 divided by, and then instead of the number 4, you could substitute in the number of nodes that are in your cluster. And then we'll continue along with this formula. And you see there's another place here where there's a 4. So you would also substitute in your number. Let's say that you had 12 nodes in your cluster. So instead of the number 4 here, you'd have 12. And instead of the number 4 over here, you'd have 12. And then if you were putting 12 in here, then on the second line, you would see 12 different values, one for each of your nodes. So in the case of 4, which is how big my cluster is, I see what the endpoints are here. -9223372, -461110, and then a positive number. Another option is that you can use a murmur3 calculator. Let's take a look at doing that. Feel free to follow along with me. Search on Cassandra murmur3 calculator. You'll see there's a few calculators people have created. I'm going to go ahead and choose this first one here. And if we go ahead and scroll down a little bit, we want to choose the murmur3 partitioner, and we can enter in how many nodes. In our case, for the cluster I'm using as an example, there's 4 nodes. If I click on calculate tokens, it gives me those endpoint values. Let's say that you were doing a 9-node cluster. So if I enter 9 in here and do calculate tokens, you see what those endpoints would be for your 9 nodes in your cluster. As we just saw, each node has an endpoint value and is responsible for all of the token values up to and including itself. Looking back at our first example where we had a number which was -7456, etc., that would be stored on this second node here. That would be the one responsible for storing that row of data. This is how the rows of data get stored and distributed across a Cassandra cluster. Let's talk about replication. Replication is a common topic when it comes to Cassandra's architecture. A replication factor must be specified whenever a database is defined. The replication factor specifies how many instances of the data there will be within a given database. Although one can be specified as a replication factor, it's common to specify 2, 3, or more, so that if a node goes down, there's at least one other replica of the data so that the data is not lost with the down node. perhaps it goes without saying, you can have a different replication factor for your different databases. So you might have a database that is storing user clicks, and you're using that to do recommendations. Maybe you're thinking, if I don't pick up every click, it's okay. If a node goes down and a few clicks get lost, no big deal. So you might just do a replication factor of 1. Or another situation, maybe you're doing bank transactions and you're thinking, no, I cannot lose any of these. These are critical. So in that case, you're probably going to do a replication factor of, I would guess, 3, at least 2, and possibly more. So it's really going to depend on your data and your applications for what replication factor you're going to specify for each of your databases. Just to illustrate this, if the replication factor for a database is 3, then the -7456 data that we were looking at earlier will be written to 3 nodes. If one of those nodes were to go down, that's okay. We still have 2 replicas of the data. We still have 2 instances of the data, no problem. And even if 2 nodes were to go down, we're still good. We still have an instance of the data. This is replication. It's a topic that we will be working with hands-on as we go forward with the course. One last Cassandra architecture topic that we should talk about is virtual nodes. Virtual nodes are newish, but have become the standard. Virtual nodes are an alternative way to assign token ranges to nodes and are now the default in Cassandra. With virtual nodes, instead of a node being responsible for just one token range, it is instead responsible for many small token ranges. And by default, that number is 256, which means that each node is responsible for 256 little ranges. You might even think of them as little slices. Virtual nodes allow for assigning a high number of ranges to a powerful computer, for example, 512 ranges, and a lower number of ranges, let's say 128, to a less powerful computer. Virtual nodes, also known as vnodes, were created to make it easier to add new nodes to a cluster while keeping the cluster balanced. When a new node is added, it receives many small token range slices from the existing nodes to maintain a balanced cluster. With the old way, when we had static token ranges, it was common to double the number of nodes if you wanted to increase the size of your cluster, so that the endpoint for the new nodes could be a value half of the value of the existing endpoints. And this was to make it so that as you added nodes, your cluster remained balanced. You didn't have any nodes with larger ranges and other nodes with smaller ranges. With the old way, the best practice was to double the number of nodes to maintain a balanced cluster without having to change the endpoint values of the existing nodes. I've added 4 nodes here. If you were to just add 1 and assign its endpoint value, then other nodes would have a lot bigger range and therefore be holding a lot more data than that new node that was just brought in. So traditionally what you did back in the days of the static token ranges is that to keep it all even and balanced, you would always double. So you would go from, say, 4 nodes to 8, 8 to 16, 16 to 32. And as you got into really big numbers, like maybe you had 256 nodes and you wanted to add a few more, well, if you were going with this methodology, you'd have to go to 512. Maybe you didn't want to make that big of a jump. Or what if you're at 512 and then you want to add more nodes? You'd have to go to 1024. That was a lot. So using virtual nodes, you add in a new node, it gets little slices off of all the existing nodes, and you still have a balanced cluster. As we go forward, doing our hands-on exercises, getting into the configuration files, we're going to look at where virtual nodes are specified. In this unit, getting started with the architecture, we learned that Cassandra is a distributed database. We learned about Snitch, gossip, how the data gets distributed, about replication, and about virtual nodes. All topics that we need to know as we move forward hands-on with Cassandra. Let's go ahead and do a couple pop quiz questions just for fun. Number 1, what is the default partitioner in Cassandra? Is it A, byte-ordered partitioner, B, random partitioner, C, MD5 partitioner, or D, murmur3 partitioner? I bet you got this right. Murmur3 partitioner is correct. Some of these others are older partitioners that are not as fast as murmur3, which is now the standard default partitioner in Cassandra. Question number 2. The point of virtual nodes in Cassandra is to A, use virtual machines instead of physical servers, B, run Cassandra in the cloud, C, be able to easily add a new node to a cluster without having to manually adjust the token ranges of existing nodes to have a balanced cluster, or D, define one large token range per node. The correct answer is C. In this movie, we go through how to download Cassandra. In a browser window, you're going to go to cassandra.apache.org, the home of Apache Cassandra. Over on the right-hand side, you see that we have the option to download the latest version of Apache Cassandra, and we'll walk through doing that. Before we do that, I just want to mention a couple other options that are also available to you. So along with being able to download Cassandra from here, you can also go to planetcassandra.org, and from there you can download a community version of Cassandra from DataStax. Another option for downloading Cassandra is if you go to the DataStax website, they offer an enterprise version of Cassandra. So that's also Apache Cassandra plus some additional software for Cassandra to be able to communicate with other technologies such as Hadoop or Solr. We're going to be using this version. So let's go ahead and select Download Options. We notice that we have this option here to go get the tarball file. Select that. We could download it from any of these sites. If we go ahead and right-click on one of them, we can choose Download Linked File As. And if we wanted to, we could then go ahead and download the tarball file. We don't need to do this because I have already gone ahead and downloaded it to our virtual machine. Let's go take a look at that. You can click on Cancel. And let's go to our virtual machine, which we opened previously. If it's gone to sleep, like mine has, go ahead and click anywhere. And then as you may recall, the password is Ubuntu in all lowercase. Once we're in here, let's open up a terminal window. And we can do that by clicking on the dash home icon in the upper left here. If we didn't already see the terminal icon here, we would be able to type in terminal and it would show up on the list. Go ahead and click on it to open up a terminal window. And where I downloaded the tarball file to is in the downloads folder. Let's do ls. And we see the directories in here, including downloads. And let's go to the downloads directory. So cd for change directory, and then downloads, enter. Do another ls to list the contents of this directory. And there we see our tarball file. This is how to download Cassandra. And as we go forward, we'll be installing it. In this movie, we check that Oracle Java 7 is installed. Cassandra was written in Java. So in order to run Cassandra, the Java Runtime Engine, the JRE, or Java Development Kit, JDK, is required. Cassandra 2.0 requires version 7 of the JRE or JDK. Cassandra does not work well with OpenJDK, so use the Oracle JRE or JDK, not OpenJDK. Oracle JRE 7 can be downloaded from the Oracle site. I've already got it installed on our virtual machines, but if it wasn't, we could go out here to www.oracle.com/technetwork/java/java.se/downloads/index.html. And here we could go ahead and download and then install the JRE or JDK. Even though only the JRE is required in order to run Cassandra, I've actually installed the JDK on our virtual machine because as we go forward with this course, and create our applications, the vehicle tracker application and the alarm system application, we're going to be creating those in Java. And in order to compile the code that we write, we're going to need the JDK. If you're curious to see the steps I did, in your working files folder is a text file called steps done to create vm1.txt. Go ahead and open that up and you can see exactly what I did to install JDK on our Ubuntu VMs. Let's go check to see that it is indeed installed. So let's go back to our VM, and on the command line, it doesn't matter what directory you're in, let's go ahead and enter java-version. And once we enter that, we see that yes, indeed, it is installed. So we are good to go. In this movie, we'll be installing Cassandra with our downloaded tarball file. Before we leap into that, let me just mention a couple additional things. One is that along with being able to install Cassandra through a tarball file, you can also install it from a package manager. And looking here at this page, which is wiki.apache.org/Cassandra/Debian packaging, you can see the steps for installing Cassandra through a package manager. In addition, if we go to Planet Cassandra and we go to the page here, which is planetcassandra.org/Cassandra, which is where you would download the DataStax Community Edition from, which is free and includes some additional items. So along with Cassandra, you also get some bonus items. And then down here is the part I really wanted to point out, which is the installation guides. For the various operating systems, you have instructions on installing for a tarball or a package manager. Very nice options that you have here. I would like to point out that although you see Mac and Windows on the list here, you probably wouldn't want to use either of those operating systems for production, because for production, it's really Linux that is the norm. CentOS, Red Hat Enterprise Linux, Debian, Ubuntu, one of those are normally used as the operating system for production. Let's go back to our virtual machine and go ahead and install our tarball file. In terms of where does it go, it's really completely up to you. Wherever you unzip that tarball file to is where Cassandra will be installed. Let's go ahead and do that. I'm going to do CD and hit enter to go up to my default home directory. And in here, let's make a directory named Cassandra. We can name this directory anything we want, but Cassandra makes sense. So mkdir space Cassandra. Enter that. And then let's go inside of that directory. CD Cassandra. And then inside of here, we're going to go ahead and move our tarball file over to here. mv space tilde/downloads. I pressed the tab key so that I didn't have to type the whole name of the directory there. And then the name of the file that I'd like to move is our tarball file. So if I start typing in the name of it, Apache, and hit tab, it'll go ahead and type in the rest of it for me. Space, and then dot, because I'd like to move the file to this directory. I'm going to hit enter. If I do an ls, I'm going to see that it's now here. And let's go ahead and unpack this. So we'll do tar-xvzf space Apache, and instead of typing the whole thing out, I'm going to hit tab and then enter. Just takes a few seconds there. Great. If I go ahead and do an ls, we'll see that new directory now exists, the one that you see there in blue. And if we'd like to go inside of it, we can do cd. I started typing the name of it, and then I hit tab, enter, ls. You can see that it's installed and that these are the directories within the Apache Cassandra 2.07 directory. We'll be learning all about these as we go forward. So we've now got Cassandra installed. In this movie, we view the main configuration file in Cassandra, which is called cassandra.yaml. So here in the directory where Cassandra is installed, we have a variety of subdirectories which contain tools and configuration files for Cassandra. Let's take a look in the CONF folder. cd space conf ls to see the contents. And inside of here, I see various configuration files that we'll be learning about as we go forward in this course. The one we'd like to look at right now, and is the main configuration file of Cassandra, is cassandra.yaml. Let's go ahead and enter vim, which is a text editor, and then cassandra.yaml so that we can see the contents of this file. And if we scroll down, we can take a look at a few of these properties. Down here on line 10, I see cluster name. As we'll be learning, when we go to add nodes to a cluster, each of the nodes in the cluster has to have the same cluster name. Let's scroll down a little bit more. Num tokens. This goes back to virtual nodes, and this is where you specify the number of token ranges that you want this node to take on. Scroll down a bit further to line 91. Partitioner. Earlier we learned what a partitioner does, and here we can see that the partitioner that's been set up is murmur3. Scroll down a bit more. We see data file directories. This is where we specify where the data in our database is going to be stored on this node. Let's jump down to line 564. I could scroll down there, or if we press slash and type endpoint _ snitch, jump down to that area, scroll down just a little bit here to find the endpoint snitch property, and you see that it's set to simple snitch. And that's fine for now. Later on in the course, though, when we go to set up our cluster to spread across more than one data center, we'll be coming in and changing this. So what we've been looking at, cassandra.yaml, is the main configuration file for Cassandra. We'll be working with this file as we go forward. There'll be times where we want to come in and look at additional properties, and times where we'll need to make changes. Having taken a look at it, let's go ahead and exit. If you type :Q and hit enter, that's going to go ahead and take you out back to the command line prompt. In this movie, we set up a couple directories that Cassandra needs in order to be able to run. One of them is the directory where data gets written to, and the other is where log entries go. Let's go ahead and create these. At the command prompt, we could be in any directory. Let's put sudo mkdir /var /lib /Cassandra, enter. This is the directory where data gets written to. If you're prompted for the sudo password like I am, it's Ubuntu in all lowercase. Let's go ahead and create the second directory as well. I'm going to press the up arrow so it will bring back what I just last typed. Let's just slightly edit this because the other directory is almost the same. So sudo make directory /var /log /Cassandra. So this is where our log entries get written. Now we just need to set permissions so that Cassandra will be able to write to both of these directories. Sudo chown space -r space $user $group space /var /lib /Cassandra. I'm going to go ahead and hit enter, and then I'm going to hit the up arrow just to save on typing, and then using the arrow keys, modify this to be log so that I'll be giving permissions to that directory as well. Hit enter, and we're good to go. Cassandra will now be able to write to these two directories. In this movie, we learn how to start as well as stop Cassandra. So in order to run Cassandra, we execute the Cassandra command that's in the bin subdirectory. Let's do cd space .. so that we have easy access to the bin directory. If we do an ls, we see that in the Apache Cassandra 2.0.7 directory, there is indeed a bin subdirectory. And if we were to look inside of there, we would see that there's a Cassandra command. In order to run Cassandra, we could do bin /Cassandra. By entering that command, it's going to go ahead and start up Cassandra. It's running in background mode. The other way to run Cassandra is in foreground mode. If you run in foreground mode, which we'll also do, it's a little easier to stop Cassandra. We're doing it the hard way first. So Cassandra is running in the background here. Let's say we want to stop it. So what we're going to do is we're going to open up a new terminal window. So we'll go up here to Dash Home, click on Terminal. And in this new terminal window, what we're going to do is we're going to go find out the process ID for Cassandra. And we have to do this step because we chose to run Cassandra in background mode. PS space AUX space pipe space grep space CASS and hit enter. And if I scroll back up top here, we can see that the process ID, in my case, it's 4409. Yours will most likely be some other number. So what you need to do is simply take note of what that number is. And then back down at the bottom here, at the command prompt, go ahead and do kill and then enter that process ID. So if we do that, that will go ahead and stop Cassandra. Let's now look at the slightly easier way, which is running it in foreground mode. Back on this other window, just to get back to the command prompt, I'm going to do a Command C. If you're on a Windows computer, it's Control C for you. So let's run Cassandra this time in foreground mode. So it's very similar. It's bin/Cassandra. We just simply add a -F at the end of this argument. Go ahead and hit enter. Everything's good. Because we chose to run it in foreground mode by putting in -F at the end of our command, then to stop it, we can simply do a Command C or Control C on Windows inside of this window, and that will go ahead and stop it. So if we do Command C, it says announcing shutdown, and sure enough, it's now shut down Cassandra. If we go back to our other window, and we just want to confirm this, if you hit an up arrow twice to go back to PS AUX grep cas, and you hit enter, you see that there's no process ID. So it is indeed stopped. Let's go ahead and start it back up in foreground mode. We could do this from either window. We just need to make sure that we are inside of the Apache Cassandra 2.0.7 directory. So if we do an up arrow, I'm going to go ahead and start it back up with bin/Cassandra -F. In this movie, we check the status of our Cassandra node. With Cassandra running in one of our terminal windows, let's go into another terminal window, navigate to where Cassandra is installed, because that's where we can get at our tools. If I go ahead and change directory, /Cassandra / Apache Cassandra 2.0.7, since that's where we installed Cassandra, and hit enter. As you may recall, we have a bin directory in here. And within the bin directory, we have a tool called Node Tool. Node Tool has a variety of commands associated with it, the most common one being status. So if we run bin/node tool status, we're going to be able to see the status of our Cassandra node. Let me hit an up arrow just to run that command one more time so we can see it across. Let's try and make it even wider just to be able to see the whole thing. All right, what do we see here? Data Center 1, we see that we have one node. And these lines, I don't think they're especially intuitive, but what's going on here is the U is separate from the N. So the U is up. It's saying that this node is up. And then the N is pointing to these choices and is basically corresponds to normal. So it's saying that this node is up and normal. It's showing us the IP address for the node. It's showing us the load, so how much data, how much Cassandra data it's currently storing. It's saying that it owns 100% of the ring. This goes back to thinking about token ranges and how many nodes you have in your cluster. And so if you had 4 nodes I would expect to see 4 nodes listed here. I would expect each one to have 25% in the owns column because they each own a quarter of the ring. And then the host ID, and then the token endpoint, and the rack. But while we're here, let's try out a couple more node tool commands just for fun. Let's do bin/node tool info -h, which stands for host, 127.0.0.1 to see information specific about this node. So when that runs, we see that gossip is active, we see the load, memory, metrics, the data center name, the rack name, etc. Let's run one more command, bin/node tool and ring. This one will be a little crazy. What's going on here is that it's referring to the token ring with the token range. And because we only have one node, it's responsible for all the tokens. You may recall that by default with virtual nodes, that each node is responsible for 256 token ranges. What flew by was a list of 256 lines, and we were seeing the IP address of the node and the endpoint for each of those 256 token ranges. What was that command again, just to see the status of all the nodes in our cluster? That was node tool status. Let's run that one more time. This is the most common node tool command, and this is how we can see the state of the nodes in our cluster. One last topic in this unit on installing Cassandra and getting it running is where the log file is. Where is the system.log file? Let's open up a new terminal window and let's do change directory /var/log/Cassandra. Do an ls to see the contents of that directory. There it is, our system.log file. If we'd like to see the contents of it, let's use vim. So vim system.log. And if we scroll down, we can see the various events that have gone on since we started Cassandra up. Let's quit out of here. So :q, enter. If we'd like to change where that file gets written to, let's say we did. I'm going to go to this terminal window where we're already at the directory where Cassandra's installed. And let's go down into where our configuration files are, which as you may recall are in the conf folder. And if we do an ls in here, you can see the various files. The one that contains the settings for where our log file gets written is the log4j-server.properties file. Let's take a look at that. Vim log4j-server.properties. You can view that in our text editor. And if we scroll down a bit in here, down on line 35, we see this is where we could specify where that file gets written to. While we're here, let's also note that we can specify the logging level, and we can also specify the maximum file size. So this movie was on how to access the log file, which as we see by default is under var/log/Cassandra/system.log. This unit was all about getting Cassandra installed. Let's go ahead and do a few questions. Number 1, how can Cassandra be installed? A, B, C, or D? If you chose C, that's correct. Cassandra can be installed as a tarball or as a package. Number 2, what is needed in order for Cassandra 2.0 and later to run? Is it A, OpenJDK, B, Oracle JRE or JDK7, C, Oracle JRE or JDK6, or D, JRE 5 or above? I bet you chose B, and that's correct. Oracle JRE or JDK7. Number 3, What is the name of the main Cassandra file? Is it main.yaml, config.yaml, conf.yaml, or cassandra.yaml? It's cassandra.yaml. Our last question, number 4. What command can be used to check if a Cassandra process is running? A, B, C, or D? That is correct. It's B. So once Cassandra is installed and running, how do we communicate with it? CQL, the Cassandra query language, is an option. It's an SQL-like query language for communicating with Cassandra, created to make it easy for people familiar with SQL to work with Cassandra. CQL didn't always exist. It's a newish, high-level query language. Before CQL, we had Thrift. Thrift is a low-level API. It is still currently supported in Cassandra 2.0. That support may be phased out over time because CQL has really come front and center as the way to work with Cassandra, such as to define a database, define a table within a database, insert data, read data, etc. All right, what if instead of doing development sorts of activities, what if we were looking to do administration sorts of activities? In that case, and we will be doing this in our unit on administration, we'd be using tools built on JMX, the Java management extensions, like Node Tool, which we saw briefly earlier. We're going to be spending a lot more time with Node Tool as we go forward. So let's take a look at CQL. Here's an example. For those of you familiar with SQL, this looks familiar. This expression would allow us to retrieve all the rows for the columns named home ID, date time, event, and code used from a table named activity. When CQL was created, it was modeled after SQL because so many people are already familiar with SQL. Like SQL, CQL commands are not case sensitive. However, although CQL looks similar to SQL, it does not have all the same options as SQL due to the distributed nature of a Cassandra database. For example, we don't have joins in CQL. They would perform poorly because of the distributed nature of Cassandra. Let's go ahead and take a look at the commands that we do have with CQL. Let's go into a browser window. Go to www.datastacks.com/docs. Let's scroll down to the current and recent releases section, looking for the CQL for Cassandra 2.0 documentation. Let's click on that. So that takes us here to this documentation that is devoted to CQL. We could certainly read through it, including data modeling and how to use CQL. We can run CQL commands on the command line through CQLSH, which we'll be doing shortly, or we can run CQL commands through a client driver, like the Java driver, which we'll be using later on when we create an application that connects to Cassandra. All right, let's look under CQL reference. And in here, let's expand CQL commands. So if I scroll down, either here on the left or over on the right, we can see the different CQL commands that are supported in Cassandra. If we're interested in any of these to learn more about them, we're going to be using a number of these as we go forward in the course, such as create table. Let's click on it. So now we could scroll down and learn about this command. CQLSH allows us to run CQL commands on the command line. To get into CQLSH, let's go up a directory from where we currently are. Now, in the directory where Cassandra is installed, in the bin directory, we can call on CQLSH. Now, from the command prompt, we can see that we're inside of CQLSH. In CQLSH, not only can we run CQL commands, but we can also run CQLSH commands. Let's take a quick look at those. So if we go back to the CQL for Cassandra 2.0 documentation, and over in the table of contents on the left, we previously looked at the CQL commands, which we can run any of. Let's also go ahead and take a look at the CQLSH commands. Let's try out the describe command. Describe cluster, semicolon, and it tells us the name of our cluster that we're connected to, the partitioner that it's using, and the snitch type. Let's say we wanted to know more about CQL or CQLSH command. We can simply enter help, gives us a list of all the commands, and then if we enter help, followed by the name of the command, I thought we'd look up information on Keyspace since we'll be using that shortly. And we can see the documentation on using the create Keyspace command. To get out of CQLSH, we can use the exit command. So I could go ahead and type exit semicolon, or because these commands are not case sensitive, I could do it in lowercase. Just a little bit of trivia for you. If you're running a CQLSH command, the semicolon is optional, but if I was running a CQL command, I would have to have the semicolon. Since this is a CQLSH command, I could leave off the semicolon. What I tend to do is just use a semicolon for all of them. Then I don't have to remember whether to put it in or not. Let's go ahead and exit CQLSH. And we see that we're back at the regular command prompt. So this unit was a simple introduction into CQL and CQLSH, both of which we'll be using extensively as we go forward. In addition, we'll also be using CQL with a client driver when we do the unit on creating applications. Let's go ahead and do a couple questions. Number 1, true or false? CQL has all of the commands that SQL has. Is that true or false? It's false. These two query languages are based on two different underlying database technologies. It wouldn't make sense for them to have the exact same commands. Number 2, CQL stands for A, Cassandra Query Library, B, Cassandra Quotient Library, C, Cassandra Query Language, or D, Cute Quirky Laugh. The answer is Cassandra Query Language. CQL is the query language for working with Cassandra. In Cassandra, we call databases keyspaces. So kind of like how in some other database management systems, you might hear the word schema used to reference a database. In Cassandra, we use the word keyspace. Within a keyspace definition, we can define tables. So in this diagram, you see an example of a keyspace with 3 tables inside of it. When you install Cassandra, you actually already get a couple keyspaces. These are system keyspaces. Let's say we wanted to go take a look at those just for fun. Let's go to the command line, and we need to go into CQLSH. We're going to be able to use the describe command to do this. Do you remember how to get into CQLSH? In the directory where Cassandra is installed, you're going to enter bin/CQLSH. We know we're in there because of the command prompt. Now let's enter describe keyspaces. This will give us a list of any keyspaces that currently exist in our cluster. We see that there's 2. One's called system and one's called system traces. Let's say that just for fun, we'd like to see what's inside of them. We can do that using a command called describe key space without the S, system. And then if I scroll back up, see a list of all the tables that are defined in that key space. And what we'll also see at the beginning of this is the key space definition. There it is. So here's the key space definition. And then inside of it, when I was scrolling back up, we were taking a look at all the tables that are defined in that key space. Let's create a database by defining a key space. We can create a key space through the create keyspace command. Let's take a look at an example. Here we have create keyspace, the name of the keyspace, in this case, vehicle tracker. This is going to be a database for our rental car company to be able to track the location of the rental vehicles. The keywords of with replication, class of either network topology strategy, which means your database can be spread across more than one data center, which is what you normally want to use, or simple strategy, which would limit the database to only being in one data center. So in general, you want to use network topology strategy. And then we need to specify the replication factor. For each data center, how many replicas of the rows of the data in the key space are we going to have? In this example, it's showing that in data center 1, we're specifying 3 replicas in that data center. And in data center 2, we're specifying 2 replicas. In order to do this, you have to have at least 3 nodes in data center 1, and you would have to have at least 2 nodes in data center 2. Later on in the course, we are going to have a cluster with 4 nodes. We'll have 3 nodes in data center 1 and 1 in data center 2. Right now, we just have a single node in our cluster. So what we're going to do initially is we're going to specify simple strategy with a replication factor of 1. This is something you might see people do when they're just starting out learning Cassandra, but ultimately, you're going to want to be using network topology strategy and then specifying for each data center how many replicas you're going to have. Let's go ahead and create a key space. In our virtual machine, we've got Cassandra running, and we're in CQLSH, and we want to create a key space. Let's start typing create key space. You could type this out by hand, or you could hit the tab key and it will autocomplete for you. And then we need to specify a name for our key space. We're going to put vehicle_tracker. The other command, create key space, is never case sensitive, the CQL commands themselves, but the key space names are potentially case sensitive. The easiest thing to do is to just name your key space in all lowercase. But if for some reason you think, no, I really want it with a capital V, what you need to do in that case is you need to put quotes around this, because if you didn't put quotes, it would go ahead and lowercase the name. If you do use quotes because you think, gosh, I really want to have a capital letter in there, then whenever you reference the key space, you will also need to use quotes. So if you were maybe now going to go and define a table in the key space, you would need to use quotes around the name. I recommend that you make it easy on yourself and just always name your key spaces in all lowercase. That way you don't have to use quotes. You don't have to worry about the case. I need to put 1 space in there, and then I can press tab. So it'll go ahead and type in with replication for us. And for the class, we could do network topology strategy, or what we're going to do right now is simple strategy. So if you start typing that in and press tab, it'll autocomplete, comma, space, tab to have it type in replication factor for you. And because right now we just have 1 node, we're going to specify a replication factor of 1. Let's finish this up. Put a closing curly brace, semicolon, enter to go ahead and create our key space. What if we want to check to make sure that key space was actually created? Do you happen to remember that command from earlier? Describe key spaces, semicolon. And if we go ahead and run that command, we can see the vehicle tracker key space was created. Do you happen to remember what command to run if you wanted to see the definition for that key space? Describe key space without the S, and then the name of the key space. I'm going to press tab, semicolon. You can see the definition. So we have a key space. In this movie, we talk about how we can delete a key space. So if for some reason you don't want the key space anymore, you can use the drop keyspace command, and then you would simply put the name of the keyspace that you want to get rid of. I don't want to drop our vehicle tracker keyspace. If you did drop yours, you'll want to recreate it. If maybe earlier you accidentally made some keyspaces you don't want, you can go ahead and clean them up with the drop keyspace command. Get rid of that since we don't want to delete that. And then to check to see that the keyspace has been deleted, you could use the describe keyspaces command. And if you had some extra keyspaces that you've now deleted, they should be gone. Let's do a few questions for this unit on how to create a database, which, as we learned, is actually called a keyspace in Cassandra. Number 1, the name of the strategy that allows a keyspace to span across more than one data center is called A, local strategy, B, data center strategy, C, simple strategy, or D, network topology strategy. Correct answer is network topology strategy. Number 2, the name of a keyspace is never case sensitive. Is this true or false? That's false, because even though the CQL commands themselves are never case sensitive, the name of a keyspace can be, because Cassandra will take the name that you've specified whenever you reference a keyspace, and it will lowercase it unless you put quotes around it. So it really is case sensitive. If you, for some reason, choose to put capital letters in the name of your keyspace, then you're going to need to reference it with quotes. Last question. The replication factor has to be the same for all of the data centers referenced in a keyspace. True or false? False. You could specify a replication factor for your keyspace in data center 1 of, let's say, 3 replicas. Maybe you have another data center, you treat it sort of like a backup data center, and maybe for that one you decide to have a replication factor of just 2. So you can definitely specify for your keyspace, your database that spans across more than one data center, how many replicas are going to be in each one. All right, we have a lab. The labs are here so that you can test your new skills. We do need to do the labs because all of the exercises build as we go through the course. The way that the labs work is that on the next slide, I'll show you what the steps are. And then what you'll want to do is pause the movie on that slide so that you can go do the lab. If along the way, when you're doing the lab, if you get stuck somewhere, what you can do is you can then play the movie and it'll show me doing the steps in the lab so you can get caught up. Let's go ahead and take a look at the steps for the Unit 5 lab. Number 1, we're going to define a keyspace named home security with the replication strategy of simple strategy and a replication factor of 1. So that's the first thing you're going to do. Then you're going to use the describe command to see a list of all the keyspaces defined in the cluster. Then you'll see that your home security keyspace is in the list. Then you'll use the describe command to see the definition of the home security keyspace. So go ahead and pause the movie so that you can do these steps. And then, like I said, if you get stuck somewhere, you can play the movie to see me doing the lab. To create the keyspace, I'm going to use the create keyspace command. I'm going to name this home security. We're going to press tab so that it'll type in with replication equals class for me. And in the steps, it had said to use the simple strategy, comma space, tab. So it types in replication factor 1. Later on in the course, we're going to be changing the definition of the keyspace. We'll be using a higher replication factor, and we'll be using network topology strategy. For now, though, we're going to do this while we have just a single node in our cluster. And then the step said to use the describe command to check that the keyspace has been created. So I'm going to use describe keyspaces. There it is. And then this step said to view the definition of that. So I'll do that with describe key space, and then the name of the key space, semicolon, and there I see the definition. That's the lab, creating the key space and then checking to see that it's there. So in this movie, we'll start creating a table. A table can be created in Cassandra by using the create table command. Here's an example. This is a table that we'll be creating over the next few movies. We'll be naming it activity, and it'll be storing the activity of our home alarm systems. Also, to learn about is the drop table command. If you happen to make a table that you no longer want, you can use drop table to get rid of it. As we go to start creating our table, there's one other thing we need to know about, and that's the use command. When we're in CQLSH, we need to tell Cassandra which key space it is that we're trying to create the table in. So we can do that by specifying use and then the name of the key space that we want any subsequent CQL commands to be for. All right, so here we are. Cassandra's running. We're inside of CQLSH, and we want to start creating a table that's going to be in the home security key space. So let's go ahead and enter use home _ security. Once I enter use home security, you can see from the prompt that I'm not only in CQLSH, but I'm also in the home security key space. Let's start typing in the create table command. We're going to be naming this table activity. And then as we go through the following movies, we'll be learning about and defining this table. So we'll be learning about additional topics such as how do we define columns in the table. Imagine that we'd like to define a table with this data in it. We'd like to have a home ID column that's going to have text values, basically the home IDs in it. Column name date time that's going to have date timestamp values inside of it. So basically, when did an event happen with that home security alarm system? An event column, in which case we'll have text to describe what was the event that happened. And then finally, a code use column. It's very common with home alarm systems that you have at least one code for generally the homeowner to set the alarm or disarm the alarm. You might also have another code for guests or staff, such as a cleaning person. And you notice in the code use column that some of the records don't have a value. That's perfectly fine. You can definitely do that in Cassandra. You don't have to have values for all of the columns. Let's define this. What we could do is for our activity table that we're in the midst of defining, we could go ahead and create column names of home ID, date, time, event, and code used. And then what we also need to specify is the type of data that can go into these columns. I've got a data type of text for home ID, timestamp for the date time column, text for the event column, and text for the code use column. There are other data types. Let's take a look at the list here. Along with text and timestamp both being very common, other common data types include Boolean, int, and varchar, which is actually the same as text. If you'd like to get detail on these different data types, you can take a look at the CQL documentation. There's a list of them in there with a description of each one. Let's go to where we're defining our table and put in these columns. So I'm going to hit enter to have a new line. This statement won't be completed until I type a semicolon. So if you'd like to do a new line with me, no problem. Let's put in home _ ID, space text, comma, date time, space timestamp, comma, event space text, comma, and code used, space text. All right, so these are the columns and the data types that we'd like to specify for this table. And in the next movie, we'll continue creating this table. The next thing we're going to specify as we define our table is a primary key. Like in relational databases, a primary key in Cassandra is for having a way to uniquely identify a record in a CQL table. In our table, if we were to look at perhaps the home ID column, we would see that there's more than one record with the same value. So we can't just use that column, but what we could do is we could use a combination of the home ID column and the date time column. So we're going to do that. We call this a compound primary key. And what we'll do is we'll specify the home ID column and the date time column so that we'll have a way to uniquely identify each row in our table. We'll be putting in this code shortly. Before we do that, just want to mention one little thing. If you happen to be defining a table where you were going to only specify one column as the primary key, so you could write it as you see here, so primary key and then in parentheses the one column, or another way to write it, and you might see some people doing this. So with the definition of the column, the phrase primary key is added right there. Let's go put in our primary key definition. So in our virtual machine, I'm just going to go ahead and hit enter here. And let's type primary key. And this is going to be a compound primary key, the home ID column, and the date time column. So this is how to define a primary key for our table. As we continue in the next couple movies, we'll be finishing up the definition of our table. In this movie, we talk about recognizing a partition key in a table definition. As you may recall from the unit on Cassandra's architecture, the partition key is hashed by the partitioner to determine which node in the cluster will store the partition. Here's our table, our activity table of data. Here's the partition key. Here's our cluster with our nodes. And the partition key value gets hashed by the partitioner. And then that value generated by the partitioner determines where that row of data gets stored on the cluster, which node it goes to. In a table definition, the partition key is the value in the primary key definition that is the value before the first comma. So in the case of this definition, the partition key is the home ID. If there's just one column listed for the primary key, it is also the partition key. How the data gets stored internally is that all of the CQL rows that have the same partition key value get stored in the same partition, which also happens to be called a row key. So a partition and a row key are one and the same. Row key is the old name. Partition is the newer name. The reason for the word row key is that in the old days, before CQL, a partition was referred to as a row. To try and make it so there's not so much confusion between the use of the word row, internally, the internal row that was called a row key, we now call it a partition. That's to differentiate from CQL rows. If you're talking with somebody and they're talking about a row in Cassandra, you very well may have to ask them, are they talking about a CQL row or are they talking about a thrift row? As you may recall, before CQL, there was an API called Thrift. With the Thrift API, you looked at and thought about things as you see over here on the right. In the data modeling unit, we're going to look more at how things are stored internally, and it's going to be interesting for us to understand partition keys. This unit was on how to recognize a partition key, and if we were to flip over to our virtual machine here, which one of these is the partition key? Home ID, because it's the first value before that first comma there. Let's talk about the option to specify a descending order for the CQL rows in your table. This is optional. If you don't specify, then the order will be ascending. In our case, however, we're going to want to have our rows organized by date time so that the most recent records are on top. Because in our application, we're anticipating that an end user is going to want to see the most recent events for their home alarm system. So we can do this with the clause with clustering order by, specifying the column, and then specifying DESC for descending. And as I mentioned, if you don't specify anything, then by default it's ascending. Specifying descending causes writes to take a little bit longer because the cells, those CQL rows, are inserted at the start of a partition rather than being added at the end. But it does improve read performance when descending order is needed by an application, which is our case. We are going to be putting this in. And then just one other thing to mention, although some changes can be made to an existing table, such as adding a column through the alter table command, like alter table activity, add a status column with text as a data type, changing the clustering order of a table is not an option. It would require the rewriting of all the table's data on disk in a different order. So to change the clustering order of a table, the table would need to be deleted and then created with the desired clustering order. So this is something to think about up front as you're defining the table. Let's go do it. You'll want to watch out for syntax and typos for this in particular. What we need to do is go ahead and put a closing parentheses, and then we put this clause, which is with clustering order by, and then in parentheses, date, time, space, DESC, semicolon. That is the last thing we're going to do to define this table. Let's go ahead and hit enter. The table will get created. So no news is good news. Our table was made. And if we want to just confirm that, we could do describe table, name of our table, which is activity, enter, and we see our table definition. We'll be learning about some of these additional properties as we go along. So this was on specifying a descending clustering order, which you totally have the option to do. You do it with the with clustering order by clause. And if you don't specify it, it'll be ascending. So in this unit, we learned how to create a table using the create table command. We also learned about defining columns and data types for those columns, how to define a primary key, how to recognize a partition key, and the option to specify a descending clustering order. Let's do a few questions. Number 1, if the primary key for a table has more than one column specified, what is it called? Is it A, a composite primary key, B, an open primary key, C, a compound primary key, or D, a simple primary key? If you chose C, you are correct, a compound primary key. Number 2, which of these are CQL column data types? I don't expect you to have memorized all of the data types for columns in a table, but why don't you pause the movie and go look it up? It's D, text, varchar, and int. Last question. If defining a primary key as primary key, and then in the parentheses, meter ID, date, timestamp, which column or columns contain or contains the partition key? Is it A, meter ID, date, timestamp, so basically the 3 columns, or is it B, meter ID and date, the first 2 columns? Is it C, which would be the first column, or is it D, none of the above? The first column, meter ID. In this lab, we create a second table named home. This will be for storing the home and owner contact information for each home that the home security alarm company monitors. So let's go through the steps. Number 1, you're going to want to make sure that you're in the home security key space when you go to define the table. Number 2, you're going to create a table named home with the following columns, all with the data type of text. Number 3, you're going to specify the home ID column as both the primary key column and the partition key column. And then finally, you're going to use the describe table command to view the table definition. I recommend that you go ahead and pause the movie so that you can do the lab. So if you got stuck anywhere, I will go ahead and walk through doing the steps. Step 1 was to make sure that we were in the home security key space, and we are. I can see by the command prompt there. And then we're going to start creating a table named home. We'll use the create table command, call it home. And then I'm going to put an opening parentheses. And then we're going to start entering in the name of the columns that we want. So home_ID. All of these are going to have text as the data type. Address, city, state, zip, contact name, phone, alt phone, phone password, email, main code, and guest code. And then for primary key, we're going to use the home ID column. Because it's the only column that's listed for primary key, it will also serve as a partition key, which, as you recall, determines which nodes the rows of data get stored on. Closing parentheses and semicolon. I'm going to go ahead and hit enter. I'd like to make sure it got created and check my definitions. So we're going to enter describe table, the name of our table, which is home. And there's our definition. We'll be using this table and the other going forward. We'll be loading data into them. And then we're going to be creating our applications that interface with the data in these tables. Now that we have a couple tables, we'd like to be able to write data into those tables. There are a few different ways to write data to a Cassandra table, including using the insert into command. We'll be using this first. This is a CQL command that's handy for writing a single row. It can be used in CQLSH on the command line or via client driver that supports CQL, such as the DataStax Java driver, which we'll be looking at and using in our unit on creating an application. Another option that we'll also be using is the copy command. This is useful for importing data from a CSV file. There's also the option to use the copy command to export data. If you were looking for some reason to export data from Cassandra out into a CSV file, you could use the copy command for that as well. And then one more option for writing data to a Cassandra table is using the SS Table Loader tool. This is commonly used for bulk loading, and the way it works is it streams SS table files to a live cluster. SS table is the file storage unit for how Cassandra stores data on disk, and we'll be looking at that format later on in this unit. In order to use SS Table Loader, the data does need to be in the SS table format. Let's go on to the next movie to use the insert into command. The insert into command is for writing a single row of data. This might come from a client application. Perhaps you have a web application page where the end user enters in a record, or you might use insert into on the command line, as we're going to do. To use insert into, the name of the table that the data is going to be written to, the names of the columns that the data is to go into, and the data that's to be written all need to be specified. Once you've written data to the table, you can read it by using the select command. Similar to the select command in SQL, you can do select star from activity. So this would bring back all the rows and all of the columns of our activity table. Or if you wanted to bring back data from just certain columns, you could specify those in your select statement. So in this case, we're saying, I just want to bring back the data in the home ID, date time, and event columns from the activity table. Let's go ahead and use the insert into command to write a row of data to our activity table, and then we'll use the select command to read that row. Let's go over to our virtual machines. Password of Ubuntu, all lowercase. We have Cassandra running. We're in CQLSH. We're in the home security key space. By the way, just pop question, what if you weren't here? How would you get back in here? Like maybe you had exited CQLSH. you would be here in the directory where Cassandra is installed, and you would enter bin/CQLSH. And then how would you get back into the key space? Use, and then the name of that key space. Let's go ahead and use this insert into command. You can either type it in with me, or if you don't want to do that much typing, you can go to your working files folder and you could grab the code that's in the insert into activity.txt file. I'm going to go ahead and type it in. People typing things in general helps them learn and absorb. So let's go ahead and enter insert into. You remember that the case of the CQL commands doesn't matter, so it could be upper or lower. Then the name of the table that we want to insert the data into, which is activity. And then in parentheses, the names of the columns that we want to put data into. So in our case, we want to write to the home ID column, date time, event, and code used. You don't have to write to all of the columns. And then space values, then open parentheses, single quote, the value that we want to put into that column, which in our case it's a home ID, so it's H, and then 014747777. It just happens to be the ID of the home that we're entering data for, comma, and then in our date time, this is a timestamp data type that we specified earlier. 2014-05-21 space 07:32:16 was the time that this event happened, closing a single quote, comma, space, single quote. And then the event that happened was the alarm was set. So we'll enter that. And then finally, the code used was 5599. Closing parentheses and semicolon. No errors is good. If we'd like to now go ahead and actually view the contents of that table, we can do that with the select command. So let's do that. Select star from activity. We can see that our row was written in there. What if we had a lot of columns and we just wanted to bring back a few? I'm going to do an up arrow to bring back the command I last ran. Then I'm going to edit it because I'd like to just bring back a few columns. So home_ID, comma space, date time, comma space, event. So I just want to bring back the data in those three columns. Let's hit enter. And that's exactly what happened. That was using the insert into command, and it's very handy for writing a single row of data. The copy command can be used to import data from a CSV file to a Cassandra table, or export data from a Cassandra table to a CSV file. In our case, we're interested in importing data. Let's take a look at the CSV file we're going to be bringing data in from. You can see a screenshot of it here. Within the CSV file, there's a header row. This is optional. This header row has the names of our columns, home ID, date time, event, and code used. And then for each row, the values are separated by the pipe character. Let's take a look at the code we would use to bring this in to our activity table. The copy command, the name of our table, which is activity, the names of the columns in the activity table that we want to bring data into, so home_ID, date time, event, and code used, and then from, and the path and the name of the file that we want to be bringing in the data from, so where your CSV file is located and what it's named, and then the with clause to specify whether there is a header or not. In the case of our file, there's a header row, and the delimiter that's separating the values in your file, which for us is the pipe character. Let's go take a look at our CSV file we're going to be bringing in and then bring it in using the copy command. So let's go on over to our virtual machines, and I'd like to leave the CQLSH window as is because we'll be using that shortly for running the copy command, but I would like to open up another terminal window. we're going to look at our CSV file. So on the command line, let's enter vim, and then part of the path to our CSV file has a space in it, so we need to use single quotes. So in between those single quotes, let's put in the path, which is desktop/files. So this folder over here, it contains our CSV file. In the files folder, in the chapter 7 folder, there's a CSV file called events.csv. We'd like to take a look at the contents of that file. So let's hit enter. And yes, very similar to the screenshot we were just looking at. Our CSV file has a header row with the column names and then subsequent rows with the values all separated by the pipe character. I noticed down here that some of these rows don't have a code use column. No problem. That's perfectly fine in Cassandra. And if it happened to be that within one of these rows there wasn't a value in the middle area, that's fine. You would just see 2 pipe characters if there wasn't a value for a column. Let's get out of here and import this data. So let's do escape:*Q, enter. Let's go on over to our CQLSH window and let's start entering the copy command. Copy. What do we put next? Name of the table, names of the columns in the table. So let's put parentheses, home_ID, comma, date, time, comma, event, comma, code_used. And then if you recall, the next thing is from, and then the path and the name of the CSV file. So in single quotes, we'll go ahead and enter that. We're on Linux, so the full path would be /VM1/chapter/7/events.csv, and then our closing single quote, and then with header equals true, because we do have a header row in our file, and delimiter equals, and we have to specify our delimiter, which for us is a pipe character, so in single quotes, semicolon. Go ahead and enter that to import those rows. I see that it imported 32 rows. If you have a typo in yours, you can maybe just compare yours to mine and figure out where your typo is. Also, in the working files folder, I did provide a file with the code, so you could just copy and paste it in here. That file is the copy activity.txt file. How can we check to see that those rows were imported and take a look at them? The select command. Select star from activity. Scroll back up, I can see all of our rows. A little thing to note is that it says 32 rows. I remember that we already had 1 row from using the insert into command and that we just imported 32. Well, what happened is one of the rows already was in there. Basically, one of the rows had the home ID and the date time that matched one that was coming in through the CSV file, so it simply overwrote it. So this is using the copy command to import rows from a CSV file. Let's take a look at how our data is stored internally in Cassandra so that we can have a better understanding of how Cassandra works. So in CQL, a row's primary key value is what makes it unique. So in the case of this row of data here, when we view it in CQL, how we reference it is through the primary key. Internally, a partition key value is what makes an internal storage row unique. Looking at the data or views in these 2 places, what happens is that first column of data that we're viewing in CQL, those are partition key values. So what happens is all 3 of the rows that we see above here are actually stored internally as one partition, as one row key, as we used to refer to it. So you can see the partition key here in the first cell, And then in this cell, this is basically the data that's in the first CQL row. And the next cell, the next row's data, so on and so forth. To get a look into how this works, we can use Cassandra CLI. This is the command line interface that was used by Thrift, which is the API that we had before we had CQL. We'll go into Cassandra-CLI. Once in here, we'll specify use home security so that we can communicate with that key space. And then list activity is how in CLI you would specify that you want to view the contents of a table. And then it'll go ahead and display, based on partition key, the contents of the table. So let's go over to our virtual machines. Let's leave the CQLSH window since we'll be using that a bit later. But in our other terminal window, or a new one if you'd like, let's go ahead and open up Cassandra-CLI. So in order to run it, we need to reference it down in the directory where Cassandra's installed. So let's do cd space Cassandra / Apache Cassandra 2.0.7, enter to go to that directory. And then from here, let's put bin / Cassandra-CLI, and then I'll go ahead and open it up. So this is the command line interface that we had for talking to Cassandra before CQLSH. This is what we had before then. Let's do use home security so that we're referencing that key space. And then let's do list activity to see the contents of that table. And I'm going to hit the up arrow just to go ahead and run that one more time so it'll be easy for us to look at. If we were to scroll up here, what you're doing is you're viewing the contents of the activity table as it's stored internally, which is based on the partition key. So you have the partition key, which designates the internal storage row, and then you have the contents of the cells inside of that row. Let's go ahead and scroll down to the last one, the one that was 800999943, just because we could actually see it in both places. So you can see it over here in the CQL view, and then you can also see how those values are stored internally. Luckily, we no longer have to think and write in the view you're looking at in Cassandra-CLI. It was involved, it was a bit mind-bending. Nowadays, the norm is to interface with Cassandra through CQL, which is a much more friendly, easy, familiar view of the data. But it is helpful to understand a bit about how it's stored internally. Specifically that all of the data for your partition is stored in one row, and that partition of data cannot be broken across the different nodes. So this quick look into how data is stored internally will be helpful to us as we get into the data modeling unit. Let's take a look at how data is stored on disk. This is a topic that will help us gain a better understanding of how Cassandra works. When data is written to a table in Cassandra, it goes to both a commit log on disk for playback in case of node failure, and to memory, which we call memcache. Once the memcache for a table is full, it is flushed to disk as an SS table. For each table on each node, there's a memcache. Where the SS tables are stored on a node is by default in the var lib Cassandra data directory. If desired, this location can be changed in the cassandra.yaml file. So here we have a screenshot showing under var lib Cassandra, the data directory. And then under the data directory is going to be a list of the key spaces. And then within a given key space, there's going to be a list of tables. Example here, we see the activity table. In that directory, we're going to see the data file as well as the files that support it. What we can also do is through SS table to JSON, through this little tool, we can actually see the contents of an SS table. Let's jump over to our virtual machine. We exited out of Cassandra-CLI from the previous movie. We're going to be needing this window in this exercise. Let's also open up another terminal window. And in here, let's go find the location for our SS tables. cd /var/lib/Cassandra. In here, let's do an ls. We see the directories for commit log, data, and save caches. Let's go into the data directory, cd data, ls, and we see our key spaces. There's a directory for each key space for the data within each one of them. Let's go into the home security key space and ls to see the contents of it. And we see a directory for each of the tables that we define in that key space. We'd like to see the contents of the activity directory. Let's just go ahead and do an ls. Oh, and there's nothing in there. Why is that? That's because the memcache, the memory for this table on this node, is not full, so it hasn't flushed the data to disk. This is something that we commonly let happen automatically, but we can also do manually. Let's leave this window for just a moment, go back over to this other terminal window where we're already at the directory where Cassandra is installed, and let's go ahead and run a command to flush the memcache. So let's enter bin/nodetool, flush, and let's specify the home security key space. So what it'll do is it'll flush the memcache for all the tables in this key space. In our case, that's the activity table and the home table. Go ahead and hit enter. So it's flushed those to disk. So now if we go back to our window over here and again do ls activity, aha, now we have files in here. What was happening is that the data was all still in memory, but by us flushing it to disk, it's now on disk. Let's say we want to go look inside the data file, just for fun. Back in our other window, since we're already here at the Cassandra directory, let's go ahead and enter bin/ss_table-to-JSON. So this is this little tool we can use to see the contents of an SS table file. And then we need to put in the path and the name of the SS table file that we want to view the contents of. So that's going to be var lib Cassandra data home security /activity /home _security -activity -jb -2 -data.db. Now, some of you may have JB-1 or JB-2, JB-3, etc., depending on if you dropped a table earlier. So in the unit where we were creating tables, I had dropped a table, recreated it, and so that's why I'm seeing a 2 here. You're going to go ahead and put in the name of your data file, whatever it may be, whether it's 1, 2, 3, 4, 5, etc. Let's hit enter on this so we can see the contents of our SS table. And there it is. Going in and looking at the contents of your SS table file is not a normal thing to do, really. It's interesting. Helps give us a little insight into how Cassandra stores our data on disk and allows us to see the contents of the data file if we want to. So this movie was on seeing how data is stored on disk, and really we did this to get an insight into Cassandra and get a little deeper knowledge about how it works. This unit was on inserting data as well as how Cassandra stores that data. Let's do a few questions. Number 1, which command is for inserting a single record into a Cassandra table? Is it A, write, B, copy, C, insert into, or D, write once? If you chose C, insert into, you are correct. Number 2, which command is for inserting data from a .csv file into a Cassandra table? Is it A, write, B, copy, C, insert into, or D, write once? If you chose B, copy, you are correct. Number 3, Which command line tool can be used to view, at a low level, how data is stored in Cassandra? Is it A, Cassandra CLI, B, view inside, C, look in, or D, inside Cassandra? If you chose A, Cassandra CLI, you are correct. Cassandra command line interface is the old way for communicating with Cassandra on the command line. This was used by people using the Thrift API before we had CQL. What do we use nowadays in general for communicating with Cassandra? CQLSH. Last question, number 4. By default, where are the Cassandra SS tables stored on disk? Is it A, home/data, B, var/lib/Cassandra/data, C, data/Cassandra, or D, cast/data? If you chose B, you are correct. And I'm going to ask one more follow-on question. What if you wanted to change that location? What would you do? You would change it in the cassandra.yaml file, in the configuration file for that node. Let's do this lab on inserting data. The first step is to use the insert into command to insert a record into the home table that's in the home security key space with the following data. The second step is to use the copy command to import the records that are in the chapter 7/homes.csv file into the home table. We'll be using this data as we create an application in a later unit. And then finally, number 3, flush the contents of the memcache for the home table on this node to disk to be able to see the SS table files on disk. I do want to mention one thing about step 1. There's a lot of opportunities for typos there just because it's so much typing, that I did provide a text file with the code inside of it if you do decide to copy and paste that in. Go ahead and pause the movie so that you can do the lab. If you get stuck somewhere along the way here, you can then play the movie and I will do the steps as well. In the window where I've got CQLSH running, I'm in the home security key space. I'm going to go ahead and use the insert into command. Need to put the name of the table, which is home. And then the next thing in parentheses is to put the names of the columns that we want to insert data into. So home ID, address, city, state, zip, contact name. And these, of course, need to be spelled the same as columns that are actually in the table. You may recall that if you wanted to see the definition of the table, you could do describe table and then the name of the table, which is home. So I've got the names of the columns that I want to put data into, and then the values keyword, and then in parentheses, in single quotes, the values that I want to insert into each column. 518 Crestview Drive, Beverly Hills, California, 90046 for the zip code. Jed Clampett as our homeowner. His password is oil. And his email is jclampett@bhb.com. The main code 5599 and the guest code 7778. I'm going to go ahead and try hitting enter. That went in. If I did have any typos, I could troubleshoot them and fix them. And in that case, I could just hit the up arrow to edit whatever I last typed, or could go to the text file and just go ahead and copy that and paste it in. So how could we see what's in the table? We could do a select star from home. If we just wanted to bring back a few columns, what could we do? We could just put the names of those columns. So let's say I just wanted to bring back what's in the home ID, address, contact name, phone password, and phone columns from our home table. So that's how we could put in records one at a time. Another option we have is using the copy command to import records from a CSV file. And that's what we're going to do next. We're going to go take a look at this CSV file. We could use Vim, which is a text editor, to do that. I'm going to do Vim and then the path to and the name of the CSV file that I want to take a look at. So since I'm down in this other directory, I'm going to do /home/vm1/desktop files/chapter /7 homes.csv. And I do have single quotes around the whole expression because of the space in the chapter 7 directory name. So I see that there's a header row. I see that all the values are separated by a pipe character. I've got 5 rows in here. Let's go ahead and exit out of here. And what I'd like to do now is bring those records in to our home table. So let's go back to the CQLSH window, and we're going to use the copy command. So we need to say the table that we want to bring the data into. Our table is named home. The names of the columns. To save just a little bit on typing, I'm going to do an up arrow from what I last ran in here when we did our insert into command. And I'm going to just edit it a bit. That way I won't have to retype the names of all those columns. So I'm going to get rid of the insert into. So it'll be copy space home, name of the table, and then the names of all the columns. And then instead of the word values, it's going to be the keyword from. And then instead of literally putting in all of these values, we're going to put in the path and the name of the CSV file. So this is going to be from /home/vm1/desktop/files/chapter7/homes.csv. And then the last part of this expression is going to be with header equals true and delimiter equals our pipe character. Could you use a character other than the pipe character in your CSV file and then specify it here? Absolutely. Let's go ahead and run this. Okay, so I have a typo in here. No problem. Let's do the up arrow. I see what it is. In that file, if we were to go and look at that again, there is a column alt phone. So I need to get that in here as well. Right here, one more column to add. Alt phone, phone password, email, main code, and guest code. Okay, great. So now I should have the appropriate number of columns listed here to match the records that are coming from the CSV file. Let's try enter on this one. 5 rows imported. If we do a select star from home, you can see those in there. Or if I do up arrow again, there was the choice of select with just certain columns, a little tidier there to view. And then the last step in our lab was to view the data on disk. Well, right now it's in memory. It's in memcache for the home table on this node. And as you may recall, if we want to tell it to go from memcache down to a physical file, we can do that with the flush command. So back in this window, let's get out. So escape:/Q. And then back in the directory where Cassandra is installed, it's bin/nodetool flush. And then security makes it so it just flushes the tables for this key space. And if I wanted, I could be even more specific. I could say, well, actually only the home table within that key space. Let's hit enter. Give it a couple seconds to flush. So now let's go back to where the files get written, which as you may recall is var lib Cassandra data, and then the name of the key space, and then the name of the table. So if I go ahead and do an ls here, I see the 2 tables listed. And if I ls the home table, I should now see data files in there. And we do. And the reason you see those as ones is this is the first time that data has been written down into an SS table. As memcache fills up and another SS table gets created, then you'll see more files listed in here. Each time it fills up, it makes a new SS table and its supporting files. So there we are. We did the Unit 7 lab, which was writing one record with the insert into command, using the copy command to import records from a CSV file, and then finally choosing to go look at the SS table files. In this movie, we start talking about data modeling in Cassandra. When data modeling in Cassandra, it's important to understand the implications of working with a distributed database versus a relational one. The fact that joins do not exist in Cassandra is perhaps the most significant data modeling difference between a distributed database versus a relational database, because the data for a table in a distributed database is spread across the nodes in a cluster based on the token values generated from the partition keys. It would be incredibly slow for a cluster to somehow do joins across multiple tables. As a result, data modeling in a Cassandra database needs to be done in a way so that all the data for a query is available in one table. This is not to say that you can only have one table per database. Quite the contrary, it's common to have many tables, often with denormalized data, so that a query result can be handled by a single table. Instead of data modeling with a data-centric view, data modeling in Cassandra is done by first figuring out which queries will be needed. Then, tables are designed to accommodate the queries so that a query can be answered by a single table. Let's take a closer look at partition keys and clustering columns as we learn about where clauses. As Cassandra is a distributed database with the data organized by partition key, where clause queries generally need to include a partition key. With our previously defined activity table, this query would work. Select star from activity where home_ID equals H014744777. So this would work fine because we're referencing a value that's in our partition key column. And this query would work as well. Select star from activity where home_ID equals H014744777 and date time is greater than this date and time. This would work fine as well. Because when we defined our activity table, when we specified the columns that would be in it, we set the primary key to be home ID and date time. Home ID being the first in the list there is the partition key, so that gets indexed. And date time being a clustering column, because it's also in the primary key definition, it's also indexed. So we can go ahead and include those two columns in our where clause. However, if we tried to run this query, it wouldn't work. And we'll do this hands-on in a moment here so you can see these in action. If we try to do select star from activity where code used equals 5599, this wouldn't work because code used is not indexed. Because it's not in the primary key, its column does not get indexed by default, and so would be extremely inefficient in referencing values of. As a result, Cassandra does not allow the query. We will learn in the next movie how to create indexes for these other columns. First, though, let's go try these out hands-on. Let's jump over to our virtual machines. In the terminal window where you're in CQLSH and you're in the home security Keyspace, let's go ahead and run these queries that we were just taking a look at. So let's do select star from activity where home_ID equals, and you could use any of these home IDs, H014744777, close my single quote, semicolon, press enter. As we expect, it brings back those records for that particular home ID. Let's now add on to that. I'm going to hit the up arrow to bring back the last command I just ran. And let's modify this slightly to add on and date time is greater than 2014-05-22 space 00:00:00 single closing quote, semicolon. And if I go to run this, I expect this to work as well because I'm referencing the partition key, home ID, and then I'm referencing values that are in the date time column, which is a clustering column, which, because it's part of the primary index, is indexed. Brings me those back. Let's try running something that probably won't work. Let's do an up arrow here to bring back what we just entered. And let's modify this to be an code used equals single quote 5599 single quote semicolon. Let's press enter. And it says, I'm not even going to try to run this because that column you're referencing, code used, it doesn't have an index. This could potentially be crazy slow, so I'm not even going to try. So what we'll be learning about next, as you can probably guess, is how to create indexes for these other columns. Let's talk about secondary indexes. By creating an index for columns beyond the partition and clustering columns, values in these other columns can be referenced in where clauses. We call these secondary indexes. For each secondary index, Cassandra creates a hidden table on each node in the cluster. It's important to know that, contrary to indexes in relational databases, creating secondary indexes does not increase the speed of queries in Cassandra. Secondary indexes simply make it so that where clauses that reference values in columns beyond the primary and clustering columns can run. For increasing the speed of a query, instead of defining a secondary index, you could create a table specifically for the query. Here's an example. This table could be created for a query for the homes in a particular state. We've given the table a name. We've set up columns with values. For the primary key, very interesting, you see that state is first. So state will be used as the partition key for this table so that the data will be organized and clustered by state. Then zip. So if some rows have the same state value, then it'll next be ordered by zip. And by default, they'll be ordered ascending by zip. And then finally, to make it so that each record in this table is unique, our primary key has home ID in there as well. Because if we just had state and zip, there might be some that have the same state and zip, but by adding home ID into the primary key, it makes sure that each row in our table is going to be unique. This handmade table provides a performance improvement over an automatically generated secondary index in that the query can get the needed data from just the relevant nodes rather than having to access every node in the cluster, which is what it has to do with secondary indexes. One drawback to creating your own index tables, however, is that you are responsible for creating and updating, as necessary, the data in the handmade table, as opposed to just having Cassandra automatically create and update a hidden secondary index table. Let's create a secondary index. To do so, we can use the create index command, and then we need to come up with a name for our index. The name of the index is not terribly important because it's not something you're going to be referencing in the future. You just have to come up with a name and put one in, and then the word on, and then the name of the table, in our case, the activity table, and then in parentheses, the name of the column within the table that you want to create a secondary index for. Let's create one for the code use column so that we'll be able to run that query that we tried to run earlier to view the homes with a certain ID and a certain code that was used. And then semicolon. So this is all we have to do to define a secondary index. Let's go ahead and hit enter. Now to use it, we don't actually have to call on it by name. I'm going to hit the up arrow to go find that select expression I used earlier, where I was trying to find all the records in the activity table where the home ID was H0147477 and the code used was 5599. Earlier, it told us that we couldn't run it because there was no index on the code use column, but now there is. So if we go ahead and run this same command, we should get results. So that is how to create a secondary index and use it. Let's learn about and create a composite partition key. Composite partition key is where a partition key is made up of more than one column. Let's look at an example. So here, our partition key, formerly known as a row key, is made up of the vehicle ID and a date. Let's take a look at the table we're going to be creating. So for our vehicle tracker application, we're going to be creating this location table. And we're going to have a vehicle ID column, which is going to contain the vehicle ID, a date column containing the date for the data that we're recording, the time, which will contain the time that the location was recorded, the latitude of where the vehicle was, the longitude of where the vehicle was, and then in the primary key, this is the part that's new and interesting for us, we're going to have two values that make up the primary key. The first one is going to be a combination of the vehicle ID and date, and then the second is going to be the time. As you may recall, when you define a primary key, the first item, in this case, vehicle ID and date, because of those parentheses, is what is used as the partition key. Let's talk about why we're going to do this. If a partition might grow endlessly, imagine what if we didn't use date in here? What if we just had vehicle ID and we were picking up on the location of all the vehicles every second? So this partition could grow endlessly, such as with the time series use case, which is a very common scenario for this. Instead of using the value of just one column as a partition key, the values from more than one column, such as an ID and date, can be used to define the partition key. Without a composite partition key for time series data, the partition could grow endlessly. Time series data can be a good candidate for creating a composite partition key. Although the limit for the number of cells that can be stored in a partition is 2 billion, which is a fairly large number, it may be better to define a partition key that does not have infinite growth to avoid the possibility of approaching the limit at some point in time. In addition, all data for a single partition must be able to fit on disk on a node in the cluster. Let's go create this table, and as we do that, we will be defining this composite partition key, and then we'll go take a look at it. We'll look at how the data is being stored internally, and we'll be able to actually see this composite partition key, which we've created. Let's jump over to our virtual machine. In CQLSH, we'd like to create this table in a different key space. We want to create it in the vehicle tracker key space that we defined earlier. You probably remember how to change key spaces. It's use and then the name of the key space that you want to change to. So we'll do use space vehicle underscore tracker. And now by the prompt, we can tell that we are in that key space. Let's go create this table. Create table. We're going to call it location, opening paren, and then we'll go ahead and specify our columns. So vehicle underscore ID, this column can contain text. We're going to have a date column that can contain text, a time column, which can contain a timestamp value. Now in our other table, you can actually see it a bit up here, which was our activity table in our home security key space. We had just one column for this. We just had one called date time, and it was a timestamp data type, and we didn't have an extra date column. The reason that we're creating an extra date column for our location table is so that we can create this composite partition key. So what will happen is each partition will be a combination of the vehicle ID and the date. So basically every day, a new partition will get created for each vehicle. And this is how we're going to stop from just having a runaway partition. Because if the partition was just vehicle ID, it would never end. It would just be an endlessly growing partition. Every day it would get huger and huger with all the location data of every car being picked up on every second. Let's go ahead and finish these columns. Latitude, and that data type will be double, which of course is a number data type. Longitude is also going to be a double. And then primary key. So we're going to have a normal opening parentheses, and then we're going to have an extra opening parentheses, which is going to be our way to combine the value in the vehicle ID column with the value in the date column. So those two will combine to make up the partition key. And then we do also want to have time as part of our primary key definition, because if we only had the first two, there wouldn't be a way to uniquely identify each row in our table. But by providing the time column as well, every row will be unique in our CQL table. We're going to add one more thing to this. Along with the closing parentheses, we're going to add with clustering order by, we're going to put time space DESC for descending, because in our application, when we go to look up where a car is on a certain day, we'd like those rows to come back in descending order so that the most recent is on top. Let's hit enter to create this table. We're going to go ahead and load some rows into there, and these are in a CSV file. So let's put copy location, because we want to load the data into the location table, and then the names of the columns. So vehicle ID, comma date, comma time, comma latitude, comma longitude. We could, of course, also go look at the CSV file before we load the data. From, we're going to put in the path and the name of our CSV file, /home/vm1/desktop/files, the name of the folder on our desktop, /chapter8/coordinates.csv, closing single quote, with header equals true. So if we did go look at that file, we'd see there is a header row in there. Delimiter equals single quote pipe. If we were to go look at that file, which you normally would do, we would see that there's a pipe character between all the values, and semicolon to end that. Let's go ahead and hit enter. 30 rows imported. Let's go ahead and just take a look at this data. Let's do a select star from location. We could go ahead and bring back all 30 rows, or we can use an optional clause in here, which is limit, but limit 3. We'll just bring back the top 3, the most recent 3. Now, let's go take a look at this composite partition key that we defined. In a terminal window, in the directory where Cassandra is installed, let's go ahead and open up CLI, the old Cassandra command line interface. As you may recall, it's bin/Cassandra-CLI. Go ahead and run it. And then let's put use vehicle tracker. So it knows that we want to work with the vehicle tracker key space. And then list location, the name of our table that we'd like to see the contents of. Press enter. It tells us there's 5 rows. And you know, when you see this word rows, it's talking about internal rows. It's really talking about partitions. So if we scroll up, I see that there's a row key for each of our vehicle IDs combined with the date. Another one, another one, another one, another one. So 5 rows, 5 partitions, and the partition key for each of these is a combination of the vehicle ID and what was in the date column. By defining this composite partition key, we don't have to worry about a partition growing endlessly, because there's going to be a new partition key for each vehicle each day. So if we were collecting the vehicle's locations every second, we wouldn't have to worry about an individual partition growing endlessly. Creating a composite partition key, as we've just done, is a pretty common thing to do with time series data. So in this unit, we talked about data modeling in Cassandra. We talked about the fact that there are no joins in Cassandra. We learned more about partition keys and clustering columns. We learned about secondary indexes and how to create them. And we also learned how to define a composite partition key, common with time series data. We've got a few questions. Number 1, true or false? It is common to have denormalized data in Cassandra. As you probably already know, denormalize means that you would have duplicates of some of your data in different tables. Is that true or false? That's true. It's very common. Because we have no joins, we need to have a table that can satisfy a query's request with all the data. So it's very common to have lots of tables for all these different queries. And as a result, it's quite common to have denormalized data, which is no problem in Cassandra. It's the norm. We have cheap storage and a highly scalable distributed database. No problem storing lots and lots of data in there. Number 2, secondary indexes make queries run faster in Cassandra. Is that true or false? That is false. So in many other database management systems, secondary indexes do make it run faster, but not in Cassandra. Secondary indexes in Cassandra simply allow you to query values that are in columns other than the columns that are in the primary key. So if you wanted to retrieve records based on values in columns beyond those in the primary key, you can do that with the secondary index. If you've perhaps set up a lot of secondary indexes and thought that that will make things run faster in Cassandra and found that it doesn't, that's correct. In that case, if you're looking to make things faster by how you model your data, then you want to look at perhaps creating your own tables that satisfy that query, like the homes by state table that we looked at. I might also mention, and we'll talk about this in a later unit, that certainly your hardware choices will also affect the speed of your queries. So that's definitely another area to look at, and we'll talk about that. Number 3, true or false? It is important to remember the name of a secondary index for referencing it in a where clause. Is that true or false? False. All you have to do is define the secondary index, give it whatever name, and then the fact that the index exists allows your where clause that you perhaps had previously tried to run that wouldn't run, allows it to work. Doesn't matter what you call that index, it's just the fact that you have set up an index for a column that then makes you able to use a where clause that references values in that column. Last question. What is used to specify a composite partition key? Is it A, square bracket, B, quotes, C, underscores, or D, parentheses? And the correct answer is parentheses. The Cassandra client drivers allow for communicating with Cassandra through various programming languages. For example, an application could be written in Java, C#, or Python that reads from and or writes to a Cassandra database. Let's go take a look at the various client drivers that are available. So if you'd like to follow along with me, open up a browser window and go to planetcassandra.org/client-drivers-tools. So when you go there, you end up on the landing page. At the top are some getting started pages to help you get started with using Cassandra with a handful of programming languages. However, we have drivers for a lot more languages than just that. If you look over on the left, you're going to see them broken out by category, by programming language. And if you start scrolling down, you'll see that there's over 50 different client drivers for Cassandra. At the top here is data stack supported drivers. And if you happen to be using one of these 4 programming languages, C#, Java, C++, or Python, I encourage you to start with the appropriate driver from the DataStax list there, because these are drivers that are DataStax certified and heavily tested. However, if you want to use a programming language other than those 4, no problem. Let's scroll down. And you're going to see there's this great selection of drivers for different programming languages. Node.js, ODBC, Perl, PHP, R, Ruby, Rust, Scala, lots to choose from. You notice that some of them have an asterisk next to them. And if we go back to the top of the page, the drivers marked with an asterisk have not been updated since Cassandra 2.0, so they may not utilize the newer features of Cassandra. Out of this list, I would recommend first you start with the DataStax supported drivers, one of those, if there's one for your programming language. And if not, that you look through the list, maybe looking for the ones that don't have the asterisk. If, however, there's only one under the programming language you want, then go ahead and check it out. See if it'll work for your purposes. So I encourage you to go ahead and take a couple minutes and click on some of these. So to create our vehicle tracker application, we're going to be using the DataStax Java client driver. Let's take a look at it. We can click on the link here. And by the way, I'm on the planetcassandra.org/client-drivers-tools page. And I just scrolled down a little bit, get down to the DataStax supported drivers. So if we go ahead and click on the link here, it's going to take us to the actual source code for the driver. So we can take a look at that, check it out, depending on your level of interest in terms of how deep you want to go. Scroll down, there's some information about it. And then where we can get a lot more information is another web page. Let's go to www.datastax.com/download. And then you'll land at the top of the page, which looks like this. But if you scroll down, you can get down to the DataStax drivers and the DataStax Java driver in particular. So the first link is what we just looked at. It's actually the code for the driver, the source code. The second link here, the one that says binary tarball, this is so that we can download the jars. So the jar files that make up the driver, which we'll be using. So I've already put these on the virtual machine. You have them. They're in our files directory on the desktop, and we'll be going through how to install them. And then the API reference, let's take a look at that. Here's our packages that make up the DataStax Java driver. The main package is the core, the com.datastax.driver.core package. If you click on that, you see an interface summary and class summary. Down under class summary, there's the cluster class. We're going to be using that. That's the first one that we're going to use so that we'll be able to communicate with our Cassandra cluster from our application. Let's go back to this page, which was datastax.com/download. And let's look at one more thing in here. The programmer's guide. We've got documentation either in the HTML format or PDF. If you click on the PDF link, I've already opened it over here, gives us access to the documentation on the Java driver. Lots of good stuff in here. Let's go to About the Java driver. Gives us an architectural overview of it. Under Writing Your First Client, we've got information about connecting to a Cassandra cluster, which we'll be doing. And then under Java driver reference, we've got a whole lot more topics listed in here. So we'll be creating a simple application as we go forward, but I encourage you, to the level that you're interested, browse through this documentation and get a deeper understanding into the Java driver and how it works. As we go to create our vehicle tracker application, which we've decided to create in Java, we're going to need somewhere to write our Java code. We're going to use Eclipse. Eclipse is an open source IDE, integrated development environment, that you may already be familiar with. It's very common. In order to use Eclipse and our Java code that we're going to be writing, we're going to need the Oracle JDK installed because we're going to need a way to compile our Java code. And we're going to need web server software and a servlet container to be able to run that Java servlet that we create. Let's take a look at these things in a little more detail so that you can see what I've already installed on the virtual machine so that you know what you're dealing with. This file, if you'd like to follow along with me, is in your working files folder, and this file is called steps done to create vm1.txt. Go ahead and open it up in a text editor. This shows basically all the steps I did to create the virtual machine. The steps that we're interested in right now are these ones here, these 4, Oracle JDK, Maven, Eclipse, and Tomcat. And let's scroll down in the file to where these topics are. Steps 34 to 67 are the steps that were done to install the Oracle JDK, which allows us to compile our Java code. Below that, you can see that Maven was installed. We'll be talking about this in a little bit. Maven, if we choose to use it, provides an easy way to install the DataStax Java driver jar files in our Eclipse project. And then below that, you can see the steps I did to install Eclipse. And then below that, the steps I did to install Tomcat, our web server and servlet container. Let's now go to our virtual machine. Open up a new terminal window. And in the terminal window, let's run a command to check to see that the JDK was installed. -version. And if we press enter, we see that yes, indeed, it is installed. Great. Let's go to where Eclipse is installed. If you do ls, you'll see in our list here, there's Eclipse. There's a directory for it. And if we were to look inside of there, we'd see there's an executable named Eclipse. So what we're going to do now is we're going to go ahead and run Eclipse. And you can do that by entering Eclipse, which is the name of the directory, /Eclipse, which is the name of the executable inside of the directory. Enter, and then give it a couple seconds to launch. For the Workspace Launcher window, you can just leave it with the default settings and click OK. So what we want to do now is go ahead and create a project for our vehicle checker application. Let's go up to the File menu, and let's choose New Dynamic Web Project. And for project name, let's go ahead and enter Vehicle Checker. And target runtime of Apache Tomcat version 7.0 is great. All these settings are fine. Let's click on Next. This is fine. Next. And let's select the checkbox for Generate Web.xml Deployment Descriptor. And then we can choose Finish. So now we see that our vehicle checker project has been created. In this movie, we set up our development environment. We're using Eclipse as our IDE and Tomcat as our web server and servlet container. Let's take a look at the application page we're going to be creating. So in your working files folder, you have location_tracker.pdf. So if you'd like, you can go ahead and open that up in Acrobat Reader. What we have in here is we're going to have a heading, track a vehicle, enter the track date and ID of the vehicle you want to track. We're going to then have 2 fields in our form for the end user to be able to go ahead and enter the date and the vehicle ID of the vehicle they want to track. When they click on Submit, we're going to pass those values in the URL from the database. We're going to retrieve the date and time, latitude and longitude. And then what we'll also do for fun is we'll go on to display their location in Google Maps. To create this application, we've decided to use Java. There are a lot of different frameworks out there for creating Java applications. We're going to try and keep it as simple as possible to create this. Let's go to Eclipse. So in your VM virtual machine over in Eclipse, which you previously launched, we're going to go into here and we're going to be creating a servlet file. Under Vehicle Tracker, under Java Resources, we're going to right-click on the source folder, the SRC folder, and we're going to choose New Servlet. We need to specify a package for the servlet to live in. Let's go ahead and give that a name. com.vehicletracker.servlet. That's the package name. And then for the name of the servlet file, we're going to do a class name of vehicle tracker servlet. Everything else is fine. Let's click on next. For the URL mapping, so this will become part of the URL. Let's change that. Usually URLs are in lowercase. So let's select that, click on edit. Let's just put track just to keep it simple. Click on OK. Next. We don't need this do post bit of code, so we can deselect that and then finish. So if we look over on the left here under source, under SRC, we're going to see that there's a package. And then inside of there's our servlet file, vehicle tracker servlet.java. And that's a file that was opened up for us. Let's scroll down in that file, down to the do-get method, because that's where we're going to be entering our code. To give ourselves a little bit of room in here, how about after the comment, after the to-do comment, hit enter a couple times, have a little bit of space. And let's go ahead and create a title for our page. So let's enter print writer out equals response.getWriter, and then out.println, println, the text that we'd like to have show up on the page, which is going to be our vehicle tracker header. Semicolon at the end of that line. One thing we need to do, you see here that the class printWriter is unknown, but if we go ahead and hover over it, we're going to have these choices. Let's click the first one that says import printWriter java.io. And once we do that, the underline will go away because up top here, this import statement has been added. Let's try this out. Let's go ahead and save. And then let's right click anywhere on the file and choose run as, run on server. All of these settings are fine. We'll click the finish button. Don't worry about those red messages that you saw at the bottom there. Those are just messages from Tomcat, the web server, and servlet container, and they're just informational. Here we are, our page is shown up. So I noticed the URL, it's localhost:8080, the port for Tomcat, /vehicle tracker. That's the name of our project in Eclipse. That's what we called it. So that's where that came from. And then track, which is what we specified as part of the URL. And then on the page, we see the text of vehicle tracker as we specified. So our application page is started. And as we go forward, we're going to be communicating with our Cassandra cluster to retrieve data from our vehicle tracker key space. And within that, the location table. Let's talk about getting the DataStax Java driver jar files. The files that we need include the following, and there's a couple ways for us to get them. We can either get them from the DataStax Java driver binary tarball link, which is on the web page that we saw earlier, and I have downloaded them already onto the virtual machine. So you have them. I haven't installed them, so we'll be learning how to do that. But I have simply downloaded the tarball file, so we all have it. The other way to get the jar files is via Maven. And Maven works with an XML file called pom. So this pom.xml file. What it does is it retrieves the jar files from a Maven repository. Either of these methods for getting the jar files is fine. There's really no benefit of one versus the other than Maven does require internet access. So if that's a factor, that might affect your decision, but really it's the same. You just need to get these jar files. Now, in order for the DataStax Java driver to be able to communicate with the cluster, there is something that needs to be set on every Cassandra node in the cluster. And it's this start native transport property. It needs to be set to true. It is set to true by default from Cassandra 1.2.5 onwards. So it's probably going to be already set for you when you go to use Cassandra. It is already set on the virtual machine. But just for fun, let's go take a look at that. Let's jump over to our virtual machine and let's go into a terminal window where we are already down in the directory where Cassandra is installed. So if you go to this terminal choice over here and you click on it and you click on it again, it should bring up your terminal windows. We're looking for the one where you're already in the directory where Cassandra is installed. I'm going to go ahead and click on that one. As you may recall, there's our con folder. So if we were to cd to the conf folder and ls, we see our cassandra.yaml file in there. Let's do vim cassandra.yaml. And if we scroll down to line 310, or if you don't want to do that much scrolling, you could just search. You could do / and then start _ native _ transport. Jump down there. We see that this property is already in here and it's already set to true. So we are good to go. In the next couple movies, one is going to be on installing the jar files using Maven, and the other is going to be installing the jar files manually. Go ahead and watch both movies, but then you're only going to do one of them. So you're going to pick one or the other for how you go ahead and install the jar files. And as I mentioned before, it doesn't matter which one you choose. Either will work fine. To get the DataStax Java driver files via Maven, what we can do is simply be in Eclipse, right-click on our project vehicle tracker. I should also mention this does require internet access. So as long as you have internet access, it's pretty easy. And then we're going to choose Configure, Convert to Maven Project. My menu is a little bit off the screen, but it's a third choice down. Configure and then Convert to Maven Project. So this window is going to open up. What you're going to do is you're not going to enter the Java driver information here. That's the one place people kind of get tripped up is they start entering the information here for the driver, but you don't put it here. Go ahead and click on Finish. Leave this with the defaults. What Maven's done is created this pom.xml file over here on the left, and it's opened it over here on the right. You still do not put the Java driver info here either. What you do is you go to this Dependencies tab. And then in here, in the left column, we're going to click on the Add button. And this is where we're going to enter the information for the DataStax Java driver. For group ID, go ahead and put com.datastax.cassandra. Artifact ID of Cassandra -driver -core. And then for version, let's click on OK. And then let's save and close our pom.xml file. I just did Command S, but we could do it from the menu. File save. This file's done, so we can go ahead and close it. File close. That's one option for adding the DataStax Java driver files to your Eclipse project is simply by turning it into a Maven project and then in the Dependencies tab, putting in the information for the DataStax Java driver. And then what it does is it goes and retrieves the DataStax Java driver jar files from the Maven repository. So an alternative to using Maven to get our DataStax Java driver jar files is to get them ourselves and copy them into the web content directory under webinf lib folder. So that's where we're going to put the jar files. And again, this is something you would only need to do if you didn't get the jar files through Maven. If you did it through Maven, you don't need to do this as well. All right, so let's go get these jar files. Let's go to the home folder up on the left and select desktop and then go into the files folder by double clicking and then double click on the chapter 9 folder to open it up. And then in here, we have the Java driver files. They're zipped up in a tarball file. Let's unpack this. Double click on it and then select Extract. And then in this window, in the lower right, let's click on Extract, leaving all the defaults. Once it's extracted, you can click on Close. You can close this window, and you'll see that you now have a Cassandra-Java-Driver-2.0.2 folder, which has been extracted. Let's go inside of there. And the files that we need to copy into our project are in the lib folder. And let's select all these files, Command A or Control A. And let's see if we can arrange this window so that we can go ahead and drag these files down into the lib folder. Since I've already set up the jar files through Maven, I'm not going to do this, but otherwise I would just go ahead and drag them into that folder and it will copy them in to the lib folder. And then there's one other file that you also need to have in there. So if you go back up a level, click on this back arrow to go back up one directory, you also need this file, this Cassandra driver core-20.2.jar file. So same thing, you just go ahead and drag that into the lib folder as well. And if you're curious to know, the difference between that one and this one over here is that this one on the right is for DataStax Enterprise. Since we're using the Apache Cassandra distribution, we want this one on the left. And there we are, the DataStax Java driver files in our Eclipse project. The cluster class allows the Java application to communicate with a Cassandra cluster. Let's take a look at an example here. We've got the cluster class defining an object, which could be named anything. We're calling it cluster in lowercase. And then for add contact points, we've listed the address of 2 nodes in our cluster. We have to list the IP address of at least one node so it can connect to our cluster. Listing more than one contact point is recommended so that if one contact point is down, another contact point can be used. Once the application is connected to Cassandra through any of the IP addresses, it then knows about all of the nodes in the cluster, including the state of nodes joining or leaving the cluster. Let's go create a cluster object for our application. So let's go ahead and jump over to our virtual machine. In our vehicle tracker servlet.java file that we created previously, this is in our vehicle tracker project under Java resources, vehicle tracker servlet.java, open over here. If you're not already scrolled down, then go ahead and scroll down into the doGet method. And let's go ahead and define our cluster objects that we'll be able to connect to our cluster. Right after our to-do comment here, let's give ourselves a little bit of room by hitting enter a few times. And let's type cluster. And of course, Java is case sensitive. So this has to be a capital C, as you see there. This name could be anything you want. I'm going to go ahead and call it cluster in lowercase equals, and then cluster.builder.add contact point. And then for the moment, we are going to put localhost and then .build and semicolon to end that expression. As I was typing, it was auto-hinting with methods that I might want to specify based on the fact that I was creating a cluster object. If for some reason yours wasn't doing that, then there's a couple possibilities. One is that you perhaps have a red underline, in which case you would want to hover over that and you would want to select import cluster com.datastax.driver.core from the list that shows up. Then it means that the DataStax Java driver jar files are not set up in the project. If that's the case, you're going to want to go back to either of the previous movies and get those jar files into the project. Let's go ahead and run this just to make sure everything is okay. So you can save the file, and then you can right-click anywhere in the file and choose Run As, Run on Server, and we'll go ahead and choose Finish. If you get this message, you can choose Continue without restarting. Click on OK, We didn't get any errors, which is great, means that the code we added is fine. So what we've done so far is made a connection to our Cassandra cluster. As we go forward, we'll be setting up a session and able to run CQL expressions. Now that we've created a connection from our Java application to our Cassandra cluster, let's look at what we need to do to be able to execute a CQL expression. After our cluster line of code, let's give ourselves a couple blank lines. And what we need to do is create a session object. And then we'll call this object session, although it could certainly be called anything. And then what we're going to pass into our session object is cluster.connect, opening, closing parentheses, semicolon. So what we pass into the session object is our cluster connection. The same name here as you see here. So we take that connection, we pass it into our session object. Now that we have a session object, we'll be able to run a CQL expression by using the execute method. If you see a red underlined session class like I do there, roll over it so that you can select import session com.datastacks.driver.core. That'll add the import statement to the top of the file and the red underline will go away. As I mentioned, once you have a session object and you've passed in your cluster connection into it, then you can use the execute method. What you pass into the execute method is a CQL expression. So we'll be doing that shortly. I'll just leave that placeholder for the moment. And when we run that CQL expression, ours is going to be to retrieve data on the location of a vehicle for a certain date. We're going to need somewhere to hold that data when it comes back to our application. So we need to create a result set object for storing that data. The name of the class is result set, and then we can name the object whatever we'd like. Go ahead and call it result. And then I'm going to have equals session.execute, opening, closing parentheses. We're going to be putting a CQL expression in here. And then, of course, semicolon to end the line. Let's roll over result set. And what are we going to choose? Import result set for the com.datastacks.driver.core package. Let's write this CQL expression. Inside of execute here, the expression we're going to write, it's kind of long. So rather than cramming it in here, what we'll do is we'll make up the name of a variable, and then we'll put the expression in the variable. I thought we'd call our variable query string. Right up here, let's do that. String, and then query string, define this variable, equals, and then in quotes, and ended by a semicolon, we'll enter our CQL expression. We're going to do a select, and then we're going to specify the columns that we want to retrieve from the location table that's in the vehicle tracker key space. So select time, comma, latitude, comma, longitude, from. So those are the columns we want. And then we need to specify what key space and which table. So vehicle underscore tracker dot location in the vehicle tracker key space, in the location table, those three columns. And then we don't want to bring back all the rows. We just want to bring them back for a particular vehicle on a particular date. We're going to continue writing this, but let's go ahead and create a couple more variables. One for the vehicle ID and one for the date. And then we'll plug them into our expression. String, vehicle ID. We'll eventually be picking up on the value that the end user enters into a form that we're going to provide. For the moment, just to make sure that this is working and we're on track here, what we'll do is we'll put a static value in here, just temporarily. One of the vehicle IDs is CA6A FL218. We'll put that static value for now just to test our code. And then let's do the same thing for a date. So we'll create a variable called track date equals, and in quotes, 2014-05-19. And that's a date that exists in our data. So we just need to use these two variables in our where clause over here, where vehicle ID equals, and then I'd like to use that variable there. So we're going to put a single quote, double quote, and then plus the name of our variable, vehicle ID, plus, in Java, this will concatenate. It'll take that literal string, combine it with the value in this variable, and then I want to add some more text, double quote, single quote, and date equals single quote, double quote, plus our second variable, we also want to include in this expression, which is track date, plus, and then we want to just finish this off. So double quote, single quote, double quote, and then semicolon. So we're saying we literally want this text as part of our CQL expression, and then we want the contents of this variable to be added to that. And then we literally want and date equals, and then we want the contents of this variable to be added. And those two variable names are the ones we defined right up here, vehicle ID and track date. Let's try this out so far. Make sure we don't have any typos in there. And by the way, if you think you do have some typos and you want to just go ahead and get the code for this, in your working files folder, there's a query string underscore code.txt. So if you want, you can just open that, select that, copy it, and paste it into our file. Or you can go ahead and give it a try with what you've got so far. Let's save the file. And let's right-click anywhere on the file and choose Run As, Run on Server. Click on Finish. For this, you can just do Continue without restarting and click on OK. And if it runs with no problems, then you're good. And you might think, well, wait a minute, why don't I see any data showing on my page? Because we haven't written any code to tell anything to display. So even though we're connecting to the cluster, we're running a CQL query that brings back the location information for that particular vehicle ID on that date, we haven't done anything to actually use that data. We'll be doing that next. This movie was on how to execute a query, which is basically creating a session object and then using the execute method of the session object and taking the result and putting it into a result set object. Let's write some code to display our query results. As you may recall, we had created a cluster object that connected to our cluster. Then we created a session object, passed in the cluster object to it, and then we used the execute method for our session object to run a query string, which was our CQL expression, which was then stored in our result set object, which we named result. Now we want to take what's in that object named result, and we want to display it in our web page. Let's look at the code we're going to write. We're going to have this display in a table, and for each row that's returned, we'd like to have an HTML row be displayed. So write tables and HTML tag says simply to display a table. And then we have this for loop, and we're saying for each row, so we're defining a row object named row from the row class. For each row that's in the result, we would like this code to run. So for each row in the result, we'd like to have a TR, so an HTML table row tag. And then within the opening and closing table row, we'd like to have 3 cells, 3 table data cells. So we'd like to display what's in the time column that's in our location table in our Cassandra database. And how we can reference what's inside of there is by using this getDate method. So this is part of the row class. There's a method for each different data type. So in the case of latitude, which we had defined in our table to store data of type double, there's a corresponding getDouble method. So we're going to say for each row that comes back from our CQL query, we'd like to display what's in the time column, the latitude column, and the longitude column. Let's try this out. Go ahead and select all this code, copy it, go back to our virtual machine, and let's put this in after our header. So after the vehicle tracker header, we'll hit enter to give ourselves a couple blank lines, and let's do a paste. All right, if you have the word row red and underlined like I do, you're going to roll over it and choose import row com.datastacks.driver.core. So the import statement for that got written at the top of our file. And we're ready to try this out. Let's save the file. And then right click anywhere in the page there and choose run as, run on server, finish. We don't have to restart the server. We can just do continue without restarting. We'll click on OK. We have data. So for our query, our CQL query, which was to go ahead and bring back all of the rows in the location table that had the vehicle ID of this and the track date of this, go ahead and bring those back and display them. Jump back to Firefox, our browser here. We can see the data. Let's say we'd like it to actually display in what looks like a table rather than just displaying the HTML tags. Let's go back to our code. And we just need to add before our header, HTML head, closing head, and opening body, just the standard HTML tags. And we could type those in, or you could grab those from in your working files folder, HTML skeleton _ code.txt. So you go ahead and select that first line. We'll put that in right here before our vehicle tracker heading. And then we'll want to put the closing body and closing HTML tag down after our table. So you could type that in, or we could grab that from our HTML skeleton _ code file. Let's save the file. Let's right click to choose run as, run on server, finish, continue without restarting, OK. Very nice. We've got our table there with all of our rows relevant to that vehicle on that date. Let's say we'd like to display just the most recent entry for that vehicle for that date. So really just this one up here. And as you may recall, they're in descending order because when we defined the table, we said clustering order of descending. All right, so we just want to bring back that one, not all of these. So let's just slightly modify our CQL expression. So I'm going to go ahead and scroll over to the right. All right, and at the end of this, we're going to add limit 1. So right here, right after the single quote, but before the closing double quote, let's put a space and put limit 1. Let's save this. Right click, run as, run on server, finish, continue without restarting. Okay. Great. Just the first one comes back. In the next video, we pick up where we left off here. Picking up where we left off in the last video, now what we'd like to do is we would like to have it so that there's a form displayed on this web page, and so that the end user can enter in a vehicle ID and a date and have the relevant data come back for that vehicle on that date. Let's go to our working files folder, open up vehicle HTML _ code.txt. That's the code we're going to want. Let's open that up in a text editor. What's going on in here? Cluster, as we had written, session, string, result set, print writer, everything looks as we had done before, but now we really just have a whole bunch of HTML. Noting especially right here, there's an opening form tag, method of get. And then in a table that's going to display, we've got input. So we're creating a form where the end user is going to be able to input the date. And we have one other input field here where the end user is going to be able to input the vehicle ID. And we've got headings for this. So this text will show up on the page, date, and vehicle ID text will also show up on the page. So the end user knows what they're supposed to type into the two input fields. And then finally, we have a submit button down here where it says vh_id and date val. Those will both be used in the URL in the query string. Two more things to note here. One thing is up top here, we have request.getParameter vehicle ID. So we basically want to pick up on what did the end user enter into that field named vh_id. So what did they enter in here? I want to pick up on that, and I want that to go into this variable so that whatever they enter for vehicle ID, that becomes part of the CQL expression. Likewise, whatever they enter for date_val, this guy, that goes into our variable called track date, and that gets used in the CQL expression. Down here, we have some if, else if, and else statements to basically check to see, did they enter something? Because if they didn't enter anything for vehicle ID, this is just a comment, then it's just going to be blank. So what they see on the web page will just be blank. That's just a comment. If they put something in, put a vehicle ID on a date and there's no results, or they put a vehicle ID that doesn't exist, then they'll see this message. Sorry, no results for vehicle ID. And then we'll print out the ID they entered for, and we'll print out the date they entered. Otherwise, else, so as long as there's some results, then what'll happen is the code that we wrote before. Go ahead and display the time, latitude, and longitude. Select all, and then copy it. Go back to our virtual machine, back into our code. And we're going to replace the code that we had previously typed in here with the code we just copied out of the text file so that we're not having to type tons of HTML code since we really want to focus on Cassandra. So let's go ahead and delete that. Make sure you don't delete those remaining two curly braces there. And then go ahead and paste from the text file. Save the file. Right-click, run as, run on server. Finish. Continue without restarting. Click on OK. Great. We have this nice looking form. Let's try it out. We could put in the suggested values here. Sure, let's try those out. And then we could try out other values that also exist in our table. 2014-05-19. Vehicle ID, FLN, 78197. Submit. Very nice. All right, let's try another one. If we were to go look in CQLSH and do a select star from this table, we could see other values in here. Or I'll just give you one. Go ahead and enter in for date, the same date, 2014-05-19. For vehicle ID, let's try out WA063JXD and do a submit. So we get the latitude and longitude values for where that vehicle last was on that day and time. This is optional, but I'm going to go ahead and do one more thing for fun, and that is add a little bit of code in here to use Google Maps to display the location of the vehicle. And the reason I'm saying this is optional is this is not a Cassandra thing. This is just for fun. So we can actually see a visual of that car's location. Go ahead and go to your working files folder and open up vehicle with map html_code.txt. In here, it's our code as before. there's just some extra code in here so that we can interface with Google Maps and get a map to display. I won't spend time going through the JavaScript code and all for this, but if you're interested, feel free to trace through this, see how it works. Let's go ahead and copy it. I can do a select all, let it copy. And then back in Eclipse, let's go ahead and get rid of what we had pasted into our doGet method, leaving, of course, those two curly braces behind. And then go ahead and paste what you just copied from the file that included map code. Save your file, right-click, run as, run on server, finish, continue without restarting, okay. Go ahead and enter in the information for a vehicle. I'll go ahead and use one of those two that we just used. Beautiful. So this movie was on displaying our query results. And of a special note was the use of the row class combined with our result set to display the results that came back from the CQL query. Let's look at using an MVC pattern for our application code. MVC, which stands for Model View Controller, is a common pattern for structuring application code. It's a modern design pattern in which the code for an application is separated into its model, view, and controller parts. Model refers to the data or backend aspect of an application. In the case of a Cassandra application, the cluster and session objects for communicating with the Cassandra database would be part of the model code. The view code is for the front end or user interface of an application. The view code determines how the application is displayed to the end user. In the case of a web application that interfaces with the Cassandra database, this would commonly be HTML and JavaScript code. The controller code is for handling the user's interaction with the application, in effect, working between the view and model code. Let's go take a look at our application with the code organized in an MVC pattern. Let's go over to our virtual machine, and you can close any files you have open in Eclipse. I'll just go ahead and collapse that project. And what we'll do is we'll make a new project and we'll point at files that have already been created in an MVC pattern. Let's go up to File and choose New Dynamic Web Project. For project name, vehicle-tracker-MVC. For project location, let's deselect the Use Default Location checkbox because we actually have a place where the files are. So let's do Browse, and then Desktop, and then Files, Chapter 9, and then Vehicle Tracker-MVC .folder, and then OK, and then Finish. Now we have this project over here, Vehicle Tracker-MVC. Let's expand that by clicking on the triangle. And then let's click on the triangle to the left of Java Resources and the triangle to the left of Source. We see that we have two packages, com.vehicletracker.dao, which stands for Data Access Object, and com.vehicletracker.servlet, so that we can see the files inside of these two packages. Let's go ahead and look at the model file first. So if you double-click CassandraAccess.java to open up that file, then we can see the definition for a cluster object and a session object inside of here. Let's next take a look at the view file. So let's double-click on VehicleTrackerServlet.java. Earlier, we had all of our code in this one file. Now in here, we really just have our view code. So you can see our HTML and JavaScript code in here for our vehicle tracker application page. Browse through there. And then let's open up our controller file, VehicleTrackerDAO.java. Double click on that one. And inside of here, you see our query string. So working between our view file and our model file, we've got code in here to query the database, and then the data will go back to the view file and be displayed for the end user on the application page. Supporting this file, we have another controller file, get sets. Let's open that one up. This is additional code which provides Java encapsulation for addressing the columns in the location table. Let's go ahead and run this application just to see that it does indeed work. So go ahead and right-click on Vehicle Tracker Servlet.java. So you can choose Run As, Run on Server. The defaults are fine. Let's click on Finish. And let's choose Restart Server. Click OK. Let's go ahead and try this out by entering a date and vehicle ID. Go ahead and use our 2014-05-19 and vehicle ID. I'll go ahead and enter the one suggested here. Let's click on Submit and see if our map displays. And it does. So this was on looking at our application code in an MVC pattern, where the model, view, and controller code is in separate files. The focus of this unit was on creating an application that uses a Cassandra database on the back end. We learned about Cassandra drivers. We took a look at and used the DataStax Java driver. We set up a development environment. We created an application page. We got the Java driver files. We connected to the cluster. We executed a query. We displayed the query results. And then we looked at the code in an MVC pattern. So we'll go ahead and do a few questions here. I just want to also add that for whatever programming language you choose to use with Cassandra, that you go investigate the drivers available and read through the documentation so that you can learn about all the different options with the driver. Number 1, the only client driver that exists for communicating with Cassandra is the DataStax Java driver. Is that true or false? Definitely false. As we saw on planetcassandra.org, there's over 50 different client drivers available for Cassandra. Along with that, it's over a dozen different programming languages. So you're definitely not limited to the DataStax Java driver. We just happen to use that one as an example. Number 2, the DataStax Java driver must be used with Maven. True or false? False. So while you certainly can use it with Maven, and it does make a very easy way to get the jar files set up in your Eclipse project, you certainly don't have to. You can also manually put those jar files into your project. Number 3, when using the cluster class, it's a good idea to specify the IP address of more than one node so that if one node is down, an alternate node can be used for the initial connection to the cluster. True or false? True. Definitely a good idea. Number 4, to execute a CQL expression via the DataStax Java driver, a session object is needed. True or false? True. That is correct. Because if you just have a cluster object, you can communicate with the cluster, but you can't execute a CQL expression without a session object. And last question, number 5. The name of the class that receives and holds the result of a CQL query, is it A, rows, B, results, C, results, or D, result set? So what's the name of the class? D, result set is correct. In this lab, we're going to create a second application. This is going to be for a person to be able to remotely check on the status of their home alarm system. Let's take a look at the application. So this is what we're going to be creating, alarm system status. Enter your home ID to see the most recent activity for the system. So we're going to have a form with a single field where they enter their home ID. And when they submit, we're actually going to call on 2 tables. There's going to be the activity table data down below. And from the home table, we're going to retrieve the name of the person and the address for that home. When you do this, You're going to have only one cluster object. So the cluster objects you're going to use for the whole application. Same goes with the session object. Just one session object for the whole application. You could have more than one, but there's no need to. Session objects are long-living objects in the DataStax Java driver. It's normal to use just one session object for the whole application. If you think this is going to be really easy, then I recommend that you do it with an MVC pattern and that you go take a look at the DataStax Java driver documentation so that you can learn about additional classes as you go through this. If, on the other hand, you think this is going to be really hard, then I recommend that you follow along with me, so we both do it together. Depending on your situation, you can either pause the movie here or go ahead and let it play. Put in Ubuntu. You can close Firefox if that happens to be open. You can close any files you have open from earlier. Let's make a new project. File, new, dynamic web project. I thought we'd call it alarm system. All these default settings are fine, so let's click on next and next again. And we'll select the generate web.xml deployment descriptor checkbox and click on finish. So that makes a new dynamic web project. Let's go ahead and create a servlet file inside of here. Click on the triangle, and then you can click on the triangle to the left of Java resources. Then for source, we can right click on that. And as you may recall, we're going to choose new servlet. All right, we need to specify a package for our servlet. Let's put com.alarmsystem.servlet. And for the class name, let's put alarm system servlet. Click on next. For URL mappings, this will be part of the URL. We'll do something maybe shorter and lowercase. I'm going to select that and click on edit. And let's put instead status. Click on OK and next. We're going to deselect the checkbox for do posts because we just don't need that code in our file. And we're going to click on finish. So we see this file was generated, and where it lives is down under the src folder and inside of the package, which was called com.alarmsystem.servlet. Let's go ahead and create a heading so we can test this out so far. So if we scroll down, we're going to be putting all our code down here in this doGet method. So I'm just hitting enter a couple times down there to give a little bit of room. Let's go ahead and type print writer space out equals response dot get writer. This will allow us to be able to output text on the screen. And then out dot print ln. And inside of here, we can simply put the text that we want to have show up on the web page. So we're going to want alarm system status. This will be our heading on the page. All right, this is underlined because Eclipse doesn't know about this class name. Let's roll over it and let's choose import print writer. And when we do that, that adds it up here, that statement, so that the class is now known. Let's save this file and try it so far. File save and do a right click, choose run as, run on server. We just want to make sure we don't have any errors so far. Finish. Let's restart the server. There's our page displayed. Alarm system, that came from the project name. Status, that came from the URL we specified. And this came from the print writer class. You can close or minimize that, doesn't matter. In the next video, we pick up where we left off here. Picking up where we left off in the last video, let's get our jar files that we're going to need for the DataStax Java driver so that we'll be able to communicate with our database in our Cassandra cluster. Let's do this the Maven way. I'd say that's the easiest way. Let's right-click on our project, Alarm System, and choose configure and then convert to Maven project. You can't see mine, but it's the third choice down on the list, convert to Maven project. Do we put in the settings here? No. Click on finish here. Do we put in the settings here? No. We go to the dependencies tab. Which add button do we click on? The one on the left. Group ID, com.datastacks.cassandra. This is going to be so that we can go get the jar files from the Maven repository. So we're specifying the information for that. So for artifact ID, let's put Cassandra-driver-core. And then version, we want version 2.0.2 of the driver. Click on OK. Let's save the POM file. And then we can close it. Back here in our servlet file, we're going to define a cluster object, and then a session object, and then a CQL expression, and go from there. So we could start typing all of that in by hand, or since we have been through all of that and it's just going to be a lot of typing, why don't we go grab it from our class files? Go to your working files folder and open up home html_code.txt in your text editor. Let's take a look at this. We're going to be copying and pasting this in. Cluster, we're defining a cluster object. The IP address we're using for now to reference our cluster is localhost. We'll be changing that a bit later when we have IP addresses for our different nodes in our cluster. We'll be specifying a couple of those. And then we're passing in that object, the cluster object, to a session object that we've defined. Once we have a session object, we can use the execute method. And what we're going to do is execute a CQL expression. Rather than typing the whole thing in here, I've just simply broken it out into a variable called query string. Select date, time, event, code use from the activity table that's in the home security keyspace, where the home ID equals what the end user has entered into the form. And we're picking up on that through this request.getParameter h_ID. That's getting put into this variable that's ending up in our CQL expression. And of course, where this came from is if we look at the form code, so this is HTML code down here, and we see that there's an input field which has a name of h_ID. So whatever they type in there is going to end up here. That's going to go into that variable. It's going to become part of our CQL expression. The result of running that is going to go into this result set object, which we're calling result. Down in here in our else expression, we're looking to see if they didn't fill anything out or if they filled in a home ID that has no results. Otherwise, down here under this else, we're going to say for each row in that result expression that we'd like to display what the event was. So what event happened for that home and what was the date and time that that event happened. This is the column name in the table event. And this is the column name in the table date time. To retrieve the results of each of those, we have to use the appropriate get method based on the data type of that column in the table. Let's put this in. Select all. Let's copy it. Jump back over here. Get rid of our temporary code that we had there. Clear that out. Not wiping out the closing two curly braces. And let's do a paste. It doesn't know about these class names, but that's okay. Go ahead and roll over each one, choosing the com.datastacks.driver.core package. I'll choose it for cluster, and then for session, same thing, looking for the com.datastacks.driver.core package. Same goes for result sets, com.datastacks.driver.core. And then also for the row class, scroll down a bit, you'll find that. Same thing, import row com.datastacks.driver.core. that has put these up here. Let's now save the file and rerun it so we can see the form show up. Right click and choose Run As, Run on Server. Finish. Don't need to restart the server. We can do Continue without restarting. Our form is there. Let's try it out. Let's enter in the ID of one of our homes. We could look them up back in CQLSH, or let's just go ahead and put one in I know of, which is H01474777. And fantastic. See the events that have happened and the date and time when those events happened for this home. If we also wanted to display the home ID, we could have added that column as well. Or if we also wanted to add the code used column, we could have added that one as well. We can pull data from more than one table. We can do that on the client side. We talked earlier about how you can't do joins in Cassandra on the server side, but you can do it in your client. Let's go ahead and also display the contact name and the address for the property. So let's go to our working files directory. Let's open up home HTML with address _ code.txt. We're still going to have just one cluster object, just one session object. We're still going to have the code we had earlier for our query string. We're just going to have some additional code in here, such as this line here. We're going to create a second query string. We'll call this one query string _ home table. And as you see here, it's select contact name, address, city, state, zip from homesecurity.home, so from the home table, where the home ID equals the home ID. And then to run this query, we're going to have a second result set object. We're going to call it result _ home table, just to give it a name. And in the execute method, we're going to execute that second CQL expression as well. So this first one will execute the first one, which brings the data from the activity table. And this one will bring data from the home table. So now to display the results from the home table, down here in our else expression, we're going to print out. So here we've got for all the rows in this result set, result _ home table, which is going to be one result, because in that table, there's just one row for each home. For that row, go ahead and output a paragraph tag, a bold, show the contact name, closing bold, and then output the address, which is a string data type, the city, the state, and the zip, and then end the paragraph. Let's select all this text, copy it. Let's go back to our virtual machine, back in our code, in our alarm system servlet.java file. Let's go ahead and get rid of the code that we had inside of the doGet method. Of course, leaving those two closing curly braces there, and paste this code that includes the query to the home table. Save. Let's right click, choose Run As, Run on Server, finish, continue without restarting, OK. Let's enter a home ID, H01474777. There we are. We're pulling data from the home table as well as from the activity table. In the next video, we pick up where we left off here. Picking up where we left off in the last video, one last thing we might choose to do is take a look at this application with the code done in an MVC pattern. We can close Firefox or leave it open, it doesn't matter. Back in Eclipse, let's close any files we have open. And let's go ahead and make ourselves a new project. And then we'll point at application files that are set up in the MVC pattern. File new, dynamic web project. We'll call this alarm-system-MVC. We'll uncheck use default location since we already have some files for this. We'll click on browse, make our way to where those are, which is on the desktop in our files folder, the alarm system-MVC folder. And then we'll click on OK to select that folder as the location for our project files. And then finish. So that project now exists over on the left there. We'll go ahead and click on the triangle to expand it. And then let's take a look at these files. So if we click on the triangle to the left of Java resources and the triangle to the left of SRC, and then we look in both of these packages, let's expand both of them. We can see the files inside of here. Let's go ahead and look at the model file, which is Cassandra Access. If we double click on that, we see the cluster and session objects that are then used throughout the application. Let's open up Alarm System Servlet. This is our view file for controlling what the end user sees in terms of formatting and other HTML tags. And then let's go in the Alarm System DAO file to look at the controller file. So in here, we see our query strings. So the first one's for the activity table and the second one's for the home table. To accompany this file, let's open up getSetsActivity, which has additional code to provide Java encapsulation for columns in the activity table. And then likewise, in our getSetsHome.java file, we've got code to provide Java encapsulation for columns in the home table. All right, let's make sure this code runs. Let's right-click on alarmsystemservlet.java and choose Run As, Run on Server. These settings are fine, so finish. Let's restart the server. And let's enter in a home ID. Submit. And sure enough, this code works just fine. So this is our second application, the alarm system status. So let's talk about updating data. We can update data with the update command. Here's an example. So we've got the update CQL command with the name of the table that we want to update, the keyword set, the name of the column, and the value that we want it to have. And then if we want to limit which records get updated, we can include a where clause, as we've done here, to say that we only want to update the records where the home ID is H014747777. If we wanted to update more than one value for this record, we could do that by using a comma in the set clause. So in this example here, we have update, the name of the table, set, the name of the column, and the values that we want to set. So both the phone and the contact name columns. You notice there's a comma separating those. And then optionally and commonly specifying a where clause. Let's jump over to our virtual machine. I closed Eclipse and Firefox and all that. So you can close it as well, or if you want to leave it open, that's fine too. We're going to be here at CQLSH, and we want to be in the home security key space. As I would imagine you remember, we use the use command to specify home security as our key space. And then let's do a select expression to look at the current value for some of the columns in a particular record. Select space home underscore ID, comma space address, comma space phone, comma space alt underscore phone, comma space contact underscore name, from home where home underscore ID equals, in single quotes, H014747777, closing single quote, semicolon. So we see that this home's contact name and phone number is currently Jed Clampett, phone number of 310-775-4011. And we need to update that. Turns out that phone number is no longer correct. There's actually a new contact number. So let's use the update command. Update home, set the column that we want to set the value of, which is the phone column. We want to set that equal to 310-883-7197, where home_ID equals, and in single quotes, H01474777. Close my single quote, semicolon, and enter. No error message is good. Let's do the up arrow to rerun that select expression. Up arrow twice to get to it, and then enter to run it. We see that the phone number has now been updated. So in this movie, we learned how to use the update command to update values in our tables. And in the next movie, we'll look at what really goes on when we specify an update in Cassandra. Let's get an inside view into how updating works in Cassandra. When doing an update in Cassandra, unlike relational databases, there is no disk seek to find a record, update its data, and save it. Instead, an update is essentially another write. For example, the update done in the last exercise, changing the phone number, was simply a write to a mem table to eventually get flushed to a new SS table once the mem table's full. When a request is made to read the data, Cassandra combines any data from the table's memcache and SS tables that exist for that record. To resolve any conflicts, for example, a phone number in one write versus a phone number for the same record in another write, Cassandra views the timestamp for each value. Whichever has the latest timestamp is the one that's used to reply to the read request. Let's go on over to our virtual machine. Let's go to a window where we're at the directory where Cassandra is installed. So the Apache Cassandra 2.0.7 directory. I'm going to go up a directory from here. So cd space ... Let's go ahead and flush the memcache so that we can then look at the SS table that gets generated. So as you may recall, we can do bin/node tool, flush, and we can specify when we run this command, which key space, and if we want, which table within that key space gets its memcache flushed. So we're going to go ahead and put bin/node tool space flush space home_security space home to flush the home table's memcache on this node. Once it's done that, let's go take a look at the SS table. In another window, let's go look at where the SS table's been written. So var/lib/cassandra/data/home_security/home. And then if we do an ls, we can see what's inside of there. So these files were here from the first SS table. And then when we did the flush, the second set of files were generated. Let's now take a look at the contents of that data file. So as you may recall from earlier, we can use SS table to JSON to do this. Back in the terminal window where you're at the Cassandra 2.0.7 directory, let's enter bin/SS table to JSON space, and then put in that path, which we could actually copy from this other window. Highlight this, right click, copy, and then over here, right click and choose paste, slash, and then let's start typing the name of the file, that data file. So home, I'm going to hit tab, so it'll help me type it in. And then 2 is the one that I want, the most recent one, dash data, tab to complete that. And if we go ahead and hit enter to run this, we can see the contents of that file. And sure enough, what we see in there is really just the update. An update is really just a write. And when there's a query, all of the entries for the requested data are combined, checking the timestamps for any conflicting cells to return the most recent result. Let's talk about deleting data. In CQL, there are a number of commands that can be used to delete data, including delete, truncate, and drop. Delete can be used to delete a value in a column or to delete a row or rows. Truncate can be used to delete all of the rows in a table. And drop can be used to delete a table or a key space. Let's go on over to our virtual machine. Let's be in CQLSH. So find your terminal window where you have CQLSH running. We're going to create a third key space. We're going to create a table inside of it. We're going to load data in there, and then we're going to try out these different delete commands. Let's create a key space that we'll call playground. As you're typing it, you can of course hit tab, so it will help you type in the text. So with replication equals class equals simple strategy, comma space, replication factor, :1. And I have provided a lot of the text that we're going to be typing in our working files directory. If you want to save on some typing, you can grab the text out of the appropriate file to copy and paste it into here. Let's make this key space. Let's do use playground so that any commands we run from here will be in the playground key space. And now we're going to use a command that we haven't used yet, but will be handy in this situation because we want to execute a series of CQL expressions. And rather than typing them all in, I've already got them in a CQL file. What we're going to do is just simply call on that file. Source, this is a CQLSH command, single quote / we need to put the path and the name of our CQL file. And we'll go take a look at it as well so you can see what's inside of there. /home /vm1 /desktop /files /chapter10 /create.cql. Maybe before we run it, why don't we go take a quick look at it? You can look at this file in your working files folder, and it's this create.cql file. That's the one we're about to run. So if you want to take a look at it first, you can double click on it to open it in a text editor. And you see, yeah, we've got use playground and then create table. So we're going to create a table called messages by user, which is going to have a column called sender that can have text in it, a sent column with timestamp values, recip with text values, body with text, message UUID, that's universal unique identifier, primary key of sender and sent with clustering order by the sent column in descending order. We're going to make that table. It's basically going to store messages. And then we're going to use the copy command to import the contents of the messages.csv file into our new table. You can close this. Back here at our CQLSH prompt, we've got source, and then the path to the name of that file. And this will basically run that file. It'll run the commands that are inside of it. Let's hit enter. So it created the table and imported the data, 6 rows. Let's do a select expression just so we can see the contents for ourselves. So select star from messages by user. So that's what we've got in our table. Let's try out some of these delete commands. Let's do delete body from messages _ by _ user, where sender equals Juju and sent equals 2013-07-21 space 15 colon 32 colon 16, closing single quote, semicolon. And this text, by the way, is in one of the files in the working files directory. So we're saying delete the contents of the body column that's in the messages by user table where the sender is Juju and the date, the sent value, the value in the sent column is this date. Let's go ahead and run this. And then let's do the up arrow so we can locate and rerun our select expression. And we see that sure enough, it took out that value. So we can use the delete command to remove a value from a column for a particular row, or we could delete a whole row. Let's do that next. If you do up arrow to get back to that delete expression that you wrote, and then we simply get rid of the word body, which was the column name. If we just don't have the column name in there, then what's going to happen when we run this is it's going to delete the whole row. Let's try it out. Hit enter. Do an up arrow to get to our select expression. Now we only have 5 rows instead of 6. What if we wanted to clear out all of the rows in the table, but leave the table? We could do that with the truncate command. So let's do truncate space messages by user, semicolon. Go ahead and run that. And if we do the up arrow to get to our select statement and run it, we see that the table still exists, but there's nothing in it. Let's say now that we want to go ahead and get rid of the table altogether. What we can do is use the drop command. Drop table, and then messages underscore by underscore user, which is the name of our table. Now if we try and do that select expression, it says, hey, I don't know that table. You notice here it says column family. That's the old word for table. I don't know that table. Messages underscore by user. What's that? Let's do one last thing here. Let's drop our key space. Drop key space playground. Remember how to see all the key spaces that you have in your cluster? Describe key spaces. And it's gone. Playground is no longer on the list. This was on how to delete data in Cassandra using the delete, truncate, and drop commands. Let's talk about tombstones. When a delete is written to Cassandra, a tombstone is created, marking the data for deletion. The reason the data is not immediately deleted is so that there is time for all of the nodes with a replica of the data, like any down nodes, to learn about the mark for deletion. If the deletion were to happen immediately while a replica node is down, it would be possible for the down node to come back up and replicate the data to the node that had previously deleted it, unaware of the delete. The minimum amount of time that must pass before a delete can occur and its corresponding tombstone is set in the GC_grace_seconds property for the table. And we'll go take a look at that. By default, the value of GC grace seconds is 864,000, which is in seconds, so that's 10 days. Once the GC grace seconds amount of time is passed, the data is then eligible for deletion. For the data to actually delete, compaction needs to happen. Compaction is when SS tables are combined to improve the performance of reads due to the fewer number of SS tables and to reclaim disk space from deleted data. Compaction is normally done automatically, although it can also be started manually by using the node tool compact command. And we'll do that, so you'll get to see it. So let's jump over to our virtual machine. In our CQLSH window, let's change to the home security key space. Use space home underscore security, semicolon. And let's do describe table home. So we'll be able to go ahead and see the GC grace seconds property that I was mentioning. Right here, one of these properties, GC grace seconds, is set to 864,000, which, as we talked about, is 10 days. This property can be changed, but it's the default with the thinking that you wouldn't have a node down for more than, say, a week. So if you think you might have down nodes for longer than that are then going to come back and rejoin your cluster, then you may want to set that to an even higher number. Or if you know that none of your nodes are ever going to be down that long, maybe you have a much shorter period for taking care of any down nodes, then you could possibly reduce that number. So let's go ahead and do a deletion so that we'll be able to view a tombstone. Let's do select star from home. And then let's do delete from home where home underscore ID equals single quote H02257222 closing single quote and semicolon. If we rerun that select expression, up arrow and then hit enter, we see that now we just have 4 rows in our table instead of 5. So we did delete that. So now we'd like to see the tombstone that was generated. In a window with the directory where Cassandra is installed, so in the Apache Cassandra 207 directory, I'm going to do an up arrow because I have a flush command from earlier. Let's go ahead and run bin/node tool flush home security home. That'll go ahead and flush the mem table to generate an SS table. Now we could go look if you happen to have your other terminal window where earlier we had viewed the contents of that directory. You could do an ls and you'd see now there's these 3 files for that SS table. So let's go look at the contents of that data file there. Back in the terminal window where you're at the Cassandra directory, let's do an up arrow and let's just change this to 3. So we can see the contents of that most recent SS table. Hit enter. And there's our tombstone. So it's got the deletion information for when this is marked to be able to be deleted. Now, if we try to go ahead and run compaction, which we're going to, it is not going to delete this tombstone. It's still going to live on until the amount of GC grace seconds, which is 10 days. And then once a compaction runs, it would go ahead and get rid of the data in the tombstone. Let's try this out just to see for ourselves. So let's go ahead and run compaction. Normally, you do not run this manually. Normally, you let compaction run automatically. And by default, it will run whenever there's 4 SS tables that are of similar size. It will go ahead and generate a new SS table. So the way compaction works by default is that once you have 4 SS tables of similar size, it will take the contents of all of those, merge them together to create a new SS table, the 5th one, let's say, and then it will go ahead and delete those 4. In our case, we're going to manually run compaction so that we can see that that tombstone doesn't get deleted because of the GC grace amount of time. So bin/node tool space compact, and then we're going to specify that we want to run compaction on the home security Keyspaces home table. By running this command, it's going to take our existing SS tables and combine them into one. Back in our other window where the SS table files are, if you go ahead and do another ls, and we see that the other ones that were there, the files for SS tables 1, 2, and 3 are gone, and there's this new one for 4. Let's look at the contents of that. Back in the window where Cassandra's installed, let's do an up arrow to access our SS table to JSON command. Let's change this to 4 and go ahead and run it. And we're going to see all the data that's in the SS table for this node, for this table. And in here, you see that the tombstone still exists. Marked for delete at, local deletion time, columns, etc. Because the GC grace seconds amount of time hasn't happened, so it doesn't want to go ahead and delete the data and the tombstone too early, because if another node in the cluster also has this data and that node was down, so it doesn't know about the deletion, and then it comes back up after this has been removed, it will think that, oh, this node over here needs this data, and it'll go ahead and copy it over there. So that's why deletions work the way they do. It's a combination of tombstones, GC gray seconds, and compaction. Let's learn about TTLs, which stands for time to live, and how to use them. TTL is a way to specify an expiration date for data that's being inserted. For example, in this insert into command, you see using TTL 30. So this means this data will live for 30 seconds. You might have vehicle data that you're inserting into a location table that you want to last for just 3 months or 6 months. So you could specify that using TTL clause. TTL values are marked with tombstones once they've expired. Then, once the GC grace period of time has passed, the data can be deleted from disk through compaction. Let's go over to our virtual machines. And in our CQLSH window, let's change the vehicle tracker key space, vehicle_tracker, semicolon, so that we'll be able to see what's going on behind the scenes as we go through creating a TTL. Let's first go flush the memcache for the location table. In the window where Cassandra's installed, let's do a flush. You can probably do an up arrow to find a recent flush you ran and just edit the command. Flush, vehicle tracker, space location, enter. So now when we do our TTL, we'll be able to go back, look at the SS table files and see what got written. In CQLSH, we're going to run that command you saw on the previous screen, which was insert into location, It's a lot of typing. So let's jump over to our working files folder. Let's open up insert into location1.txt, your text editor, so that we can select that and copy it. We're inserting this new row, and we're saying that we just want it to live for 30 seconds. In CQLSH, right-click and choose Paste. Now, this is only going to last for 30 seconds, so right after we run this, let's run a select expression so that we can see the value in the table, and then we'll see that after 30 seconds, it's gone. Run this. And then immediately, let's do a select star from location. And if we scroll up a little bit, so there's the record we just inserted. And then after 30 seconds, let's rerun that command, and we should no longer see that row in our table. So now it says 30 rows, and when I scroll up, it's gone. So that's how time to lives work. Now let's take a closer look at how they work on the back end. In our window where we were looking at the SS table files, in that terminal window, let's do cd space .. /.. go up a couple directories, and then let's do an ls vehicle_tracker /location to see the contents there. So these are the SS table files from when we flushed before we ran the TTL command. So now go to our other window, the Cassandra directory, and let's do an up arrow to go ahead and rerun flushing the memcache for that table. And then back over here to this window, up arrow to redo the ls. And we've now got the new files for this second SS table. And if we're curious to see the contents of the data file, go back over to this window, do an up arrow to find the SS table to JSON command. We'll edit this to look at the one for vehicle_tracker /location /, and if you start typing it in, you can hit tab, so it'll help you out. 2 tab, D for data, tab, and then enter. And we can see what got written for this insert record, including the D markers for deletion. If we had run this SS table to JSON tool before the 30 seconds were up, we'd be seeing E markers for expiration. Because the time has passed, we're seeing them as Ds. when data is being inserted, there's the option to mark it with a time to live. And once that time has passed, and then the GC grace period of time has passed, the data can then be deleted through compaction. Updating the time to live for data is possible via the update command with the using TTL clause. We see an example of this here. So the update command, as we've used previously, but now also with the using TTL. And this number, of course, in seconds for specifying how long we want this data to live. Let's go back to our virtual machine. In our CQLSH window, let's update the record that we had previously inserted. And we had previously told it to just live for 30 seconds, but now we've decided we'd like it to live for 90 days. We could start typing this in, update, or it's quite a bit of typing. So let's go to our working files folder and open up update_location.txt in a text editor, and then copy and paste it into CQLSH. So update location being the table we want to update, and then using time to live of 7,776,000 seconds, which is 90 days, and then set, and then specifying the columns and values we want to have. Where clause to limit this update to just the row where the vehicle ID is this value and the date value is this, and the time value is this. Let's select this, select all, copy it, and then back in CQLSH, paste, enter. And now if we rerun our select star from location command, we'll see that we now have 31 rows instead of just 30. We see our row is back. And because we set its time to live for 90 days, that's how long it'll be available to users. And then after those 90 days, it'll have a tombstone. And then after the 10 days of GC grace period, it'll then be eligible for compaction. It is possible to update the time to live for data, and you do that through using the update command with the using TTL clause. In this unit, we learned about updating and deleting data in Cassandra. Let's do a few questions. Number 1, what is the CQL command for updating data? Is it A, update data, B, data update, C, update now, or D, update? Update. That's our CQL command when we want to update data. Number 2, what is the CQL command for deleting all of the rows in a table but leaving the table? Is it A, delete, B, clear, C, truncate, or D, drop? It's truncate. That's how we can clear out all the rows in a table and yet leave the table. Number 3, when does data actually get deleted from disk? Is it A, as soon as the delete command is executed, B, as soon as the GC grace seconds time has elapsed, C, after the GC grace seconds time has elapsed, then during compaction, or D, data never gets deleted from disk? What's the correct answer? C. When it gets marked to be deleted, that's the tombstone. And then once the GC grace seconds period of time has elapsed, which by default is 10 days, then it's eligible for deletion during compaction. So whenever compaction then runs after the GC grace seconds time has elapsed. Last question, number 4. When does TTL, otherwise known as time to live, data get deleted from disk? Is it A, TTL data never gets deleted from disk, B, as soon as the TTL time has elapsed, C, as soon as the GC grace seconds time has elapsed, or D, after the TTL time has elapsed, then after the GC grace seconds time has elapsed, then during compaction. And I bet you know it's D. All of those things need to happen. That's something to think about if you're thinking that, oh, I'll just have the data elapse after 1 day or 1 hour or some short period of time. It'll then no longer be available to any applications that are accessing the data, but it doesn't just automatically clear it off disk. These other things need to happen as well. Unit 10 Lab, update and delete data. First, in the home table for home ID of 8014747777, we're going to update the contact name from Jed Clampett to Mr. Drysdale. Then, in the activity table in the home security keyspace, we're going to delete all the activity data for home ID 802257222. Then we are going to insert a row into the activity table with the following values into the home ID, date, time, and event columns. And we're going to have this data go in with a time to live of 20 seconds. That, by the way, is a very short period of time. If you'd like, feel free to make that longer. And then finally, we're going to update the time to live for that new row to be 6 months, thinking that that's how long we want to hold the activity for the home alarm systems. I recommend that you go ahead and pause the movie so you can go through and do the steps in the lab. If you get stuck anywhere, you can unpause the movie to play it and do the steps with me. In our CQLSH terminal window, let's change the key space to home security. So use space home underscore security, semicolon. And then let's do a select so that we can look at this record that we're going to be changing. Select home underscore ID, address, contact name from home where home underscore ID equals single quote 801474777. Closing single quote, semicolon, enter. I must have put a typo in there. Ah, yes, I had a spare comma. Let me go ahead and just up arrow, go back and get rid of that. Enter. So that's the record that we want to update the contact name for. How do we do that? The update command. Update home, set contact underscore name equals single quote Mr. Drysdale, where home ID equals 801474777. Enter. I'm going to up arrow to find my select expression from before. It's updated. The next thing we're going to do is we need to delete all the activity for home ID 802257222's alarm system. Let's go ahead and do a select for this so we can see what we're dealing with first. So select space home ID, comma, date time, comma, event, comma, code underscore used, space from activity. And we see that, yes, indeed, there is data in here for 802257222, and we need to take that out. Back down at our command prompt here, what are we going to do? We're going to do a delete. Delete from activity where home underscore ID equals, single quote, 802257222. Enter. Up arrow, get our select expression back so we can run it. Yes, now there's only 28 rows. And when I scroll up, I see that data's gone. Step number 3 in our lab is to create a TTL for some data we're going to insert. Insert into name of our table, which is activity. And we're inserting data into the home ID column, the date time column, and the event column. And the values that we want to insert in here are home ID of 801033638 and the date time is 2014-05-22. And the time for this event is 14:43:07. And the event that happened was alarm breached. And then we're going to initially have a time to live of 20 seconds. So let's go ahead and hit enter. And if we do an up arrow to rerun this select statement within 20 seconds, we see that we now have 29 rows. And this one here was indeed added. Now, if we go to run that again, that select expression, now that 20 seconds have passed, we see that there's only 28 rows. And if we looked in the list here, we would see that that one that we entered is now gone. And then our last task is to update its time to live so that it's 6 months from now. So to do our update so that the time to live will now be 6 months, let's enter update, name of the table, which is activity, using TTL. And if we got our calculator out, we would figure out that it's 15,552 seconds for 6 months. And then set event equals single quote alarm breached, where home_ID equals 801033638, closing single quote, and date time equals 2014-05-22 14:43:07, closing single quote, semicolon. Let's go ahead and run that. So we've updated that record to have a time to live of 6 months. So let's go back and do a select on that table. We see that we have 29 rows. And if we scroll up, we see that that row is back, and it will in fact be there for 6 months. So that was our lab on updating and deleting data. Let's talk about hardware. Hardware choices matter for the performance of Cassandra. Although Cassandra does not require special hardware, it is important to ensure that at least the minimum recommendations for RAM, CPU, and storage are met. Each of these is key for having a highly performant distributed database, and we'll be looking at each of these in the coming couple of movies. Let's talk about RAM and CPU. The minimum amount of RAM recommended per Cassandra node is 8 gigabytes. In production, 32 gigabytes of RAM per node is common. The more memory that's available, the better Cassandra's read performance is. This is because the more data that it already has cached, the less chance that disk seeks will be needed, which are, of course, time-consuming. Like RAM, the more CPU power that exists, the better Cassandra's performance will be. Cassandra is highly concurrent and will take advantage of multiple cores. The minimum number of recommended cores is 4, whereas in production, 8 or more cores is common. Let's go take a look at how much RAM we have assigned to our virtual machine. So let's jump on over to our VM. If we look in the settings for the virtual machine, go to processors and memory, we can see that the virtual machine has been allotted 1.5 gigabytes of memory, which has been fine for our training purposes. Now, in the upcoming unit, we're going to be adding 2 more virtual machines to our cluster to end up with a 3-node cluster. And each one is going to have 1.5 gigabytes of memory assigned to it. For the next unit, we're going to need a total of 4.5 gigabytes of memory. And then in the second to last unit in the course, we're going to be adding a 4th node, which is going to be another 1.5 gigabytes. So for the virtual machines for the course, we're going to need 6 gigabytes of memory. And because you'll need some memory for your computer's operating system, we've recommended 8 gigabytes for the course. So you probably checked earlier how much memory you have. If you want to look again, if you're on a Mac, you could look under the Apple menu, choose About This Mac, and it'll tell you how much memory you have. So on this computer, I have 8. If you're using Windows as your operating system, then you'll want to right-click on My Computer and go to Properties, and then it'll show you how much memory you have. If you're using Linux, you can use the top command on the command line to tell you how much memory you have. This movie was on CPU. You want at least 4 cores in production, and memory. And here for training, we're getting by with 8 gigabytes of memory on one computer to run 4 nodes. But of course, normally you would want to have a lot more memory per node, really starting at 8 gigabytes per node and going on up. The type of storage used for Cassandra can greatly affect performance. Storage considerations include whether the storage is shared, the type of drive, and capacity. Shared storage can have a significantly negative effect on the performance of Cassandra. This is because if the disk head is often being pulled to service others, it will take longer to service the request to your database. Hence, it's highly recommended to not use shared storage. For type of drive, solid-state drives, SSDs, are preferred. They provide much faster performance than spinning disks. Having said that, either can be used with Cassandra. With regards to capacity, it's generally better for performance to have more nodes in your cluster with less data on them, rather than just a few nodes in the cluster with tons of data on them. The recommended amount of data per node varies with the type of disk being used, but it's generally from 500 gigabytes to 1 terabyte. To provide maximum write performance, it's recommended to have a separate drive for the commit log. By having a separate drive for the commit log, the disk head does not need to move and so can continuously be used to write commit log entries. It's fine for the commit log disk to be a spinning disk, as the disk head does not need to move. The location of the commit log, it's configurable in the cassandra.yaml file on each node. Now that we've talked a bit about CPU, RAM, and storage, let's go take a look at a reference document provided by DataStax. So if you'd like to follow along with me, you'll want to go to datastax.com, basically this URL, or it might be faster if you just search in Google on DataStax Enterprise Reference Architecture. That'd probably be the fastest way to get here. And once you get here, at the top, it says DataStax Enterprise Reference Architecture. And it's a nice document. It's got a lot of detail about recommendations for hardware. And if we glance at the table of contents, you'll see there's recommendations for storage, CPU, and memory, as we were just talking about. Let's scroll down and take a look at these. So if we scroll down to capacity planning and storage, you can see more detail in here about the storage recommendations we talked about, especially not wanting to use shared storage and preferring to use SSD drives if possible. If we scroll down a little bit more, we'll see recommendations for CPU and memory. And let's scroll down a bit more so we can see a couple examples of recommendations. So here under deployment scenarios, here's a low-end specification. In this case, a server with 8 cores or more, RAM starting at 16 gigabytes, but really 32 gigabytes or more preferred. Storage, spinning disks are listed here, although of course, if we have SSDs, we prefer those since they're faster. Network and data size. Now that we've looked at a low-end production recommendation, let's look at a high-end. This server has 16 cores, 128 gigabytes of RAM, storage, spinning disks, or SSDs, network and data size. Down here under data size, it says if you're using SSDs, possibly up to 5 terabytes of data per node. So just to recap on storage, you want to avoid shared storage. You want to use SSDs if possible, otherwise spinning disks are okay. And for capacity, depending on the type of drive you choose, anywhere from 300 gigabytes up to 5 terabytes, with 500 gigabytes to 1 terabyte being the norm. Along with the option of purchasing and setting up your own hardware for your Cassandra cluster, you also have the option to use the cloud platform. Here in the DataStax reference document that we were previously looking at, we have a couple cloud platforms listed. One is Amazon. Amazon is very popular for Cassandra deployments, such as Netflix. If you have up to 1 terabyte of data you'll be putting on each node, you might look at this instance type. It's the i2.2x large. It's got 60 gigabytes of memory and uses a solid-state drive. If you're just going to be putting up to 100 gigabytes of data on each node, you might look at either of these instance types. The second one here, the C3.2x large, comes with 15 gigabytes of memory and SSD. Let's go take a look at the wide variety of instance types on Amazon site. Go to a browser window and enter aws.amazon.com/ec2/instance-types. You're going to land at the top of this, which is Amazon EC2 instances. And as you scroll down through the list, you'll see that there are lots of different Amazon instance types to choose from. If you scroll on down to the i2 family, you'll see a group of instances that provide very fast SSD-backed instance storage optimized for very high random I/O performance. And if we look over here on the right, we'll see the one we were just looking at, which is the i2.2x large, great for up to 1 terabytes of data per node. And you can see down here under use cases, it even mentions Cassandra. Let's also go ahead and take a look at Google's instance types that are recommended for Cassandra. So if I go back over to our reference document and we look down here under the Google Cloud Compute Engine section, we can see that if we've got up to 1 terabyte of data we're going to be putting on each node, that we'd probably want to look at the N1-HighMem-16 instance type, which comes with 104 gigabytes of memory. Or if we only need up to 200 gigabytes of data per node, then we could look at using the N1-Standard-8 instance type, which comes with 30 gigabytes of memory. Let's jump over to Google's page on this so we can see the choices and pricing. So in a browser window, if you go to cloud.google.com/products/compute-engine, and you'll first land at the top. So this is Google's page for the cloud platform, which is called Compute Engine. Scroll down. There's features, case studies, a pricing calculator. Scroll down a little bit further. We'll get down to machine type pricing. And down here under high memory, we see the N1-HighMem-16 instance type, which is great for up to 1 terabytes of data per node. Or for a less expensive solution that would support up to 200 gigabytes of data per node, we've got the N1-Standard-8, which has 8 virtual cores and 30 gigabytes of memory. We can see the pricing over here on the right. Along with being able to set up your own hardware for creating your Cassandra cluster, you also have these cloud platforms as an option. There's a lot of them out there, and these are just a couple of them. So if you're interested in doing a cloud deployment, take a couple minutes to check these out, as well as others you may be interested in. The focus of this unit was on selecting hardware for Cassandra, specifically RAM, CPU, and storage. And then we also talked about deploying in the cloud. Number 1, true or false? Cassandra is able to take significant advantage of multiple cores. Is that true or false? It's true. The more cores you have, the better. Number 2, true or false? 8 gigabytes to 32 gigabytes or more of RAM per node is recommended for Cassandra. True or false? True. The more memory, the better. You really want at least 8 gigabytes of RAM per node, with many production systems actually starting at 32 gigabytes per node of memory. Number 3, true or false? Shared storage is recommended for use with Cassandra. That is definitely false. We really don't want to use Cassandra with shared storage. We don't want other systems competing with ours, pulling that disk head away from our database over to theirs and then back, potentially creating lots of I/O contention. Number 4, true or false? It is a good idea to have a node's commit log write to a drive that is separate from the drive being used for reads. True. For performance, it's definitely going to be faster performance for the writes if we can just have them happening on a separate drive where the disk head doesn't have to move, so that they just keep getting written to that commit log without any contention. Number 5, true or false? Cassandra can be deployed in the cloud only with Amazon Web Services or Google Compute Engine. Definitely false. Along with these 2 cloud platforms, there are many, many more. In this unit, we'll be adding nodes to our existing cluster of 1 node, so that by the time we get done with this unit, we'll have a 3-node cluster. As each node in a Cassandra cluster has the same functionality as the other nodes, it's fairly easy to add a new node. To add a new node, it needs to have the same cluster name as the existing nodes in the cluster, and it needs the IP address and network access to at least one of the nodes in the existing cluster. Let's go ahead and start setting up a second VM so that this can eventually be a second node to join our cluster. So if you'd like to follow along with me, let's go to our working files folder. And there's a second zipped virtual machine file. It's called virtualmachinex.zip. We're going to use this to create a second virtual machine, a third virtual machine, and later on, a 4th virtual machine. Let's go ahead right now and double click on it to unzip it. Or if you're on a platform such as Windows, you'd be right clicking and choosing extract all. Or on Linux, you'd be unzipping it, perhaps using the unzip command. Once this unzips, let's go ahead and rename it to Virtual Machine 2. Since, as I mentioned, eventually we're going to have a 3 and a 4 as well. And then let's go ahead and open it up. So if you double click on it, and for those of you on Windows, keep in mind you're down inside of a subfolder looking for the file that has the extension of .vmx, and that's the file you're double clicking on. If you get this message about other virtual machines also running, that's okay. That's our virtual machine 1. Just click on OK. And if you get this message about the virtual machine might have been moved or copied, you're going to choose I copied it. And then as the virtual machine boots up, you'll eventually make it to the password window here. And you're going to enter Ubuntu, same password as we used in virtual machine 1. And then once we get into the virtual machine, it's named Virtual Machine X. And since we are planning to have 2 more of these, let's rename this so that we can have a different name for each one, just to keep our sanity as we're working across these different virtual machines. So let's go up to Virtual Machine Settings. The equivalent for doing this on Windows is going to be Player Manage Virtual Machine Settings. This is what I'm using with VMware on the Mac, but if you're on Windows, again, it's Player Manage Virtual Machine Settings. And then in here, if you're on a Mac, you're going to double click on the General icon. If you're on Windows, you're going to select the Options tab. And then inside of here, we can rename our virtual machine. Here it says name, and then over on the right, I'm going to change that X to be a 2. And if I go ahead and click anywhere, like down in the notes area, I see the name's changed. I see it's also changed up above. Let's close this extra window. Oh, if you get an upgrade message, we don't need that. You can choose don't upgrade if you happen to see that message. So now we've got a second virtual machine, which we'll be working with as we go forward to eventually have it join our cluster that our virtual machine 1 is in. In this movie, we get our 2 virtual machines set up with static IP addresses and able to ping each other. The nodes for a Cassandra cluster need to be in a network that allows them to communicate with each other, which makes sense. In addition, as Cassandra is a distributed database, the faster the network connection between the nodes, the more performant Cassandra can be. Recommended bandwidth is 1,000 megabits or more per second. Some of the common ports used in Cassandra are 7,000. This is the one used for gossip, Cassandra's intra-node communication. 9042, which is the native binary protocol. We were using this when we were using the DataStax Java driver to connect to Cassandra from our Java application. 9160, which is for a Thrift client. So this is an older port. 7199, which is for JMX monitoring, which is commonly used by the various monitoring tools, which we'll be looking at in our unit on monitoring, such as Node Tool, JConsole, and DataStax Ops Center. By default, the course virtual machines use the network connectivity of the host computer, which is your computer, to connect externally, like to go out to google.com. On the host computer, each virtual machine is given a dynamic IP address by default. Over time, the dynamic IP address assigned to a virtual machine may change, which would stop Cassandra from working. To avoid this problem, we can assign static IP addresses, which we'll be doing. Static IP addresses can be assigned to Ubuntu virtual machines by gathering the network settings for the host computer and then using them in the system settings of the virtual machines. So we'll be going through this. We'll take those network settings for our computer, and then we'll apply them to create static IP addresses for each of our 4 virtual machine nodes. Right now, we'll be doing this for 101 and 102, and then later we'll be adding in 103 and 104. Let's jump over to our virtual machine 1. In VMware, you can switch over to your virtual machine 1. In a terminal window, I'll just open up a new one here. Let's enter ifconfig so we can see the dynamic IP address that's currently assigned to this node. It's right here. Go ahead and jot that down. You can either put that in a text editor or a piece of paper. We're going to be using a part of this for defining our static IP addresses. Let's do the same thing for our second virtual machine. Let's jump over to virtual machine 2, open up a terminal window, enter ifconfig, and take note of that dynamic IP address. Let's go ahead and see if they can communicate right now before we convert it over to static IP addresses. At the command prompt, let's put ping, and then you're going to put your IP address of virtual machine 1. So in my case, virtual machine 1's IP address is 192.168.159.180. Hit enter. So my virtual machines are currently able to communicate with each other. You can do Command-C or Control-C to stop the pinging. Now what we want to do is we actually want to set these to be static IP addresses so that we don't have to worry about the dynamic IP addresses changing over time and having our cluster stop working, which we obviously don't want. Let's go ahead and note a couple more things. So if we scroll back up, let's note the broadcast address and the mask. And this will be the same on both your VMs. Grab it from either one. All right, now let's enter one more command to get some more network settings we're going to need. nm-tool. That's going to give us the gateway address. So go ahead and jot that down. And the DNS address. Go ahead and jot down what yours is. So let's go ahead and change this to be a static IP address for this virtual machine. We're going to do this for each of them. Doesn't really matter what order we do them in. Let's go ahead and close everything. Close your virtual machines. Where you have CQLSH running, you probably remember how to get out of there. You can do exit, close that window, close that one. Where you have Cassandra running, you can go ahead and do either a Command C if you're on a Mac like me, or Control C if you're on Windows. That'll go ahead and shut down Cassandra. Close that. In the next video, we pick up where we left off here. Picking up where we left off in the last video, let's go up to the gear icon here in the virtual machine and choose System Settings, and then the network icon, and then the Options button. And then we're going to select the IPv4 Settings tab. For the method, we're going to specify manual. In the addresses area, we're going to click on the Add button. And we're going to put in the static IP address that we want to assign to this virtual machine. From your IP address that you picked up earlier, you're going to put in the first 3 octets. In my case, it's 192.168.159. And then, because this is my first virtual machine, I'm going to put 101 as the address. The next one I'll do is 102, 103, 104. The important part is that they're unique. And then for netmask, so that's our mask IP address that we picked up earlier. Mine was 255.255.255.0. For gateway, let's go ahead and enter that. The gateway address that we jotted down from earlier, so 192.168 for me, .159.2. And then finally, DNS servers, you're going to enter the IP address that you wrote down. This is what mine was. Let's click on the Save button to save our static IP address settings for this virtual machine. If you get this little bug error window, that's okay. Just click on Continue. It'll actually still work. You can see your settings here. We can close this window. And let's restart this virtual machine. If you're on the Mac, it's going to be Virtual Machine Restart. If you're on Windows, it's going to be Player Power Restart Guest. Are you sure? Yes. Once it's restarted, let's put in our password, Ubuntu. And then let's open up a terminal window and check that our static IP address is there. Open up a terminal window. And what are we going to enter? ifconfig. There is our static IP address. If we want to just make sure we still have internet access, we could open up a browser window here, like Firefox. And sure enough, still got internet access, so all is well. Let's jump over to our second virtual machine to do the same thing, to give it a static IP address. So window virtual machine 2, we can close this window, and let's go up to the gear icon. Select System Settings, go to Network, go to the Options button, select the IPv4 Settings tab, select Manual, and the addresses, click on Add, put in your static IP address for your second virtual machine. So for me, that's 192.168.159.102. Put in your mask setting, 255.255.255.0. Your gateway IP address, for me, that's 192.168.159.2. And then finally, your DNS server IP address, 192.168.159.2. All right, go ahead and click on Save. If you get this message, that's okay. Just click on Continue, it's fine. And you can close this window and restart the virtual machine. So virtual machine restart. If you're on Windows, that's Player Power Restart Guest. Once that comes up, we'll put in our password of Ubuntu. Go ahead and open up a terminal window and enter ifconfig. The static IP address is there. Great. And let's go ahead and try pinging VM1. Ping. And then you're going to put in the IP address for virtual machine 1. In my case is 192.168.159.101. And it's pinging. All is good. Control C or Command C to stop the pinging. In the next video, we pick up where we left off here. Picking up where we left off in the last video, let's go to VM1, and at the command prompt, we're going to make the host names for the virtual machines unique. Right now, they're both just called Ubuntu. We're going to have them be VM1, VM2, VM3, VM4. So at the command prompt, go ahead and do sudo space vim space /etc/hostname. So we can edit the host name for this virtual machine. For sudo password, it's Ubuntu in all lowercase. You can see that right now it's Ubuntu. We want to have a unique host name for each of our virtual machines. Let's go ahead and edit this by pressing the I key so that you can edit the text inside of here. And enter VM1 and then the delete key to clear out the old name. Save and exit by pressing the escape key and then colon, W for write, Q for quit. And then while we're still here in this VM, let's do one more thing, which is sudo vim /etc/hosts to access the list of hosts. And what we want to do is we want to add in our list of IP addresses and host name associations. So if you maybe just go down to this blank line and then press I to be able to edit the file, you could hit enter a couple times to give yourself a blank line. And then what you're going to do is enter in the IP address of each of your VMs. We're ultimately going to have 4 VMs, and we're just going to go ahead and take care of this now so we don't have to come back here later when we add the other ones. 192.168.159, so your IP address, and then 101. We want to associate that with the host name of VM1. And then I'm going to do a little copying and pasting here. So I'm going to highlight this, right click and choose copy, and then right click and paste. Right click and paste. And then I can just use the arrow keys to modify this. So this will be for VM4, VM3, and VM2. While we're here, let's copy this because we're going to put this into the VM2 one. So we're just going to highlight these lines and copy them. All right, let's save and exit this file. So escape, colon, WQ, enter. And then you can close and restart this VM. And then we'll go over to virtual machine 2 and just do these last 2 steps to change the host name and put in the IP addresses and host names of the virtual machines that we're going to be creating. So over in virtual machine 2, on a command line, sudo space vim space /etc/hostname. Sudo password is Ubuntu. I to be able to insert text. VM2, delete, 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 get rid of those extra characters. Escape, colon, WQ to write and quit. And then finally, sudo vim /etc/hosts. Down arrow, I, insert text, and then right click, paste, escape, colon, right quit, close this, and restart this virtual machine. Once this comes up, let's enter the password. Same goes for our other virtual machine. And then once they're both up, let's do one last ping. This will be with the host name, just to make sure that the networking is all set up between these 2 virtual machines. So we'll open up a terminal window. I'm doing this in virtual machine 1. I can do ping VM2. Awesome. It's pinging. Command C or Control C to quit the pinging. And we've now got both our virtual machines set up with static IP addresses and able to communicate with each other. The next thing will be to get these two Cassandra nodes communicating with each other and on the same cluster. Now that we have our two virtual machines with static IP addresses and able to communicate with each other, the next thing is for each node to specify in the cassandra.yaml file the IP address of the node. Specifically, we need to specify the listen address and RPC address properties. The listen address is for specifying the IP address of the node so that other nodes in the cluster can communicate with the node. The RPC address is for specifying the IP address of the node so that a client application can communicate with the node. Let's jump over to virtual machine 1. And on the command line, if you have forgotten the IP address, you could, of course, do ifconfig. Copy it while you're here. And then we need to go into the cassandra.yaml file and enter this. Let's do vim. I'm going to start typing Cassandra, the name of the directory, and hit tab/Apache tab -Cassandra -2.0.7/conf/Cassandra.yaml. Basically need to edit our main configuration file. And in here, we could either scroll down to the listen_address property. It's at line 297. Or we could do a search by typing / and entering the name of that property, which was listen_address. When you first install Cassandra, it's set to localhost. But now that we want to have a multi-node cluster, we can't just leave it as localhost. Let's go over here and to insert. Put in the IP address for this node, which for me is 192.168.159.101. So you're putting in the IP address for your virtual machine 1, which is the one whose configuration file we're editing right now. And then not only do we need to specify the IP address for listen address, which is so that other nodes in the cluster can communicate with this node, but we also need to specify RPC address so that client applications can communicate with this node. We could scroll down to find that property or search for it. Line 335, there it is. So let's remove localhost and put in the IP address of this node. Mine's 192.168.159.101. All right, we need to do the same sort of thing for our VM2. Let's save and exit this by pressing escape:\WQ enter. And let's jump over to our virtual machine 2. Open a terminal window. Edit our cassandra.yaml file. Vim space Cassandra /Apache-Cassandra-2.0.7/conf/Cassandra.yaml. Let's do a search. /listen address. To edit 192.168.159.102. And then let's scroll down to line 335. Get rid of localhost. 192.168.159.102. So again, putting in the IP address for our second virtual machine. All right, let's press escape:\WQ. So this was specifying the IP address of the node in the cassandra.yaml file. And this is something you do need to do for each node in your cluster. Let's talk about seed nodes. Seed nodes are regular nodes that, via their IP address, provide a way for new nodes to join the cluster. The IP address for at least one seed node is needed for a node to be able to join the cluster. Seed nodes are specified in the seeds property of the cassandra.yaml file of each node in a cluster as a comma-separated list. Here, in this cassandra.yaml file, we have the seeds property with 2 seed nodes. And this is very common to have 2 or 3 seed nodes so that if the first one is down, then the new node can go in through the second or third. While it's common to have 2 or 3 IP addresses listed for seed nodes, it's certainly not necessary to put the IP address of every node in the cluster in the seed list. If you put 2 or 3, you have 1 or 2 backups. That's considered plenty for most people. If you wanted to, you could certainly put more. Really, all it takes is 1 seed node for that new node to be able to join the cluster and learn about all the other nodes. Let's now go edit our virtual machines, the Cassandra.yaml property file, so that we can specify a seed node for both of our nodes so that once one of them is up, the other one can join that same cluster. So let's jump on over to our virtual machines and let's go into virtual machine 1. And on the command line, let's go ahead and edit our Cassandra.yaml file. So if you had just run this vim command like I did, you could do an up arrow and hit enter, jump back into that file. And let's scroll down to line 227, or you could of course do / and enter seed_provider to jump down there. By default, what's listed in the seed node list is 127.0.0.1. Let's go ahead and edit that. Let's do I. So we can insert text. Let's enter in the IP address of VM1 since we're planning to bring up that node first. So 192.168.159.101. So you're putting in the IP address for your VM1. Save and quit, escape :WQ. And now let's go to VM2 and we're going to put in the same seed node address. So let's do the up arrow to edit our Cassandra.yaml file. Let's scroll down to line 227 to our seed provider property. I to edit this. And for our IP address, we're going to put in the IP address of VM1. Put in your IP address for your VM1. Because what we're going to do is we're going to start at VM1 first. And then when we go to start at VM2, we needed to go locate VM1 and communicate with it so it'll be able to join the cluster. Escape :right quit. All right, let's go ahead and start at VM1. So let's jump back over to it. Let's go ahead and change directories. Let's go down into the directory where Cassandra's installed. CD space Cassandra / Apache -Cassandra -2.0.7. And then let's go ahead and start up Cassandra on this node. As you may recall, bin / Cassandra space -F to run it in the foreground, which makes it easier for us to quit if we ever want to stop Cassandra running on this node. So let's go ahead and hit enter. As this first node starts up, it's using itself as the seed node. And once we see the message of listening for thrift clients, we know that it is up and running. So we're going to leave Cassandra running in a terminal window up here. And then let's give ourselves another terminal window. So in the second window, let's also go to where Cassandra's installed because we're going to be setting up a watch for node tool status so that we'll be able to see as the second node joins the cluster. Here, let's do watch. And for every 2 seconds, we want node tool status to run. Initially, what we see here is that we have 192.168.159.101 is up and it's normal. So that first node is up and everything is good. Just want to make this window wide enough so that it will look tidy as we add additional nodes. So our first node is up, and then in the next movie, we're going to be bootstrapping, basically adding our second node to the cluster. This movie was on seed nodes, and the fact that you need to have at least one seed node defined so that a node has an entry point for getting into the cluster And in our case, we specified the seed nodes for VM1 to be the IP address of VM1. And then we specified the seed node for VM2 to be the IP address of VM1. When we later go on to add VM3, what we'll do is we'll specify two seed nodes. We'll specify the IP address of VM1 and VM2, so that if one of them happens to be down, VM3 can still join the new cluster. And you might be thinking, well, what if VM1 goes down and needs to join the cluster again later? What would you do? Well, what you would do at that point, because the cluster is up and running at this point without VM1, is you would go edit the cassandra.yaml file of VM1 and specify seed nodes like VM2's IP and VM3's. Initially, though, we had to specify just one IP address for the seed node because we only had one node in the very beginning. Let's talk about and then bootstrap a node. Adding a node to a cluster is called bootstrapping. In order to bootstrap a node, it needs to have the same cluster name as the nodes in the cluster it's to join, and it needs to be on a network that allows it to connect to the IP address of at least one of the seed nodes. Once a node is able to join a cluster, if the auto bootstrap property is set to true, the node will start to take on responsibility for the data in its token range or ranges. Specifically, with the default of virtual nodes defined through the num tokens property in the cassandra.yaml file, the node will take on responsibility for many small token ranges, whereas if the cluster had instead been configured the old way with the initial token property, the node would just take on responsibility for one large token range. The node will begin by accepting write requests and then eventually also accept read requests. If there are multiple nodes to be bootstrapped, give time between each one so that the cluster can smoothly bootstrap each node. Let's go bootstrap Virtual Machine 2. Let's go take a look at this configuration file and some of the properties that we were just talking about. So if you do an up arrow, go ahead and go into cassandra.yaml. And let's scroll down and just take note of a few properties like cluster name right here on line 10. So they all have to have the same cluster name. And VM1 has the cluster name of test cluster, and so does VM2. So that's fine. And then let's scroll down a little bit further to line 24 and note the num tokens property. Because we have this property and it has a value, that means we're using virtual nodes. So that means that this node, as it joins, is going to be responsible for 256 little token ranges, like little slices off of the existing token range. You notice just below it here, it mentions the initial token property. If we were using that instead, basically use one or the other of these two properties. So if we were not using virtual nodes, we'd be using initial token, and we would be specifying the endpoint for the token range that it's responsible for. That's fine, but that's the older way. And the reason that we really like the new virtual nodes way of handling the token ranges is because when we go to add a new node to our cluster, we don't have to worry about going back and adjusting the endpoints of the other nodes to try and keep the data load balance between all the nodes. Let's do a search on the auto bootstrap property. So if we do / and type auto_bootstrap, we're going to see that it doesn't exist. In earlier versions of Cassandra, there was an auto bootstrap property, which you can still specify, but now you don't see it listed and it's true by default. So that means when this node joins the cluster, it's going to go ahead and start taking on responsibility for the data in its token ranges. Let's escape out of here. So escape, :Q, enter. Let's go ahead and start up Cassandra on this node. So let's do a cd Cassandra / Apache Cassandra 2.0.7 to go to that directory. And then in here, let's start it up. Let's do bin/Cassandra --F to run it in the foreground. And once we start this, let's jump on over to Virtual Machine 1 so we can see this node getting added to our existing cluster. So let's hit enter. And then in window, let's go to virtual machine 1. In our last movie, we had set up this watch to basically run node tool status every 2 seconds. So as this is getting updated every 2 seconds, I can see that this IP address here for this guy is up and it's joining. So the J stands for joining here. So now I see that it owns approximately 50% of the token range. I see that at the moment its load is only 30 kilobytes, but there it goes. It's gone higher there. We're dealing with an extremely small amount of data in our case. We will be loading more data later so that we can see this working with a heavier load. But what would normally happen if we did have bigger numbers in here is that we would see the second node joining, that it would be taking on approximately 50% of the data that's on the first node. Now, it doesn't take the data off of the first node, but it does go ahead and copy over half of it, basically the data that it's responsible for based on its token ranges. And so normally if these are bigger numbers, you would see this be, if it was 125, let's say megabytes, then you would expect this to be like 60. So our cluster initially was just one node, which was VM1, but now our cluster has 2 nodes, VM1 and VM2. And if we want to run node tool status from VM2, we could certainly do that. Jump on over to virtual machine 2, give ourselves a new window. I'm just going to make this one small. So in our new terminal window, we could change directory down to where Cassandra is installed. And we could run bin/node tool status to see our cluster information from here. We can definitely do that from either node. If I go ahead and up arrow and run that again, I can see it stretched across the whole window. So there we are. We've got 2 nodes in our cluster and they are both up and normal. In this movie, we talk about cleaning up a node. When a node auto bootstraps, it does not remove the data from the node that had previously been responsible for the data. This is so that if the new node were to go down shortly after coming online, the data would still exist. To tell Cassandra to delete the data that a node is no longer responsible for, the cleanup command can be used. Here's an example of it. Node tool, and then -h for host, the IP address of the node that you want to clean up, and then the command cleanup. So let's go on over to our virtual machine 1. So if it's not already showing, then go ahead and switch to virtual machine 1. These numbers are very small, so we may not see much difference here, but once we load a lot more data in the next movie, then when we add an additional node, we can run a cleanup and we'll see a much bigger difference. All right, so let's open up a new terminal window. And this is using the node tool command. So let's make our way down to the directory where Cassandra is installed. And then bin/node tool, and then -h for host, and then the IP address of our node 1, which for me is 192.168.159.101. You're going to put in the IP address for your virtual machine 1, of course, and then the command cleanup. So when we go to run this, we're looking to see if the load number here of virtual machine 1 is going to go down. Normally, because we added the other node, which was 2, and it's now taken on the responsibility for 50% of the nodes, normally we would expect that if we now run cleanup, that this number would go down. It's just that because we are working with such tiny loads, we may not see much of a difference. Let's hit enter. We're watching the value over here. Okay, and it went down a little bit. When we do this in the lab exercise, because we're going to have a lot more data in our cluster, and then when we go to add node 3 and we go to run cleanup on VM1 and VM2, you'll see a significant difference as it releases the data that that node is no longer responsible for. So this movie was on the cleanup command, which is a command that you can use to clear out the data that a node is no longer responsible for. And this is a common thing to do when you've added a new node to a cluster, that you would go back to the existing nodes and choose to run cleanup. I should also mention that you don't have to run cleanup. The only reason for doing it is if you wanted to free disk space on those nodes. The Cassandra stress tool, which comes with Cassandra, is handy for stress testing a cluster. It can be used to write data or read data from a Cassandra cluster. For example, Cassandra stress could be used to generate and write 100,000 rows of data. We can do that from the directory where Cassandra is installed, then the tools directory, the bin subdirectory, and then Cassandra stress, and then the node that we want the data to get written to, and then the number of rows that we want inserted. Even though we're specifying one of our nodes, what's going to happen is the data is going to go in through that node, and then it's going to get distributed across the cluster, as you'd expect. So the executable is located in the bin folder of the tools folder, down under where Cassandra is installed. And in using Cassandra stress, a key space with a replication factor of 1, named Keyspace 1, gets generated. Within Keyspace 1, tables named Standard 1, Super 1, Super Counter 1, Counter 1, and Counter 3 are generated depending on the Cassandra stress options used. The Cassandra stress tool has many options, which can be viewed by running Cassandra-stress -h. So if you'd like, you can go ahead and run that. You'll see that this is just the top of the list. There are many, many options for Cassandra stress. Let's go ahead and load some data into our cluster so that when we add a third node, we'll be able to use that cleanup command and see a big difference. So let's jump on over to our virtual machines. As I mentioned, it doesn't matter if you run this command from VM1 or VM2 because the data is actually going to go in and get spread across the two nodes. So I'm here in virtual machine 1, and in the directory where Cassandra is installed, let's go ahead and enter tools/bin/Cassandra stress -d space 192. So you're putting the IP address of either of your virtual machines, either one's fine. 159.101 -n for the number of rows that I want to have inserted. And I'm going to have it write just 100,000 rows. You can have it write many more than this, but 100,000 will be plenty for our purposes right now. Let's hit enter. And we're going to see these rows generated as it's writing the data. You can see the key for this here in the first row, the total, the interval, rate, latency, the 95th percentile, the 99.9th percentile, the elapsed time. And the elapsed time is in seconds. So right here it's telling us it's written 17,000 rows. I told it to do 100,000, so probably have another minute or so here. As node tool status catches up, we'll eventually see these numbers get bigger as the data is being written to the two nodes. So it's done. You see some metrics. I noticed that this number just sprung up here. And I expect that this number will also get a bit larger. We'll give it another minute or two. I don't expect the load to be exactly split, but approximately 10.96 megabytes for the second node and 12.37 for our first one. So now we have some more data to work with as we go forward and do things like add a third node and want to run cleanup on our first two nodes. If you're curious to see where the data went and how it's being stored, let's go ahead and open up CQLSH. In the directory where Cassandra is installed, let's do bin/CQLSH. Because we've changed the IP address, instead of it being 127.0.0.1, which is the default that CQLSH expects, we need to specify the name or the IP address of our Cassandra node. So we'll go ahead and enter bin/CQLSH space VM1. And sure enough, that launches CQLSH for us. Let's do describe Keyspaces. And we'll see that there's now a new keyspace called Keyspace 1. That was generated by Cassandra Stress. So if you're ever wondering, where did that come from? Let's do a describe on it, just for fun. We can see the tables that are inside of the keyspace. So describe keyspace. And then we need to use quotes because it's a capital K. If we tried to do it without quotes, it wouldn't know the keyspace name. Enter that. And then if you scroll through, you'll see the different tables that were generated inside of this keyspace. If we wanted to go look inside of one of them, like standard one, we could do a select star from keyspace 1, quotes, dot. And then because the table name has a capital letter as well, quotes around that, standard 1. And let's say we just want to bring back 10 rows from that table that's in that keyspace. So that's what's in there. It's not common to go look at it. It's really just a stress testing tool. But if you're curious, that's the contents. Let's do one last thing here. And that is, now that we have more than one node in our cluster, let's go back to the application that we built in Eclipse. We've got a vehicle tracker application and an alarm security application. And instead of using the DataStax Java driver to communicate with the cluster through localhost, let's put in our actual IP addresses. Go ahead and open up one more terminal window. And let's run Eclipse by entering Eclipse/Eclipse. Okay. All right, and I'd left some files open. I think I'll just tidy things up by closing those. Earlier, we had created this alarm system application. Let's go back in there, back to our Java resources source, down to our alarm system servlet.java file. Let's go ahead and open that up by double-clicking on it. And let's scroll down to where we had defined our cluster object, and we had specified a contact point of localhost. Now that we have more than one node in our cluster, if the Java driver is not able to get in through one, we want to have a backup option. So let's go ahead and put the IP address of our nodes. And you certainly don't have to put the IP address of all the nodes in your cluster. I would say 2 or 3 should be plenty, because all it needs is one contact point, and then it will know about all the nodes in the cluster. So 192.168.159.101, which is the IP address of my VM1, and then comma, and then another set of double quotes to put my second one in so that I have a backup. In case the first node is down, it can go in through the second. Now, because we've specified more than one argument in here, it is a different method name. It's add contact points. So I just had to add that S there. And while you're here, let's copy this because we can put this into the other file. Copy that, Command or Control S to save. Right click anywhere on the page and choose Run As, Run on Server. Finish. Then the server should run Tomcat, display our application. Excellent. Let's go ahead and enter a home ID. How about H01545551? We see we're able to communicate with our cluster, retrieve our results, and display it on our page. Let's go plug in the IP addresses for our other application. We can close that file. We can collapse that project. And Vehicle Tracker was the other project we created. We'll go down to Java Resources, Source, com vehicletracker.servlet, and double click on vehicletrackerservlet.java to open that file. And then right down here, we can go ahead and paste our add contact points with our IP addresses in quotes. I'm just missing a closing parentheses there. Same thing. Let's save this file and then right click on it and choose Run as Run on Server. Finish. Restart the server. Once that happens, our Track a Vehicle application should display, and we can then enter a date and an ID of a vehicle to see that the application still works. And there it is. Let's just copy and paste the ones we've got here. Submit. We are still able to communicate with our database, our Keyspace, and get our latitude and longitude values and have it display on a map. So in this movie, we use Cassandra stress. And then with our 2-node cluster, we went back to our applications and entered in the IP addresses so that our applications could continue working. This unit was on adding a node to a cluster. Number 1, true or false? All of the nodes in a cluster must have the same cluster name. That's true. Definitely all need to have the same cluster name. Otherwise, you would have different clusters. Number 2, in order to add a node to a Cassandra cluster, it is important to register it with the master node. True or false? That's false. There are no master nodes. All the nodes in a Cassandra cluster have similar functionality. No masters, no slaves. Number 3, true or false? As a new node bootstraps, it takes on responsibility for its token range or ranges, in the case of vnodes, by receiving the data that it is responsible for from other nodes and then deleting the data off of the other nodes. False. The first half was true, but it doesn't delete data off of other nodes. That's a precaution so that if this bootstrapping node were to go down as it's coming up in its early days, that you wouldn't have lost the data altogether by having moved it over there and removed it off of the old nodes. The way it works is that the new node bootstraps, goes ahead and gets the data that it needs. And then if you want to reclaim that disk space off of the other nodes, you can then run cleanup on them. So in this lab, we're going to add a third node to our cluster. Let's go through the steps. Step 1, we're going to use virtual machine x.zip to create a third virtual machine. Step 2, we're going to specify a static IP address like the one you see here where it ends .103. So similar to the IP addresses we specified for VM1 and VM2. Number 3, we need to set the host name to VM3 and add the 4 IP addresses and host names, the list of hosts. Step 4, edit the cassandra.yaml file for VM3 to specify the listen address, RPC address, and seed nodes. For the seed nodes, we're going to specify the IP addresses of VM1 and VM2. Then we're going to start Cassandra on VM3, use NoTool status to watch it join the cluster, and then use NodeTool cleanup to reclaim disk space on VM1 and VM2. If you think this is going to be no problem, then why don't you go ahead and pause the movie, maybe go ahead and get as far as you can, perhaps all the way through. Otherwise, whenever you get stuck, go ahead and play the movie. So the first thing is to go create a third virtual machine using virtual machine x.zip. So let's double click on that to unzip it. Or if you're on Windows, you're going to perhaps right click on it and choose extract all. Once it unzips, let's rename it, call it virtual machine 3, and then let's double click to open it up. If we get the message about other virtual machines running, no problem. Let's click on OK. And if we get this message, I copied it. Once a virtual machine comes up, we'll go ahead and log in, Ubuntu. And since we are going to be having a couple more virtual machines, let's not leave it just called virtual machine X. Let's go to virtual machine settings. And if we're on Windows, we would be doing player manage virtual machine settings. And if we were on Windows, we'd be selecting the options tab. Click on General here, and then we can go ahead and change the name. See, it's changed, and we can close this window. Next thing is to specify a static IP address for this virtual machine. So let's go up to the gear icon and choose System Settings. If we get this message, you don't want that, just say don't upgrade. And where we do want to go is to this network icon. In here, we're going to click on Options. We're going to select the IPv4 Settings tab. For Method, we're going to choose Manual. For addresses, we're going to click on Add. And we're going to enter the IP address for this virtual machine. So this is the static IP address. It's going to be very similar to the address of your other two virtual machines, except it's going to be 103. Net mask, same as what you used on the others. Gateway, same as what you used on the others. And DNS, also same as what you used on the other virtual machines. All right, let's click on Save. See our settings. And if we get this bug, then just go ahead and click on Continue. And we'll close the network window. And then we'll restart the virtual machine. So virtual machine restart. Log back in. Maximize the window if you want to. Let's open up Firefox just to make sure that we still have internet access. Let's open up a terminal window so we can check our static IP address. Right there. And let's ping one of our other VMs to make sure we can communicate. I'm going to put in the IP address for VM1. Pinging is going great. Command C or Control C to stop. Let's make the host name unique and known. So sudo space vim space /etc/hostname, password of Ubuntu, I to edit the file, delete to get rid of those characters, and let's put VM3 in here instead. So we have a unique host name, escape right quit to get out of here. Sudo space vim space /etc/hosts, add to the list of hosts, and if you saved your IP addresses and host names by chance, you could then paste those in. I have mine in this IP and host names file. I don't know if that's useful to you, but you could copy those, right click to paste, and then modify them to put in your IP addresses. Save and exit this file. So escape right quit. And then we'll restart our virtual machine with those new settings. Go ahead and log back in. Maximize my window here. And let's open up a terminal window just to check that we can ping the host name, one of our other VMs. Quit that by doing Command C or Control C. Next thing is to go edit our Cassandra.yaml file. Let's do vim Cassandra /Apache Cassandra 2.0.7 /conf/Cassandra.yaml. I must have had a typo in there. Ah, yes, I had too many S's in Cassandra there. So in here, we notice the cluster name is test cluster, like our other two nodes. We need to go down to modify our listen address property, which is on line 297. So we could scroll down there or search. There it is. To be able to edit this. And we're going to put in the IP address for this node, which in my case is 192.168.159.103. Need to put in this also for the RPC address. Scroll down a little bit. Here it is on line 335. So again, that was 192.168.159.103. You, of course, will be putting in the IP address for your VM3. We need to specify our seed nodes. So let's scroll back up a little bit. Let me just search for it. Escape seed_provider. There we are. So right down here, line 227. Let's do I to be able to edit this. And let's put in the IP address of our other two nodes. We only really need one to be able to join the cluster, but just in case one of them's down, when we try and join this node, we can then use the alternate one. Quotes around the whole thing, comma separated, escape : WQ, enter to write and quit. We are ready to start up VM3, our third node here. Let's go ahead and change the directory down to where Cassandra's installed. And then, as I'm sure you remember, to start up Cassandra, it's just bin/Cassandra space -F to run it in the foreground. So it's going to go ahead and start bootstrapping. Let's jump over to VM1, where we have node tool status running every 2 seconds. And we can see node 3 is now joining because we can see its IP address. And then we see the U for up and the J for joining. It's basically getting its token nodes sorted out. We expect that it will eventually be approximately 33% here, here, and here. Those numbers won't be exactly evenly divided, but along those lines. And then we'll expect it to take on about a third of the load, keeping in mind that it's not going to go deleting data off of the other two nodes. So it's going to go get the data it's responsible for, but it's not going to wipe it off of the other nodes. They each own approximately a third of the token ranges, and it's taken on approximately a third of the data. We can leave things as they are, it's fine. Or if we think, well, I'd like to tidy up VM1 and VM2 by clearing that space where they're still holding data that they're no longer responsible for, let's go to a terminal window into the directory where Cassandra's installed, and let's run cleanup. So let's do bin/nodetool space -H to specify which host we want to clean up. Let's put in the IP address for VM1, then we'll do VM2 after. .101 space cleanup. It might take a minute or two, but eventually we expect to see this number reduced a little bit. 9.57, that makes sense. Now let's do the same thing for VM2. .102. You see that number starting off at 14 megabytes. We'll wait a minute or two, but eventually expect it to go down as that data gets cleaned up. And there we go. In the lab, we went ahead and bootstrapped a third node, so we now have 3 nodes in our cluster. And then just to tidy up, we use cleanup on VM1 and VM2. Let's talk about tools that we can use to monitor a Cassandra cluster. Tools for monitoring Cassandra include NodeTool, JConsole, and OpsCenter. NodeTool is a command line tool that comes with Cassandra. JConsole is a tool that comes with JDK, Java Development Kit. And OpsCenter is a GUI application that comes from DataStax. All of these tools work by communicating with Cassandra through JMX, Java Management Extensions. Through JMX, Cassandra exposes many metrics and commands, which any of these tools can use to monitor and manage a Cassandra cluster. Provided with Cassandra, NodeTool is available on the command line via its executable, located in the bin subdirectory where Cassandra is installed. Many options for monitoring a cluster are available through NodeTool. I'll go ahead and mention a few to give you an idea of some. NodeTool status for monitoring the status of a cluster, probably the most common NodeTool command. NodeTool info for information on a particular node. NodeTool ring for seeing which node each token range is assigned to. NodeTool CF stats. CF, as you might guess, stands for column family, which is the old phrase for table. So this is NodeTool table stats, allowing you to see statistics for all the key spaces and tables. Node tool CF histograms to see the read and write latency for a given table, and node tool compaction stats to see compaction information. To see all of the commands for node tool can be run without an accompanying command. Let's go try this out. Let's jump on over to one of our virtual machines. It doesn't matter which one, as long as it's one in our Cassandra cluster. I'm going to go over to virtual machine 2. In the directory where Cassandra is installed, let's go ahead and enter bin/node tool without a command after it so that we can see all of the different commands available. And if we go ahead and scroll back up through this list, you'll see that there are many, many commands available to be used with node tool. I'm going to hit the down arrow to get back to the command prompt. Let's go ahead and run our most common one, bin/node tool status. So this one lets us see the status of our cluster. So the IP address of each of the nodes in the cluster, the fact that each of these is up and normal, the data load each is carrying, the percentage of the token ring that each owns, the host IDs, the racks that they're in. Let's try out another command. Let's do bin/node tool ring to see which nodes the token ranges are assigned to. And as you may recall, each one of our nodes owns 256 token ranges. What we just saw flying by was 256 times 3 different token ranges. And for each endpoint of each token range, we can see which node in our cluster is responsible for that token range. Let's try out another command, bin/node tool info. This gives us information on a particular node in the cluster. And if we go ahead and run it without specifying which node, it will give us information about the node that we're currently running node tool on. So in the case of the one I'm using, it's going to be virtual machine 2. I'm going to be seeing data about that Cassandra node. This ID here, I could compare it to when I ran node tool status to see that it is this one. Let me go ahead and do that. So if we do bin/node tool status, I notice that this ends in C987. So if we run node tool status and we look at the IDs here, I see sure enough it's this one here, and that is for our VM2. Let's say that we wanted to see information about a different node in our cluster other than the one where we're running node tool from. So what we could do in that case is we could still enter node tool info, but what we'll do is we'll specify which host by doing -h and then the IP address of the node that you want to know about. So in my case, I want to know, let's say, about information to do with node 3. So I'm going to specify node 3's IP address. You would, of course, be plugging in your IP address for your node 3. And then the word info. And now it's giving me information for my node 3. Node tool is a very common and core monitoring tool for working with Cassandra. I encourage you to take a couple minutes and try out a couple other node tool commands. JConsole, which comes with JDK, the Java Development Kit, is a tool for looking inside a Java process. JConsole can be launched from the command line by entering JConsole & from the bin subdirectory where the JDK is installed. Once opened and connected, JConsole provides an interface for exploring exposed metrics. Let's go try it out. Let's go over to virtual machine 1 because that's the virtual machine where we have JDK installed. We have it installed on that virtual machine because we were doing some Java development earlier in the course. Let's go down to this directory. So cd /usr/local/java/JDK 1.7.0_55. And if we go ahead and do an ls to see the contents of this directory, we see there's a bin directory. Let's do ls bin. And inside of here, we see jconsole listed. Let's go ahead and run it. So at the command prompt, let's do bin/jconsole space ampersand. I'm going to go ahead and maximize this window here. Let's select the remote process radio button and then enter localhost :7199, which is the port for JMX applications. Let's click on connect. That's okay if we see this message. We're going to click the insecure button. Give it a few seconds to connect. So we've got these tabs here. By default, we're on the overview tab. Let's go ahead and select the mbeans tab. This will allow us to drill down into some detail. And then let's say we're interested in looking at some of our metrics. So let's expand the org.apache.cassandra.metrics category. And then let's click on the triangle to the left of column family, which as we know really means table. And inside of here, we can see our Keyspaces that we've defined. Let's go ahead and look at detail within tables in the home security keyspace. Click on the triangle to expand that one. And then within that, let's expand the activity table. And if we scroll down, we're going to see, wow, there's all sorts of metrics we could take a look at. Let's click on the triangle to the left of read latency and select attributes. And then over here on the right, we can see all sorts of metrics related to read latency for the activities table in our home security keyspace. Go ahead, take a couple minutes and browse through some of these other categories and take a look at the metrics within them. So along with NodeTool, jconsole, which comes with the JDK, is another option for being able to look at metrics related to your Cassandra cluster. DataStax Ops Center is a GUI web application for monitoring and managing a Cassandra cluster. Two versions of Ops Center exist, the free community version and the enterprise version. When using the enterprise version, the options that had been dimmed out in the community version become available. So as you can see over here on the right, alerts, services, and data backups, those are features of the enterprise version. All of the other features are in both the free community version and the enterprise version. To be able to use Ops Center needs to be installed on a server, which can be one of the existing nodes in the cluster, or can be just a completely different server. And then Ops Center agent needs to be installed on each of the nodes in the cluster so that Ops Center can communicate with each of the nodes. Once Ops Center is installed, it can be accessed by opening a browser window and specifying the IP address of the server that it's installed on with 8888 as the port number. So you see an example of this down at the bottom. So this is the IP address of the server that Ops Center is installed on, and then :8888 as the port number. Let's go take a look at the Ops Center documentation so that if Ops Center is something that you think you might want to use, you know where to find more information about it. Let's go to a browser window. The URL that we're going to go to is www.datastax.com/documentation/5.0/about_c.html. Once we go to that URL, we end up on this landing page, which talks about Ops Center and provides a little diagram. So you can see where we have the graphical user interface in a browser window, and that's communicating with where Ops Center is installed. That could be a separate server or could be one of the nodes in your cluster. And then Ops Center server can communicate with the nodes in the cluster because Ops Center agent is installed on each node in the cluster. So over on the left in the installation category, expand that. In here, you've got information on installing Ops Center as well as installing Ops Center agents. And while we're here, let's look at the key features of Ops Center. So if you clicked on the key features link on the left, and then you scroll down, you're going to see various features available, including alerts and automatic backups. So go ahead and take a second to scroll through there and click on any links that are of interest to you. Along with Node Tool, Ops Center is a very nice option for monitoring your Cassandra cluster, as it provides a great graphical user interface, as well as additional features such as alerts and automatic backups. In this unit, we learned about 3 tools for monitoring a Cassandra cluster: Node Tool, JConsole, and Ops Center. Let's do a few questions. Number 1, how do the monitoring tools communicate with a Cassandra cluster? Is it A, BMX, B, JMX, C, KMX, or D, XML? B, JMX, Java Management Extensions. Question number 2. After installing Cassandra, the installation of Node Tool requires additional steps. Is that true or false? It's false. So when you install Cassandra, Node Tool comes with it. You don't have to do anything extra to install it. Question number 3. JConsole is provided by, is it A, DataStax, B, JRE, C, JDK, or D, Apache? C, JDK. JConsole comes with the Java Development Kit. Number 4, last question. In order for Ops Center to communicate with a node, what needs to be installed on the node? Is it A, Acrobat Reader, B, Ops Center Agent, C, Hadoop, or D, Solr? It's B, Ops Center Agent. You need to have Ops Center Agent installed on each of the nodes in your cluster. And that will allow each of those nodes to communicate with Ops Center, which may also be installed on one of those nodes or maybe on a separate server altogether. Let's talk about what repair is. Repair is for updating a node's data to be current. This comes into play when you're using a replication factor higher than 1. Examples of reasons for why data can get outdated on a node include that the node has been down, that the replication factor for a key space has been increased, or that the token ranges for a node have changed. So in any of these 3 scenarios, you've got more than one replica of the data. Let's say you had a replication factor of 2, and let's say that one of the nodes that had one of the replicas went down for a couple hours. And let's say that some of that data got updated from the client. There were writes or updates made to the data. That down node still has the older version of the data because it was down. It didn't know that the data had been changed. So in this case, you would need to repair that node that has the older data on it. Repair should be run on each node at least once within the GC grace seconds period of time, so that data marked as deleted on one node does not come back to life through another node because the other node was unaware of the delete from being down. Given that the default GC grace seconds value is 10 days, running repair at least once a week is recommended. So that we can try out running repair, what we're going to do is for one of our key spaces that currently has a replication factor of 1, we're going to change it to have a replication factor of 2. Although it's not common to change the replication factor of a key space, it's certainly possible. We can do it with the alter key space command. So we simply use alter key space, the name of the key space, and then we specify the replication properties that we want it to have. So earlier we were working with a replication factor of 1 because we only had one node in our cluster. But now that we have 3 nodes in our cluster, we can definitely increase the replication factor. Aside from giving us an opportunity to run repair, it's also a good idea in general to have a higher replication factor than 1 so that your system is fault tolerant. The node can go down and the data is still available. Well, let's go change the replication factor for our home security key space. Let's jump over to one of our virtual machines. Any of them are fine. We just need to be able to access CQLSH to do this. I'm on virtual machine 1. I don't happen to have CQLSH already open. Let me go ahead and open up a terminal window. And as you probably recall, we need to run it from the directory where Cassandra is installed. Earlier, we were running it by just doing bin/CQL. But if I tried to do that now, it's not pointing to localhost anymore. It's pointing to the IP address of the VM. So what we need to do is we need to specify the name of at least one of the VMs. I'm going to go ahead and put bin/CQLSH space VM1. And that'll let us connect to our cluster with CQLSH. Let's do describe keyspace, home security, so we can see what the replication factor currently is. And if I scroll to the top of this, I see that it's currently set to a replication factor of 1. We want to change that. I'm going to hit the down arrow to get to the command prompt. Let's use the alter keyspace command. Alter keyspace, home_security, which is the name of our keyspace, with, I'm going to hit tab to help me type some of this in, with replication equals opening curly brace, single quote, class, closing single quote, colon. For now, we're going to leave it as simple strategy. We'll be changing this in a couple units when we redefine our cluster to spread across more than one data center. Simple strategy, and then what we're here for to change the replication factor. So replication_factor 2. We could put 3, but if our cluster only has 3 nodes, then replication factor of 3 doesn't allow for any faults. So we're going to use replication factor 2. Let's hit enter. And if we do an up arrow to get back to our describe keyspace command and run that, and then scroll up, we see that we now have a replication factor of 2. One last thing I want to mention on this before we get into repairing is that even though we said replication factor of 2, defining that does not automatically make it so that the second replica gets created. That does not happen automatically. What we need to do is we need to run a repair in order for that second replica to be created. And we'll be doing that next. So this movie was talking about what repair is. Repair is for making sure that a node's data is up to date. Let's go to repair a node. To repair nodes, the node tool repair command can be used. This is a node tool command. We simply specify the IP address of the node we want to repair, followed by the repair keyword. If we wanted to repair just one key space, we would put that same command followed by the name of the key space, home security. If we don't specify the name of a key space, it's going to repair all of the key spaces for that node, and that could take some time. Since repair can put a heavy load on the cluster, it's best to run repair during low usage hours and to stagger the repairing of nodes so that the system is not overwhelmed with comparing and reconciling all the data on all the nodes at the same time. So this is quite processor intensive. If you happen to be using Ops Center Enterprise, there's a nice option to have Ops Center automatically run a continuous repair service in the background with minimal impact on the performance of the cluster. All right, let's go repair one of our nodes in our cluster, since we did in the last movie change the replication factor for the home security key space from 1 to 2. We need to run repair so that the second replicas actually get generated. So let's jump on over to one of our virtual machines. Any of them are fine. We simply need to be in the directory where Cassandra's installed so that we'll be able to run node tool repair. I'm in virtual machine 1. So you're going to enter bin/node tool space -h. We're going to go ahead and specify one of the machines. Could be any of them. I'll put in the IP address for VM1, 192.168.159.101. And then the important word repair, And then let's also specify the name of a key space. Since home security is the key space that we change the replication factor of and the one that we want to generate the second replicas for, I'm going to specify that. You don't have to, as I mentioned before, you could just leave it with the word repair. It's just that it will take longer because it will be checking the Merkle trees for the data in all of the key spaces. Let's go ahead and hit enter to run this. Repair can definitely take a while. When it's done, we'll be back at the command prompt. Up top, it's kind of interesting. You can see where we have Cassandra running in this virtual machine. You can see what's going on. I could make that window wider. And if we were to jump on over to our other virtual machines, because what's happening is we specified repair for VM1, but what it needs to do then is it needs to go to the other virtual machines and compare the data between what's stored on virtual machine 1 and what's on 2 and what's on 3. So if we go to the others, we'll see they're also busy at work. So if I jump to the bottom of this, I can see the action. You'll see this message about sending completed Merkle tree to VM1. And then same thing, if we jump over to virtual machine 3, I'll scroll down to the bottom here, and we can see all the activity going on. For that key space, it's sending the Merkle trees for the data that's in the home table, as well as the activity table, because both of those are in the home security key space. So this may run for another minute or two. When it's done, back on virtual machine 1, we'll see it go to the command prompt. And it's done. Mine may have finished a little bit faster than yours. Mine took about 5 minutes, only because we've cut out a little bit of the video just so that you weren't having to sit and watch. So to repair a node, use the node tool repair command and specify the node that you want to run the repair on, and then optionally specify a key space. If we hadn't specified a key space, it would have taken even longer to run the repair. Along with repair, another topic that comes into play when we have a replication factor higher than 1 is consistency. Consistency has to do with the accuracy of data when there is more than one replica of the data. And consistency comes into play when we read or write data. So a consistency level is specified per read or write request with the default consistency level set by the client driver. And in general, this is 1 unless you change it, which we'll learn how to do. So if it's 1, it means that if we're doing a read request, only one of the nodes with the replica on it has to respond in order for that read request to be successful. Or if we're doing a write and the consistency level is 1, it means that only one of the replicas has to acknowledge having received the data in order for it to be considered successful. Let's look at some other consistency levels. Along with 1, some others include 2, 3, quorum, local quorum, and all. And we can see detail for these different levels in the DataStax Cassandra documentation, which we'll take a look at. And you'll see that there'll be a chart for read consistency levels, as well as a chart for write consistency levels, of which most of them are the same. We'll take a look at them so you can see. Let's get into getting to use some of these hands-on so we can get a better feel for what they are and how they work. If we want to use CQLSH, which we do, so we can try out consistency, we're going to use a command called consistency. And this command can be used to see what the default consistency level is, or we can use this command to specify what we want it to be going forward. And we'll use both of these. Let's go ahead and jump on over to one of our virtual machines. It doesn't matter which one you use because they're all together in the same cluster. So by communicating with one of them, you're communicating with the whole cluster. I'm in virtual machine 1. So to jump into CQLSH, if you're not there already, you're going to need to be down where Cassandra's installed. So I'm going to change down into that directory. And then, of course, bin/CQLSH, and then the name of one of our machines in our cluster. I'm going to put VM1. Once you're inside of CQLSH, let's try out this consistency command. And it tells us that the default consistency level for CQLSH is 1. Let's say we want to change this. Let's do consistency 2. This means that when we do a read or a write command in CQLSH, that at least 2 of the nodes with replicas will have to respond in order for it to be successful. Let's do consistency 2. And if we do the up arrow to go back to our consistency command to find out if it's been set, we see that sure enough, current consistency level is 2. Let's try doing a read. We're going to do a select statement, and we could type this in, select space home underscore ID, comma, date, time, comma, space, event from home underscore security dot activity. We're going to do a read from that table where home underscore ID equals single quote H00999943, closing single quote, semicolon. Because we set consistency level to 2, when we go to run this, it's saying that at least 2 of the nodes where this data is stored, the 2 replicas, have to respond. Both of them will have to respond in order for this to work. That should work fine because all 3 of our nodes are up, and we did change the replication factor of our home security key space to 2. And then we ran a repair to make sure that the 2 replicas were actually generated. So let's go ahead and run this. This should work fine. And it does. Let's now try changing the consistency factor to 3. So let's do consistency 3. This is not going to work. Let's do an up arrow to rerun our select expression. And why is it not going to work? Because for the home security key space, we set the replication factor to 2, which means there's 2 replicas of the data. So 2 nodes in our cluster contain the data for this home ID. So if there's only 2 nodes that have the data, there's no way we can do consistency 3. It's just not going to work. So let's try it. Let's hit enter. It says, I can't do that. Let's try another consistency level. Let's do consistency quorum. If we say this, and then we go to run our select expression again, there's 2 replicas, because that's what we say is the replication factor for this key space and all its tables and data within the tables. So what we're saying is that out of 2, it has to be more than half. Well, if there's only 2 for the replication factor, it's basically the same thing as if we're saying 2, because we can't have like 1.5. If we do 1, that's not good enough for quorum. It's basically going to have to be 2. So when we run this in this situation, it's as if we're running consistency 2, or even as if we're running consistency all. All means that all the nodes that have that data have to respond in order for it to be successful. So in this case, because we just have a replication factor of 2, quorum 2 and all are in effect all the same. So this should work fine. Let's try running it. And it does. So we've been using consistency with reads. Now let's try using consistency with writes. In the next video, we pick up where we left off here. Let's go ahead and change consistency back to 1 for the moment. If we want to check that, how do we check it? We type consistency. What we're going to do now is we're going to do a write. We'll use the insert into command to do this. We could type this in, but it's a lot of typing. So let's go to our working files folder. Go ahead and grab the code that's in the file called insert into 0855.txt. Open that up. And this is just an insert into. We've done a lot of these. We're just saying I want to insert into the activity table, into these columns, and these are the values that I want to put in. Select all, copy, and then back at our VM here, let's do a right click so we can choose paste. If we run this with consistency level of 1, what's going to happen is because this is set to replication factor of 2, this will get written to both replicas that are responsible for this data. But from a is it successful point of view or not, only one of them has to respond to say, yes, I got it. So let's go ahead and run that. We see that it executed without error, so that worked fine. Let's now change consistency to 2. Up arrow to get here and put consistency 2. Let's go to run another insert into. Let's go back to our working files folder. Insert into 1103. So this is just another row. So let's deselect all and copy. Right click and paste. And this should work fine as well, because we're saying consistency 2, and because the replication factor is 2, and because all the nodes in our cluster are up, there shouldn't be a problem. In this case, though, we are saying that, okay, both of the nodes that I'm writing this data to have to respond that they got it and everything's fine. So let's hit enter. And that worked fine. No error message. Let's do one more. Let's try consistency of 3 for doing a write. And let's go get one more insert into from our working files folder. Insert into 1245. So select all and copy it. Right click and paste. Now, what do you think? There's going to be a problem, because we're saying that 3 nodes have to acknowledge having received this write, that they got the data and wrote it. It's not going to work because the replication factor that we set for this key space is only 2. So it's only going to write to 2 nodes, the 2 that own it. It's not going to write to 3. So we're not going to get acknowledgements from 3 nodes. So let's go ahead and hit enter. And it says, yeah, problem, can't do that. 3 nodes were not available. 3 nodes did not give me a write. Let's go ahead and set this back to the default. So consistency 1. And let's take a look at the documentation. So you can see a list of all the different consistency levels available to you. If you go to the DataStax documentation for Cassandra, and then over on the left under Database Internals, you select Configuring Data Consistency, it'll go ahead and take you to this page here. And if we scroll down, you see here's a table that has all the different write consistency levels available to you. And if you scroll down a little bit further, you see a table that has all the read consistency levels available to you. So go ahead and take a minute, scan through those. You'll notice that there's one called any that's in the write list, but not in the read list. We'll be using that in the next movie when we talk about hinted handoffs. We'll take a look at that one then, and I'll explain it when we get there. This movie was on consistency, and your needs will determine what the appropriate consistency level is for your write and read requests. For many applications, 1 is adequate. In general, all is discouraged, as it would fail if any of the nodes are down that are needed for a read request, and would require that all of the required nodes for storing the replicas must be up in order for a write request to succeed. Instead of all, quorum is normally used when a strong consistency is required. Let's talk about hinted handoff. Hinted handoff, which is enabled by default, can provide a way for writes to happen even if one of the nodes that the data is to be written to is down. This is made possible by having the coordinator node, which is the node that received the write request, temporarily store the write for 3 hours by default on behalf of the node that's down. Once the down node comes back up, the coordinator node holding the write forwards the write to that node. A hinted handoff write does not count toward the 1, quorum, or all consistency levels, so you don't have to worry about that. However, if the consistency level of any is specified with a write, the hinted handoff write satisfies the consistency level for the write, even if the write never actually makes it to the node that owns it. For example, if the down node is down for more than 3 hours. Hence, a consistency level of any should only be used if it's not critical for the write to be written. The settings for hinted handoff are located in the cassandra.yaml file, and 2 key settings in there are hinted handoff enabled, the default for that is true, and max hint window in milliseconds, ms, which has the default of 10,800,000 milliseconds, which equates to 3 hours. Let's go take a look at these settings. So if you jump over to one of your VMs, I'm in virtual machine 1. and you go to the directory where Cassandra's installed. We're going to go into the cassandra.yaml file. So you could do vim space conf, since that's the directory where the file is. Cassandra.yaml opens up our file in a text editor. And if we scroll down to line 36, down in here, you'll see hinted handoff enabled, true. So if you, for some reason, decided you didn't want this feature, you could turn it off. Or on line 40, max hint window in MS, milliseconds, if you decided that you wanted a longer wait period, so instead of having the coordinator throw the hint away after only 3 hours of the node not coming back up, you could extend that, right? You could make it 6 hours or 10 hours. If you want, take a look at other settings in here. There's a lot of comments in here, which is a nice thing about the cassandra.yaml file. A lot of the properties are well documented. We could also jump over to the documentation. And then in the database internal section over on the left, you can select about hinted handoff rights. And here's just another explanation of what we were talking about, how hinted handoff works. And in here, they mentioned the consistency level of any. And if we wanted to look at that, we could go back to configuring data consistency. And in the right consistency levels, we can scroll down to see any. That's a scoop on hidden handoff. It's turned on by default. And by default, the amount of time for a coordinator to store hints is 3 hours. Along with the repair command for ensuring that the data on a node is up to date, we also have something called read repair. Read repair is an option to have a repair happen as part of a read request. Read repair compares the replicas for the requested data and then updates any of the replicas that are outdated. Configured at the table level, read repair is turned on by default with a value of 10%. With the default setting of 10%, 1 out of every 10 read requests triggers a read repair. The read repair generally happens in the background unless a consistency of all is used, in which case the replicas are repaired before the response to the client is sent, which means that the data from the closest replica is sent and then the read repair happens. Let's go take a look at where this is set for a table. So if you jump over to one of your virtual machines and jump into CQLSH, if you're not there already, we do a describe table, and we'll just pick one of our tables. How about home security for the keyspace, dot, and then activity as the table that we want to look at the settings for. And we see that in the definition for this table, that the read repair chance is set to 10%. So if you wanted to, you could increase this or decrease it via the alter table command. If you decreased it, like to 0, then it would mean that read repair is not happening. Or if you went the other direction and you increased it, let's say to 100%, well, then it would always be doing it whenever there's a read, but then you'd be giving up on performance. You can change this, or you might want to just leave it at 10%. So in this unit, we learned about repairing nodes, which is all about making it so that the data on the node is up to date. This comes into play when we have a replication factor higher than 1, in which case we have more than one replica of our data. So we learned about using the node tool repair command. We also learned about consistency, which is how many nodes need to respond in order for a read or write to be considered successful. And we got to try out some of the different consistency levels in CQLSH using the consistency command. I should also mention that for whatever client driver you use, such as the DataStax Java driver or one of the dozens of other client drivers out there for Cassandra, that each one of those drivers will likely have a way for you to set the default consistency level for that driver, as well as a way for you to set the consistency level for an individual read or write request. So maybe for a given write request, you need to have that particular request happen with a consistency level of quorum, whereas maybe for a different write request, it only needs to be a consistency level of 1. The client drivers generally give you the option to not only specify a default consistency level, but then also, if you wish, a consistency level for each individual read or write request. We also, in this unit, learned about hinted handoff and read repair. Let's go ahead and do a few questions. Question number 1. How is it possible for a replica of data to become outdated compared to other replicas of the data? Is it A, a node goes down for a day, B, a node storing hidden handoffs goes down permanently, C, a node goes down for any amount of time, or D, any of the above? Any of the above could cause data to become outdated on a node. Question number 2. Which consistency level is the default in the different drivers that we have out there? Is it A, any, B, 1, C, quorum, or D, all? It is B, 1. Question number 3. Which consistency level is recommended as a strong but also fault-tolerant consistency level? Is it A, any, B, 1, C, quorum, or D, all? C, quorum. You generally don't want to use all because it means that you couldn't ever have a node that's down. So all is not fault tolerant and really kind of goes against the architecture of Cassandra. Quorum is very strong and is the consistency level used in general when you want a very strong one. Last question, number 4. Which consistency level could result in a write being acknowledged to the client, but not actually being written to a replica node? Is it A, any, B, 1, C, quorum, or D, all? It's A, any. In this lab, we're going to increase the replication factor for one of our keyspaces from 1 to 2. And then we're going to repair the nodes so that the 2 replicas actually exist. Number 1, in CQLSH, we're going to look at the current replication factor for the vehicle tracker keyspace. So we'll see that it's currently 1. And then step 2, we're going to update the definition of the vehicle tracker keyspace to change it to 2. And then we're going to run repair on the VM2 node just for the vehicle tracker keyspace. And by running repair on this node, it will be comparing Merkle trees with the data on VM1 and VM3. In effect, it will not only repair the data on VM2, but also on VM1 and VM3. And then last step, while the repair is running, we're going to notice the activity going on in the terminal windows in VM1, VM2, and VM3, where we'll be able to see the virtual machines communicating with each other, comparing Merkle trees and repairing the data on the nodes as appropriate. So I'm guessing that you'll want to go ahead and pause the movie here so you can go ahead and do the steps yourself. And if you get stuck anywhere along the way, then you can go ahead and play the movie to do the steps with me. In CQLSH, we wanted to look up what the replication factor is for vehicle tracker. And as long as you're already in CQLSH, you can go ahead and use the describe command to do describe keyspace. And the keyspace we want to check on is vehicle underscore tracker. And if we scroll back up a bit, right there, it tells us that the replication factor for that keyspace is currently 1. We want to change that. I'm going to hit the down arrow to go back to the CQLSH command prompt. And let's use the alter keyspace command. So we can type this in, or just to save us on typing, you can go to your working files folder and open up alter keyspace vehicle tracker.txt. And we can do a select all and copy. And then back at our CQLSH command prompt, you can right click to do paste. And this is going to alter our keyspace to give it a replication factor of 2. Hit enter. And if we want to check to see if that happened, we could do the up arrow to locate our describe command, press enter, scroll up to see that it has been changed. All right, so now we know that it's set to be 2, but we haven't done anything to make it so that there actually are 2 replicas. Certainly any writes going forward will go to 2 nodes, so there'll be 2 replicas going forward. But the existing data in here, there's just the 1 replica because of when it was written to disk, it was just replication factor of 1. So what can we do? We can run the repair command to go ahead and make sure that all the nodes are up to date with their data in this key space. I'm going to exit out of CQLSH. In the directory where Cassandra is installed, we can go ahead and enter bin/node tool -h, and then the IP address of one of our nodes. In the directions for the lab, it said to repair the node on VM2. So sure, we can do that. Let's put in the IP address for VM2, the word repair. If we don't put anything else, it's going to go ahead and repair the data for all the key spaces. We really just need it to repair the data in the vehicle tracker key space. So we're going to put that in just to save time because it will otherwise take longer if we don't specify key space and it does it for all of them. Let's hit enter. So it says, yep, it's starting to repair 509 ranges for this key space. In our window where Cassandra is running, we could scroll down to the bottom to see the latest activity going on. So here on VM1, we see that it's sending Merkle trees to 102. And if we go over to virtual machine 2, we can see that it's receiving Merkle trees. Merkle trees are how the data is represented and provides an efficient way to compare the data. And if we go over to virtual machine 3, we expect it also to be communicating with virtual machine 2. Over here on virtual machine 3, let's scroll to the bottom if I'm not seeing the activity. And I can see that it also is sending Merkle trees over to 102. So the repair is going on. If I go back to virtual machine 1, which is where I started all of this, when it's done, I'll be back at the command prompt. And there we go. So it's finished up, and there we are at the command prompt. So it's done. Depending on your hardware, it may have taken you more or less time than me. For me, it probably took, I would say, 2 or 3 minutes. And that's our lab. We increased the replication factor for one of our key spaces, and then we use the repair command to actually create those second replicas. Let's understand removing a node from a cluster. A node may need to be removed from a cluster for a variety of reasons. For example, the capacity might no longer be needed, or a node may need hardware maintenance, such as having more memory added, or a node might be down due to hardware failure. Designed to be fault tolerant, Cassandra handles node removal gracefully. Depending on whether a node is planned for removal or has unexpectedly died, the node tool decommission or node tool remove node commands can be used to handle the node removal. The node tool decommission command is for a planned removal, whereas the node tool remove node command is for a dead node. We'll be using both of these commands as we go forward. Let's learn how to decommission a node. Decommissioning a node is when you choose to take a node out of service, as opposed to a node dying, where you have no choice. To decommission a node, the node tool decommission command can be used. Here's an example, and we'll do something similar. Node tool -h for host, so specifying the IP address of the node that we want to decommission. So in this case, it's our node 3 in our cluster. The port for JMX applications like node tool is 7199. And then finally, the decommission command. The decommission command assigns the token ranges that the node was responsible for to other nodes, and then streams the data from the node being decommissioned to the other nodes. Decommissioning a node does not remove the data from the decommissioned node. It just copies it to the nodes that are now responsible for it. Let's go try this out. Let's decommission one of our nodes. Jump over to one of your virtual machines. I'm going over to virtual machine 1. I've got Cassandra running in one window for this node. And the other window, I have node tool status running with the watch command. So it's updating every 2 seconds. If you don't have this running from earlier, no problem. Here, let me stop mine temporarily by doing Command C or Control C if you were on Windows. I'll do an up arrow just so we can remember how to do this. So just watch and then the number of seconds that you want the command to be refreshed or run, and then the command that you want to have run. If you don't have this set up from earlier, go ahead and do this. Go ahead and hit enter to turn mine back on. So this will be interesting because when we decommission node 3, what'll happen is instead of it saying UN, U for up and N for normal, it'll be UL. It'll be up, but then it's going to be leaving. And then eventually that whole line will just be gone once it's completely decommissioned. Let's open up a new terminal window. In the directory where Cassandra's installed, so cd space Cassandra / Apache Cassandra 207. Let's go ahead and run node tool decommission. Bin / node tool -h. And then you're going to put in the IP address for one of your nodes. Let's decommission node 3. So whatever the IP address is for your node 3, your VM3. 192 in my case, 68.59.103 -P 7199, which is the port for communicating with Cassandra through JMX, and then decommission. Now, once we run this by hitting enter, we're going to be watching the status of that node in this window over here. So let's do that. I'm going to hit enter. There it is. You see the L leaving. And you should also see the load numbers for the other 2 nodes, the remaining 2 nodes will go up because they're going to be taking on the data that this node had been responsible for. You'll see the token ranges, percentages will increase, and then the load numbers will also go up. And then you'll eventually see node 3 just disappear altogether once it's gone. Now, each of these 2 remaining nodes is responsible for half of the token ranges, which makes sense. And they've also each taken on data per their token ranges that was on VM3, that VM3 had been responsible for. Before, these both had a load of around 10 megabytes. Now they're both at 14. Decommissioning a node, nice and clean, something you're choosing to do. You otherwise have a normal, healthy node. And as that node goes to leave the cluster, it's passing off the token ranges and data that it's responsible for to the remaining nodes. And then finally is gone. So let's say that you have decommissioned a node because you perhaps didn't need the capacity at that time. And now at a later date, you decide that you'd like to put that node back into service. You'd like to have it rejoin the cluster. So the main thing to be aware of is the data that's probably now very old and outdated on that node. Since that data is not removed from a node when the node's decommissioned, the data is copied to the other nodes, but not removed from the decommissioned node, it's best to clear the data from the decommissioned node if the node has been down for any length of time before putting the node back into service. So in effect, really having this node join the cluster as a fresh node. In general, it's faster to have the node join as a clean one with no data rather than have it join with old data that then needs to be repaired. As you may recall, repair can take some time and is very processor intensive. Once the data has been deleted from the decommissioned node, the node can join as a new node. To completely remove the data on a Cassandra node, the data, commit log, and saved caches directories need to be cleared. We can do that using the rm command. Here's an example of that. In the directory where the data has been written to for Cassandra, by default var/lib/Cassandra, we need to go ahead and remove the commit log directory, the data directory, and the save caches directory. And by removing those directories, it clears out all the data inside of them. Let's go do this because we've decided that we'd like to bring our node 3 back online. We'd like to have it rejoin our cluster. So let's jump on over to our virtual machine. So in virtual machine 1, where we have a watch node tool status running, we can see that node 3 is currently not part of the cluster. That's because we had decommissioned it. Now let's jump over to virtual machine 3. And Cassandra's still running over there, even though it's not part of the cluster. Let's stop Cassandra from running. In this window, you can do Command-C if you're on a Mac or Control-C if you're on Windows. I believe I've stopped it because I'm at the command prompt. Let's double check. Do you remember that command we could run from earlier to just make sure to check whether a process is running or not? ps space aux space pipe space grep space cas. Now if I go ahead and hit enter, I see, sure enough, it's not running. Cassandra is stopped. Let's go delete that data. So let's change over to where the data has been written, which is cd space /var/lib/Cassandra. If we do an ls over here, we see the commit log data and save caches directories. These are the ones we want to get rid of. So let's do rm for remove -r recursive. So it will delete the contents of the directories and any subdirectories. And then the names of the directories that we want to get rid of, which is commit log, data, and save caches. Enter. Let's do an ls to confirm that those directories are now gone. They are. And now let's go ahead and start Cassandra back up on this machine. cd to go back to the home directory, and then cd Cassandra /Apache Cassandra 207 to get ourselves back to the directory where Cassandra is installed. And then, as you probably recall, you can start up Cassandra by running bin/Cassandra-f. So now it's basically going to join the cluster as just a new clean node. Let's go back to virtual machine 1 so we can see it coming on board over the next minute or so here. There we are. UJ, so for joining. So this node is joining our cluster. And as it's joining, it's going to figure out what percentage of the token ranges it should take on. There we go. So each of these 3 nodes now owns 1/3 of the token range. And then we'll take a look at our load. There we go. It's taken on approximately 1/3 of the load. It had been 28 megabytes spread between those 2 nodes, 1 and 2, and it's taken on about 1/3, which is 10. You notice it didn't take data off of the other nodes. It doesn't ever take data off of other nodes. It just copies it off. So if we wanted to claim back the disk space on those other 2 nodes, what command can we use? Cleanup. You don't have to run cleanup, but if you want the space back, you can. We need to go to the directory where Cassandra is installed so that we can use node tool cleanup, bin/node tool, space -h to say which node it is we want to clean up, and then the IP address of that. I'm going to go ahead and put in the IP address for 1-p port 7199 space cleanup. I must have had a typo in my command. Let me do an up arrow to see what it was. I had 2 7s. Hit enter. There we go. And now we see that on VM1, that instead of 14 megabytes, it's now just storing 9 megabytes of data. Let's do the same idea for node 2. So if you do the up arrow, you can simply edit the IP address for your node 2. Enter. Give it a couple seconds, and then we are expecting this number to go down as well. There it goes, 9.72. Putting a node back into service, the main thing to keep in mind is that you generally are going to want to clean off the old data and then simply restart Cassandra on that node and let it join as a new node. And then optionally use cleanup on the nodes that it received its data from. So let's now talk about the scenario of a node dying and why we would want to run the remove node command if a node is already dead. Removing a dead node from the cluster is done to reassign the token ranges that the dead node was responsible for to other nodes in the cluster and to populate other nodes with the data that the dead node had been responsible for. To remove a dead node from the cluster and reassign its token ranges and data, the node tool remove node command can be used. Here's an example of that. It's node tool, remove node, and then the host ID for the node. And the host ID can be copied from a node tool status window. With the dead node being dead, the data that it was responsible for needs to come from other nodes in the cluster, which happens when the node tool remove node command is run. The node tool remove node status command can be used to watch remove node happen. Here's an example of the node tool remove node status command running with a watch on it so that it's getting updated every 2 seconds. Let's jump over to our virtual machines. We notice in virtual machine 1 that all of our nodes are currently up, all 3 of them. We see UN for all of them, so they're all up and normal. Let's say that node 3 was to unexpectedly die on us. Let's go up to the window menu, go over to virtual machine 3. And in the window where Cassandra's running, go ahead and do a Command-C or Control-C if you're on Windows. So we've stopped Cassandra from running on this machine. This machine has died. Let's say that the machine died, and as a result, it killed Cassandra from running. If we look back over at virtual machine 1, we see DN, down. And we're thinking, oh, it's too bad this node died. We weren't able to run that tidy decommission command where it would have reassigned the nodes and passed the data off to the other nodes before it went down. In this case, the node is just gone. What we want to do now is run the remove node command to reassign the token ranges to other nodes and to hopefully be able to take the data that was on that node. We no longer have access to that node, but hopefully there's a replica of the data on other nodes that we can then use to write to other nodes that are still part of the cluster. To watch remove node happening, how about in one other window, we're in the directory where Cassandra's installed. Let's run watch, so it will update every 2 seconds, -n space 2, bin/node tool, space remove node, space status. So this is going to allow us to watch as remove node happens. So let's hit enter. So that should update every 2 seconds. And it says right now there's no token removals in process, as we'd expect. All right, now from our node tool status window down here, let's go ahead and pick up on the host ID. We're going to need that when we go to run the remove node command. So highlight that, right click, choose copy, and then let's give ourselves one more terminal window. We need to run node tool remove node, which we need to run from the directory where Cassandra's installed. bin/node tool, space remove node, space, and let's do a paste so we don't have to type in that host ID by hand. Enter. And then while that's running, we can watch that progress up here in our remove node status window. There it goes. So it's removing a token range, communicating with the remaining nodes in the cluster to allot that. And then once it's done, we see no token removals going on. And we see over here in our node tool status window that node 3, that third node, is now gone. It's no longer part of the cluster. And we see that the token ranges are now divided between the two remaining nodes in our cluster. And now regarding the data, a couple things have happened. For the key spaces that had a replication factor of 2, which was vehicle tracker and home security, those two key spaces that we created, the data for them is fine. Because there was 2 replicas, it was okay that we lost one of the replicas in our down node because there was still a replica left then on a remaining node in our cluster. So that was fine. However, there was a third key space we worked with briefly called Keyspace 1, and it was generated when we ran Cassandra stress, when we basically generated a whole bunch of data and loaded it into our cluster. Well, that key space just had a replication factor of 1. And we didn't have the data replicated anywhere else because it was replication factor of 1. We basically lost a third of the data for that key space. So a third of the data for key space 1 is gone. It's on the crashed node, node 3. Granted, it's still there, but if that node 3 was permanently crashed and destroyed, never to be seen again, then a third of our data would be gone. Now, we don't care about that data because it was just stress testing data. But if it was some of our data we cared about, we would likely want to have a replication factor higher than 1. At least 2, perhaps 3, or maybe even 4, depending on how important that data is to you. So this was on using the remove node command, which is one that you use when a node has unexpectedly crashed, and you use it to reassign the token ranges from that down node to nodes that are still left in the cluster. And if possible, re-replicate the lost data from existing nodes in the cluster. This unit was on removing a node. We talked about decommissioning a node, as well as removing a node that's died unexpectedly. And then we also talked about putting a node back into service. Let's do a few questions. Number 1. Which command is for when a node has unexpectedly died? Is it A, node tool restore, B, node tool decommission, C, node tool live, or D, node tool remove node? The correct answer is D, node tool remove node. Goes ahead and reallocates the token ranges that the dead node was responsible for, as well as attempts to recreate the replicas that node had been responsible for. Question number 2. Which command is for removing a node due to a decreased need for capacity? Is it A, node tool restore, B, node tool decommission, C, node tool live, or D, node tool remove node? Correct answer is B, node tool decommission. So when you're choosing to remove a node from your cluster, you can use decommission, and before that node is removed, it will reallocate its token ranges to the remaining nodes, as well as transfer its data to the remaining nodes. Question number 3. True or false? It is generally best to delete a node's stored data before putting the node back into service, before having it rejoin the cluster. Is that true or false? That's true. In general, you're going to want to clear that data because it's probably become old during the time when the node was taken offline and then when it's coming back to join the cluster. So you generally want to clear it out so that you're not dealing with old data and having to run repair on it. Just bringing that node back in as a brand new node. And our last question, number 4. What could potentially be done to get back the Keyspace 1 data that was lost in the last exercise? As you recall, node 3 crashed and we ran remove node to go ahead and reallocate its token ranges to the remaining nodes. And it would have also tried to put the replica data that was on that node onto the remaining nodes, but some of the data it couldn't do that for specifically the data that was in Keyspace 1, because Keyspace 1 had a replication factor of only 1. When that node went down, that data went down with it. There wasn't an additional replica of it anywhere else in the cluster. What could be done to get that data back? A, nothing can be done. B, run remove node again. C, delete the stored data on the VM3 node, start the node back up, and run remove node again. Or D, start the node back up, and to prevent the problem from happening in the future, change the replication factor for keyspace 1 to 2, and run repair for the keyspace to generate the second replicas. So what do you think is the correct answer? D. That node went down, but since it's not permanently damaged, we can bring that node back up, have it join the cluster without deleting data off of it first. And so that means that data is now available again, so that we don't have this problem happening again in the future. We'll change the replication factor for keyspace 1 to be 2 and run repair for the keyspace so it actually generates that second replica. And then that prevents this problem from happening in the future. Since that data will going forward have a replication factor of 2, if that node was to go down again, there is a second replica of the data on the other nodes. In this lab, we're going to put our VM3 node back into service. We're going to be needing it as we go forward in the course. So let's take a look at the steps. Step number 1 in VM3, clear the data, commit log, and save caches directories. Step 2, start Cassandra in VM3. In VM1, watch the VM3 node join the cluster to see that it did indeed join the cluster. And then, if you wish, clean up VM1 and VM2. And then finally, see that VM3 is part of the cluster with approximately 1/3 of the ring ownership. We're basically going to throw away the data that was on VM3. I guess if you wanted to do this lab differently, you could bring it back up. You could change the replication factor for keyspace 1 to 2, run repair, then take down the node, see that you don't lose any data when you run remove node. You could do those steps if you'd like. Or if you'd like to do what I'm going to be doing, sort of the common scenario is that when a node dies, you clear out the data. You're normally working with keyspaces that have a replication factor more than 1. You simply clear out the data and then restart the node to have it join the cluster. Either way, why don't you go ahead and pause the movie here so that you can go ahead and do the lab. If you get stuck anywhere, you can unpause the movie to do the lab with me. I can see here on Virtual Machine 1 that node 3 is down where we last left it. Let's go up to Virtual Machine 3 and let's go ahead and clear the data for Cassandra that's on VM3. I'm going to open up a second terminal window just so that I can go back to that one in a few minutes and restart Cassandra. Let's go ahead and change directory to where the data is stored on this node for Cassandra, which by default is var lib Cassandra. ls, we see that there's the commit log data and save caches directories. Let's go ahead and run our rm command, remove those, -r to make the delete recursive so it deletes down through all the subdirectories. Commit log data, save caches, so basically listing all the names of all the directories I want to remove. Go ahead and hit enter, and if we do an ls now, they're gone. So the data in Cassandra on this node has been removed. And now, back in my other terminal window here, let's go ahead and start up Cassandra. bin/Cassandra -f. And as that's starting up, we can go back over to Virtual Machine 1, where we have our watch command running node tool status every 2 seconds. There we go. So now node 3 starting to join the cluster. We'll give it a few more seconds here as gossip is going on between the nodes. So now each of them owns 1/3 of the token ranges. And just watching the load number here. And there we go. It's taken on approximately a third of the data. We noticed that the other node's data load didn't go down as expected, does not actually remove data off of other nodes when you bring up a new node in the cluster. If we would like to free up space on those other nodes, we could run cleanup to go ahead and release the space that has data that they're no longer responsible for, which is now on the new node. So let's do that. Go over here to the directory where Cassandra's installed, bin/node tool, -h, the IP address of the node you'd like to run cleanup for. So the IP address for node 1, since that's one of our nodes we want to clean up, -p 7199 cleanup. So if we hit enter, we're going to be watching this number here, expecting it to go down a little bit, and it did. Let's run this same command, but now for 102, our second node. Enter. And looking for this number to go down a little bit. There it goes. So this lab was on putting a node back into service. So we put VM3 back in our cluster. To modify a cluster so that it can span more than one data center, a few things need to be done. One is that the snitch type cannot be simple snitch. Simple snitch is the default snitch for a cluster, but can only be used for a single data center cluster. Additionally, the data center and rack information for each node in the cluster needs to be specified. This is generally done as part of configuring the snitch type. And then finally, the replication strategy for the Keyspaces needs to be changed to network topology strategy, which allows for specifying the number of replicas in each data center for a Keyspace. Let's go set up a fourth virtual machine so that we can at least have 4 nodes in our cluster as we go to define a cluster that spreads across more than one data center. If you go to your working files folder and double-click on virtual machine x.zip to unzip it, or depending on your platform, perhaps you're going to right-click on it and choose Extract All. So however you normally unzip your files. Once it's been unzipped, let's rename this file to call it Virtual Machine 4. Go ahead and open it up in VMware. Other virtual machines are running. That's okay. I copied it. Once it comes up, we'll log in with the password of Ubuntu in all lowercase. Maximize this window. And then let's change this name up here in the title. Virtual machine settings. If you're on Windows, you're choosing Player Manage Virtual Machine Settings. Clicking on the general icon. If you're on Windows, you're selecting the Options tab. And let's just go ahead and change this name to Virtual Machine 4. And then we can close our window. If you're being prompted to upgrade Ubuntu to a more recent version, just choose Don't Upgrade. We don't need that. We see that our title bar name has been changed to Virtual Machine 4. Let's go ahead and change the network settings to specify a static IP address for this node. So under the gear icon, we're going to choose System Settings, and then click on the network icon, and then the Options button, the IPv4 Settings tab, Method of Manual, and then under Addresses, we're going to click on the Add button. We're going to put in our static IP address that we want to use for this fourth node. So using the same convention that we use for Virtual Machine 1, 2, and 3, same idea, you're going to put the same first 3 octets that you used on the others. So for me, 192.168.159.104. And then for netmask, same setting that you used on your other 3, which for me is 255.255.255.0. And then for gateway, same as you used on the other virtual machines. So for me, that's 192.168.159.2. And DNS server, same as used on your other virtual machines. For me, it's 192.168.159.2. Click on Save. So this is specifying a static IP address for this virtual machine. If you get this bug message that shows up, that's okay. Just click on Continue. And then you can close the network window. All right, let's restart this virtual machine. So virtual machine restart. If you're on a Windows computer, you'll be choosing Player, Power, Restart Guest. Once a virtual machine's restarted, let's open up a terminal window. And let's enter ifconfig. So we can see that that static IP address is now in effect. We could also open up a browser just to make sure we still have internet access for our virtual machine. And we do. Close that browser window. In the next video, we pick up where we left off here. Picking up where we left off in the last video, let's do a ping just to make sure we can communicate with the other virtual machines. So if I try to ping VM1 using the host name of VM1, it doesn't work because we haven't told this virtual machine yet about those host names for other VMs, but let's put in an IP address. So if you go ahead and put in the IP address to VM1, which for me is going to be 192.168.159.101, that should work fine. Command C or Control C if you're on Windows to stop the pinging. Let's go ahead and put in the hostname information so this VM will know about the others. And let's also make the hostname for this one unique. So let's go ahead and do sudo vim /etc/hostname. Password for sudo is Ubuntu. And so I can edit this file. I'm going to delete that existing host name. And let's change the host name for this machine to VM4. Let's do escape:/WQ, enter to write and quit. Let's do one last thing here, which is telling this host about the other host names. So sudo space vim space /etc/hosts. And in here, I'm going to hit the down arrow and I to insert. We're going to enter the IP addresses and the host names of our virtual machines. So if you happen to have pasted and saved this somewhere from the last one we did, you could go ahead and grab that. In the working files folder, I have this IP and host names file. If your IP addresses are slightly different, you'll of course want to edit these. I'm going to go ahead and copy that. Right click and paste. And then save and exit. So escape:/WQ, enter to write and quit. Let's go ahead and restart this so this take effect. So virtual machine restart. If we go ahead and open up a terminal window and we ping VM1, should now be fine. It is. Command C or Control C to quit that. And the last thing we want to do right now on this virtual machine is configure our Cassandra.yaml file. So let's change directory to get there. So cd space Cassandra /Apache Cassandra 2.0.7 and then vim conf/Cassandra.yaml. In here, we see that cluster name is test cluster. Great, same cluster name as the other nodes in our cluster. Let's go down to line 297 to get down to the listen address property. And as you probably recall, we need to change this to put in the IP address for this node. So let's do an I to edit this file, delete localhost, and we are going to instead put in the IP address of this node. For me, it's 192.168.159.104. You're putting in your static IP address for this node, node 4. And then down on line 335, same thing, getting rid of localhost and putting in the IP address of this node. And as you may recall, listen address is the IP address specified for this node for gossip communications, whereas RPC address, remote procedure call address, is for client applications to be able to talk to this node. Last thing we need to do is specify our seed nodes, which will provide us a way to get into the cluster with this node. So let's go up to line 218, seed provider. We need to modify this and provide at least one of the node's IP addresses, at least one of the nodes that's already in the cluster. Let's go ahead and put a couple of them. Let's put 192.168.159.101, the IP address of one of your nodes. And then in case that one happens to be down when this one's trying to join, let's put a comma and let's put the IP address of a second one as well. There's nothing special about these particular two nodes other than that they're already in the cluster. We're just looking for a way for this node to get in. Let's save and exit. Escape, WQ, enter. In this movie, we talked at a high level about what we're going to need to do to modify a cluster to span multiple data centers. We're going to need to change the snitch type to be something other than simple snitch. We're going to need to specify the data center and rack information for each node in the cluster. And then we're going to need to change the replication strategy for our Keyspaces to network topology strategy. We spoke about those at a high level. In the following movies, we'll be doing those items hands-on in detail. And then the other thing we did in this movie is we went ahead and set up a fourth virtual machine so that we'll have 4 nodes to work with as we go to create a cluster that spreads across more than one data center. So we specify the snitch type in the cassandra.yaml file of each node in the cluster. And as you may recall from Unit 2, there are many snitch types to choose from, which are all detailed in the DataStax documentation, and that all the nodes in the cluster need to use the same snitch type. In our case, we're going to use the very popular gossiping property file snitch. The gossiping property file snitch is a popular alternative to the property file snitch because when adding a new node to the cluster, you can simply provide the rack and data center information for the new node in its Cassandra-rackdc.properties file, rather than having to update a separate file on every node in the cluster with the information about the new node. Once the snitch type has been changed in each cassandra.yaml file, any supporting files for the snitch type chosen need to be provided, and then a rolling restart of the nodes can be done because the cassandra.yaml file is read when a Cassandra node starts up. So let's go ahead and specify the gossiping property file snitch type in all of the nodes in our cluster. So let's jump on over to our virtual machines, and I'm on virtual machine 4. And that's fine. I'll just start with this one. Doesn't matter what order you do these in. And you guys know how to edit the cassandra.yaml file, right? So in the directory where Cassandra is installed, you're going to go ahead and open it up in a text editor, vim, down in the conf folder, cassandra.yaml. And down at line 564 is where we're going to find the snitch setting. I could scroll down there. Let's search by typing / and then the name of the property is endpoint_snitch. Jumps me down to line 514. If I scroll a bit lower, down to line 564, we're going to find the property that we're looking for. So endpoint snitch. And as you can see, by default, it's set to simple snitch. Let's edit that by pressing the I key to insert text. And let's change this to gossiping property file snitch. Why this is such a popular snitch type is because we only have to specify the rack and data center properties for this node And then as this node joins the cluster, it's going to tell the other nodes about itself so that we don't have to go and modify a list of nodes in a setting inside of all the other nodes. We can simply have this one declare its data center and rack, and then through gossip, all the others find out about it. So let's go ahead and save and exit this. So escape, right, quit, enter. And let's go on over to do the same thing for the others. I'll go to virtual machine 3. In the directory where Cassandra is installed, vim conf/cassandra.yaml. Do a search, so /endpoint_snitch. Scroll down a bit more to our endpoint snitch property. I to insert text, change this to gossiping property file snitch. Escape WQ, enter to write and quit. Go to another virtual machine you haven't done yet. So how about virtual machine 2? And same thing. So vim /conf/cassandra.yaml. Do a / to search, type in endpoint_snitch. Scroll down a bit more. I to insert text, change this to gossiping property file snitch. Escape WQ, enter. And our last one, virtual machine 1. Also changing the snitch type for this one to be gossiping property file snitch. Vim conf/cassandra.yaml /endpoint_snitch. Scrolling down a bit more to line 564. I to edit this. Escape WQ, enter. What we did in this movie is we changed the snitch type for all of our nodes to gossiping property file snitch. In the next movie, we'll be specifying the data center name and rack name for each of our nodes, and then we'll be doing a rolling restart so that the snitch type will take effect for all the nodes in our cluster. Depending on the snitch type that you specify, there may be a supporting file that you need to configure. In the case of the gossiping property file snitch, there's a file called cassandra-rackdc.properties. The cassandra-rackdc.properties file, which is located in the conf directory where Cassandra is installed, is for specifying the topology of the individual node. Within the cassandra-rackdc.properties file are two properties. DC, which is for specifying the name of the data center that the node is in, and rack, for specifying the name of the rack that the node is in. So since we are using gossiping property file snitch as our snitch type, let's go look at the cassandra-rackdc.properties file on each of the nodes in our cluster. So let's jump on over to our virtual machines. Go ahead and start with virtual machine 1. And in the directory where Cassandra is installed, let's go ahead and run vim conf/cassandra-rackdc.properties to go ahead and take a look at the contents of that file. Inside this file, we see a lot of comments, but we also see these two properties, DC and rack. And we see that these properties already have values, DC1 and rack1. We could change these names if we'd like to, or I'm thinking these names are fine. So what we're going to do with our 4 nodes in our cluster is we're going to have the first 3 nodes be in DC1. They're all going to be in rack 1. And then for our 4th node, it's going to be in a second data center. This file for virtual machine 1 is fine. Let's do an escape :Q to get out of here. And these settings are also fine for virtual machine 2 and virtual machine 3. For virtual machine 4, though, we want to change these settings. So let's jump on over to virtual machine 4. So here in virtual machine 4, let's go ahead and edit that file. So that's vim space comp slash Cassandra -rack DC properties. And what we're going to do here for this fourth node is we're going to have it be in a separate data center. So let's do an I to edit this file. Let's delete that name of DC1 and let's come up with a name for our second data center. I'm thinking, how about DC2, following that same convention? And rack 1, that's fine. It's going to live in rack 1. Let's go ahead and do an escape, WQ to write and quit. So we're set on our snitch type. We've specified gossiping property file snitch on each of our 4 nodes. We have checked the Cassandra-rack DC properties file, which is the file required by gossiping property file snitch, to make sure that the settings for DC and rack are what we want, which they are. And so now we can go ahead and do a rolling restart on our virtual machines. I'm going to jump over to virtual machine 1. Going to kind of do them in that order. You can close this extra window. And here where we have Cassandra running, you can do a Command C, or if you're on Windows, do a Control C. And that'll go ahead and stop Cassandra running on this node. We see it stopped because we're back at the command prompt. We also see that our watch node tool status is not working because Cassandra's not running on this node right now. Let's go ahead and start it back up. If you do an up arrow, likely remember what you last entered, which was the command to start Cassandra. Let's hit enter. Cassandra's going to start back up on this node. And I should also mention that you don't want to restart all your nodes at the same time. You want to do it as a rolling restart. Because if you try to do them all at the same time, then they may not all find each other because they're all coming up at the same time. It could be kind of chaotic. So best to do a rolling restart. So now let's make this window a little bigger here, because what we see is that virtual machine 1, that node, is now in a data center called DC1 over here, whereas our other 2 nodes are still in the default data center 1, which was from Simple Snitch from before. So what we're going to do is we're going to go do a rolling restart for each of those, and then we'll see them down here in our DC1 data center. Let's go on over to virtual machine 2. The window where Cassandra is running, you can do Command C, or if you're on Windows, Control C. We've stopped it. Let's go ahead and do the up arrow and hit enter so we can restart Cassandra on this node. If we jump back over to virtual machine 1, where we've got the status window, which updates every 2 seconds, we see virtual machine 2 is now showing up in the DC1 data center, and it's now no longer in data center 1. Go to virtual machine 3. Do the same sort of thing, which is up in the window where Cassandra's running. Do Command C to stop it, or Control C if you're on Windows. So it's stopped, and then do the up arrow so you can get the command to start it and hit enter. And then if we look back over on virtual machine 1, we'll give it a little bit of time to make the transition as it restarts. But we're expecting it to leave this other data center and then to show up down in our DC1 data center. And there we are. Last but certainly not least, let's go over to virtual machine 4 and let's run Cassandra on this node. And you recall in our Cassandra-rack DC properties file, we changed the name of the data center for this node to be DC2. Start it up, so bin/Cassandra-F, so it'll run Cassandra in the foreground. Enter. Let's go over to virtual machine 1, where we're running node tool status every 2 seconds. so that we'll be able to see this new node in our cluster, and it will show that's in Data Center DC2. So it's joining the cluster. Give it a few more seconds, and we expect it'll be UN for up and normal. So we see this node is up and normal, and it's in the second data center. Next, we'll be changing the definition of our key spaces to specify how many replicas we want to have in each data center. Now that we have a cluster across more than one data center, we'll want to go back and change the definition of our key spaces to specify how many replicas we want to have in each data center. We can do this by changing the replication strategy for the key space to be network topology strategy. So to update the replication strategy for an existing key space, we can use the alter key space command. Here's an example of doing that. Alter key space, name of the key space with replication, and then class equals network topology strategy. Earlier we had simple strategy, but because we want to have this key space across more than one data center, we need to change this to network topology strategy. Along with doing that, we need to specify how many replicas we want to have in each data center. In our case, we don't have a lot of nodes, right? Because we're trying to run them all on one computer as virtual machines. So what we're going to do is we're going to specify 2 replicas in data center 1 and 1 in data center 2. If we weren't constrained by having so few virtual machines here, what we might do is, let's say that we had at least 4 nodes in each data center, so a cluster of 8. We might specify a replication factor in DC1 of 3, and we might specify a replication factor in DC2 of 3, or maybe even just 2, if we sort of consider that a backup data center. And certainly, the number of replicas in each data center does not have to match and can vary for each key space. So depending on your data and what makes sense for your situation, you can specify how many replicas you want to have in each of your data centers. Let's jump over to one of our virtual machines. I'm going to use virtual machine 1, and let's go into CQLSH so that we can run alter key space. So to go into CQLSH, let's do bin/CQLSH space VM1. I could go in through any of the virtual machines. I'm just picking this one. It says, great, it's connected to test cluster, so connected to our cluster. And let's go ahead and run this alter key space command. Alter key space. Eventually we'll do both of them. Vehicle_tracker with replication equals, for these keywords, it doesn't matter if they're uppercase or lowercase, equals, and then curly brace, single quote, class, closing single quote, colon, space, single quote, network topology strategy. So we're changing this from simple strategy to network topology strategy, in which case we need to specify for each of our data centers how many replicas we want to have. So DC1, we're going to specify 2. We'll have 3 nodes in that data center. By specifying only 2 replicas, we're fault tolerant. It'll allow for one of those nodes to go down and for things to still work correctly. So DC1 is going to have 2 replicas, and then DC2, because we just don't have many nodes in our cluster and there's only 1 in DC2, we're going to specify a replication factor of 1. All right, let's hit enter to make that happen. Great, no errors. I'm going to do an up arrow because I'd also like to do the same thing for our other key space, our home security key space. Now, as you may recall, if you change the number of replicas, that doesn't automatically generate the additional replicas. What you need to do also is run repair. And that will actually make these additional replicas. All right, so in this case, because we already had 2 for DC1 for those nodes, what will happen when we do repair is it'll go ahead and generate this 3rd replica, this one over here for the 2nd data center. To run repair, I need to be back on the normal command line, so I'm going to do an exit. And in the directory where Cassandra's installed, let's do bin/node tool. Specify a host. I'm going to do 192.168.159.104. So I'm going to specify VM4. And then repair. And then I'm going to specify the name of the key space so that it's not trying to repair all the key spaces, which takes longer than just one. Hit enter on that. And as you recall, the repair command is to make sure that the data on a node is up to date. So by us running this, it's going to realize that node 4 should have a replica of the data in the vehicle tracker key space. And if we were to go look at the other virtual machines where Cassandra's running in the terminal windows, we would see them communicating with this node to go ahead and get it to be up to date with its data. And we'll know this is done when we get back to the regular command prompt. Because repair tends to be processor intensive, and because I only have 8 gigabytes of RAM on my computer, and because I'm trying to run 4 virtual machines all at the same time as Cassandra nodes, this might take some time. In the next video, we pick up where we left off here. Picking up where we left off in the last video, repair finally finished repairing our node 4 for the vehicle tracker key space. Let's do the same sort of thing for our home security key space so that the additional replica is generated for it as well. In the directory where Cassandra's installed, let's do the up arrow so we can bring back our last command. And let's just slightly modify this to repair instead of the vehicle tracker key space. We now want to also repair the home_security key space. This will go ahead and run for quite a while, but like we did with the last one, what I'll do is we'll cut out some of the long video footage so that you're not just sitting and watching this thing repair. So our second repair finished. That was for the home security key space. Mine took about 10 minutes. Yours may have been faster or slower, depending on your hardware. And as our last thing, let's make sure that our applications still work. So let's go ahead and launch Eclipse. So if you give yourself a new terminal window, maybe you still have Eclipse open, but I'd close mine. I can go ahead and launch it in a new window here, just entering Eclipse/Eclipse. OK to the workspace launcher. Let's check that our applications still work with our cluster that now stretches across more than one data center. I'm going to go into the alarm system project and into Java resources, src, com.alarmsystem.servlet. And then I'm going to right click on the alarm system servlet.java file, which we made earlier. Right click on that, choose run as, run on server. These settings are fine. So I'm going to click on finish in the lower right hand corner. Starting up Tomcat, our application server. There's our application. Let's go ahead and put in a home ID. I'm going to choose one from the list to make it easy for me. So 801545551. Submit. And fantastic. Our application is still able to connect to our cluster and retrieve data from our tables in our home security key space. Let's try out our other application too to make sure it also works fine. So I'm going to collapse that project. And in our vehicle tracker project, Java resources, src, com vehicle tracker servlet. I'm going to right click on vehicle tracker servlet.java and choose run as, run on server. Click on the finish button in the lower right hand corner. There's our application page. Let's put in a date. 2014-05-19, and a vehicle ID. I'm going to put in FLN 78197. Click on Submit. Great. So our application is still able to connect to our cluster, even though it's across more than one data center, and retrieve data from our vehicle tracker key space, even though it's spread across more than one data center, and retrieve the latitude and longitude values for our vehicle. This movie was on changing the replication strategy to network topology strategy and specifying the number of replicas for each data center. This unit was on modifying a cluster to span multiple data centers. We learned that you need to change the snitch type to something other than simple snitch, and that for whatever snitch type you change it to, which you set in the cassandra.yaml properties file, that you may need to also configure any supporting files for that snitch type. And then that we also need to change the replication strategy for any key space that we want to have span across more than one data center, using the network topology strategy to specify how many replicas we want to have in each of those data centers. Let's do a few questions. Number 1, the name of the supporting file that is required for the gossiping property file snitch. Is it A, cassandra-env.sh, or B, cassandra-topology.properties, or C, cassandra-rackdc.properties, or D, cassandra-topology.yaml? And the correct answer of the name of the supporting file for the gossiping property file snitch is cassandra-rackdc.properties. And as you recall, in that file, we specified the name of the data center and rack that this particular node is in. And we did that for each of the nodes in our cluster. Question number 2. The number of replicas in each data center needs to be the same for all of the key spaces in a cluster. True or false? So do all of your key spaces need to specify the same number of replicas in each data center? False. You can definitely specify a different number of replicas for each data center, and you can do that on a per key space basis. So you can have different key spaces with different numbers of replicas in each of the data centers. Last question, number 3. The name of the replication strategy that allows a key space to be across more than one data center. Is it A, simple strategy, B, local strategy, C, network topology strategy, or D, new strategy? It's C, network topology strategy. As you go forward, deepening your knowledge of Cassandra, one great resource is the documentation from DataStax. To get there, you can go to www.datastax.com/docs. We've been here a bit over the course. And if you scroll down through the page and you go down to the current and recent releases section, and then within that, the latest releases section, there's a couple of the documentation guides that I want to especially point out for you. The first is the documentation on core Cassandra. Click on PDF, so we can go ahead and open this up. And if we scroll down, we'll get to the table of contents, and some of this will look familiar from the course. And if you want to go ahead and scroll down through the topics, you'll see things that we've covered, and then you'll see other things that are more advanced that we haven't talked about in this course. This is a great place to go to learn more. And I know people always joke, oh, who wants to read documentation? But it's actually pretty readable, and it's certainly very interesting. And it's only 197 pages. Let's look at one other documentation guide that I also think would be really helpful for you. So back on the documentation page, it's the CQL guide. So let's click on the PDF for that. And this guide is 104 pages, even shorter. And if we look at the table of contents, We're going to see different topics, some things we did in this course, some things that are more advanced that would be in an advanced course. This is all about CQL, so learning about additional functions inside of CQL that are available to you and how they work, learning about additional data types, all sorts of good stuff in here. So I think this is another documentation guide that would be especially useful to you as you deepen your knowledge of Cassandra. If we go back to the documentation page, you'll notice there's other guides as well, such as guides for the DataStax drivers. So if you happen to be using one of those drivers, you'll certainly want to check out the documentation that comes along with it. And then if you scroll up a little bit, there are links that go to particular topics. So if there's certain topics that look interesting to you in here, go ahead and click on them and read up on these different things. This is the documentation from DataStax, a great place to go as you deepen your knowledge of Cassandra. Along with the documentation, blogs and books are a great way to supplement your knowledge of Cassandra, as they often go beyond the documentation in exploring and explaining a topic in depth. Let's start with the DataStax developer blog. In a browser window, you can go to www.datastax.com/dev/blog. And once you get here, you can scroll down through the blog posts, and you'll find that the blog posts on the site are mostly technical in nature. A lot of them are by committers that work on the Apache Cassandra project. You'll see other technical articles as well, sometimes from support engineers. Let's take a look at a couple of these. Up top here, I see Introducing DataStax Java Driver 2.1. So if I wanted to take a look at that blog, I can just click on it and scroll through it. Let me click on the back button. Maybe you're interested in accessing Cassandra from Spark using Java. Select that one. So a nice little tutorial in here. Click on back. So why don't you take a couple minutes and scroll down through the list of blog posts. If you get down to the bottom of the page, you'll see there's an older entries link. Go ahead and click on a couple that look interesting to you. So along with the DataStax developer blog, there's also the Apache Software Foundation blog. To see the blog posts relevant to Cassandra, you can go to the URL of blogs.apache.org/foundation/tag/Cassandra. And once you get here, you won't see a lot of blog posts, but you will see some pretty interesting ones. I've noticed it's about once a year, and these are the official voice from the Apache Software Foundation. If you scroll down and take a look at these different posts, you'll be able to see the history of Cassandra and what different features came out with the different versions. Not a lot of posts, but very interesting ones. One more blog site for Cassandra that I'll mention is Planet Cassandra. So in a browser window, planetcassandra.org/blog. And on this site, you will see tons of blog posts. I think there's almost one a day. There are so many, and they're so interesting. So on the landing page, you'll see the latest, greatest blog post, and you can scroll down through it. And then below it, you'll see another one, and below that, you'll see yet another. Lots of blog posts. If I go back up to the top here, you'll see there's also top posts this month. I find it to be a really nice combination of topics here. Some of them are technical, and some of them are use case and customer focused, where a customer talks about why they chose Cassandra and maybe, why they chose it over other technologies they could have chosen and how it's working out for them. Some really interesting blog posts here. Along with reading blog posts, another way to deepen your learning about Cassandra is to read books. And at this point, there's quite a few books out there. I'm going to jump over to amazon.co.uk since I happen to be living in London and I buy a lot of books through here. Of course, you'll just go to wherever you buy your technical books. If you search on Apache Cassandra, you'll see there's probably about a dozen different books, lots of Cassandra books to choose from. One that you may not need to purchase because you have already done the video version of it is this purple one here, Apache Cassandra Hands-On Training Level 1 by yours truly. That's the written version of the video course that you have already done. In terms of selecting from these other books, I would suggest you click on Look Inside and take a look at the table of contents for whichever one looks interesting to you. And also look at a few sample pages to see if the style of writing is something that you'll enjoy reading and that will make sense to you. Reading blogs and books, great way to expand your learning beyond the documentation. Watching video recordings from Cassandra summits, webinars, and meetups is an easy way to keep learning more about Cassandra. Many Cassandra recordings are available through the YouTube Planet Cassandra channel, which is here at www.youtube.com/user/Planet Cassandra. Go ahead and enter that in your browser. Once you do, you're going to land here on the home page. And the video that happens to be showing for me today is one from Patrick McFadden. Patrick's chief evangelist at DataStax for Apache Cassandra, and he's done a lot of nice videos, especially around data modeling. So you might check some of those out. You could do that by just searching by his name up here. And along from the many videos from Patrick, we also have a lot of other videos from other great people. Let's take a look at those. If we go to videos, we can scan through the many videos we have here. There's even more when you click on the Load More button at the bottom of the page. Maybe take a moment and look through these, see if there's one that's interesting to you. Click on it, listen to it. Or perhaps you'd like to see groupings of videos, in which case, let's go to Playlists. And here we've got some different playlists to choose from, such as Cassandra Summit EU 2013. So these are presentations from the Summit conference that was here in London. You can see there's 29 videos. So 29 of the presentations were recorded. Or for even more, Cassandra Summit 2013, that was held in San Francisco. And we've got 58 video recordings of that. Let's take a look at those. I'm going to click on Cassandra Summit 2013, so we'll be able to see the list. If you scroll down through here, you're going to find all sorts of interesting topics. Here's time series metrics with Cassandra. We've got Intuit's journey, going from a relational database to Cassandra. Cassandra internals by Aaron Morton. Aaron's a committer on the Apache Cassandra project. Very, very knowledgeable guy. I'm thinking of another very knowledgeable guy. Here he is, Jonathan Ellis. I'm going to go ahead and click on this. Jonathan is the Apache Cassandra chair and is also CTO at DataStax. He's a great person to watch, whether live or in a video recording, because he tends to talk about the state of Cassandra, so what's currently going on in the marketplace, as well as the future. What are the next versions coming out? What new features do we have to look forward to? What's the roadmap look like? I definitely encourage you to watch any videos by Jonathan. And if I go back here and we kind of scroll back up through the list, you're going to see that sometimes it's technical topics. Here's real-time big data with Storm, Cassandra, and in-memory computing. And then others are use cases. So here's eBay and how they're using Cassandra. Really nice combination of videos on technical aspects of Cassandra, as well as how it's being used. I'm going to suggest that you watch one a day, or if that seems like too many, how about one video a week? That's pretty doable. That's a nice, easy way to continue your Cassandra education. finding out how people are using it, or looking at a technical aspect of the technology in greater depth. For learning more about Cassandra by viewing questions that people are asking, as well as be able to post questions of yours, there are forums as well as a mailing list. Stack Overflow, which is where I am now, is a popular forum for Cassandra and available at stackoverflow.com. Stack Overflow is used for people to post questions on all sorts of technologies. Let's limit what we're viewing to posts related to Cassandra. Up in the URL, once you've typed stackoverflow.com, then go ahead and enter / and then questions /tagged /Cassandra. And that way we'll be viewing questions that have been tagged with the keyword Cassandra. And once you get here, check things out. Go ahead and scroll down and take a look at some of the different questions and answers people are providing. Let's choose this one here. It says insert heavy workloads are CPU bound or IO bound. And if I select that, I see the question somebody posted, and I see a nice answer that another person provided. So that's how to view posts, and you can certainly learn by reading other people's posts and answers. What if you wanted to post your own question? If you're on Stack Overflow, you can click on the Ask Question button up at the top on the right. And if I go ahead and select that, it's going to prompt me to log in, either using Google, Facebook, or Stack Exchange. If you don't have an account for any of these, you could do sign up. And you could then, for instance, sign up for a Stack Exchange account. And then if I go back, go ahead and enter my email address and password. Once you've clicked on the Ask Question button and you're logged in, then you land on this page where it gives you some tips on how to ask questions. So if you scroll down through the list, it's good. Some really nice tips on how to do this and get good answers. One thing they suggest you do right off the bat is go ahead and search to see if somebody has already asked that question. Two benefits of that. One is you're not asking a question that's already been answered, and the other is you get an instant answer. Go ahead and do that if you've got a question to post. And then if you realize that this question has not been asked, then at the bottom here, select the checkbox, the thanks, I will keep these tips in mind when asking box, and then click on the proceed link so that you can go ahead and enter your question. So you're going to put in a specific title. You're going to put in a good description of what your question is. In tags, you're going to put Cassandra and any other relevant keywords. And then I recommend you select the checkbox so that if anybody responds to your post, then you'll get an email. And then finally, of course, you'll click on post your question. So that's how to ask a question. Let's also look at the mailing list option. So I'm going to go to another browser window here, and let's go to cassandra.apache.org. And if you scroll down to the bottom of this page, you're going to see this mailing list column. And under users, you could subscribe. If you'd like to get an idea of the sorts of things people are asking in the mailing list, you can click on archives. And if I scroll down here, you get an idea, some of the different posts. There's one up here from Sylvan. He's one of the committers. He's letting people know that this version has been released. So for asking questions, you've got forums, you've got the Cassandra mailing list. And then I should also mention, if you happen to be a DataStax customer, you would also have DataStax fabulous support engineers available to you. Yet another way to keep learning more and more about Cassandra is to attend events, whether that be Cassandra conferences like the San Francisco Summit and the London Summit, or webinars. DataStax sponsors a lot of Cassandra webinars on various topics, technical to use cases, or meetups. I think meetups are a great way to keep learning about Cassandra and get asked questions. Bring a list of your questions to the meetups, and as you're meeting new people and talking to them about Cassandra, you can ask them your questions. People are there because they love Cassandra and they're happy to talk about it. So how can we find a Cassandra meetup near us? The first thing is go into a browser window and enter cassandra.meetup.com. And once you get to this page, you'll see that there are 165 Cassandra meetup groups around the world. And to find one near you, you can zoom in on the map, or over here on the right, you can specify your country. I'm currently living in England, so I'm going to choose United Kingdom. And if I go ahead and put in a postcode here and click on search, and then I scroll down, I see there's Cassandra London, 1,000 members. I think maybe this might be the biggest Cassandra meetup group in the world. Although don't hold me to that. I know San Francisco also has a very large group as well. Also near me, Reading. So that's a relatively new group, 88 people there as well. And if I go ahead and click on either one of these, it'll take me to that group's meetup page. If there were any upcoming meetups, they would be listed at the top. And then after that is recent meetups, some of the different meetups that have gone on and how many people came and what the topic was. Let's go find one near San Francisco. Go back. I'll put in a San Francisco zip code. Search. Here's the DataStax Cassandra SF users, 939 members. I see there's one coming up. So if I wanted to attend, if I happen to be nearby, I could RSVP for that. I can scroll down and see recent meetups that have gone on and what they were on, who was speaking. So along with the summits and webinars, I think meetups are just a great resource for continuing to learn Cassandra, as well as for getting to know more about Cassandra, getting to know people in the community, and getting to ask questions that you have. Congratulations! Finished the whole course, learned tons of stuff, from understanding what Cassandra is for, to getting started with the architecture, installing Cassandra, communicating with Cassandra, creating a database, creating tables, inserting data, modeling data, creating an application, updating and deleting data, selecting hardware, adding nodes to a cluster, monitoring a cluster, repairing nodes, removing a node, redefining a cluster for multiple data centers, and then finally, resources to learn even more. My hope is that you are excited about Cassandra and you keep going. You keep learning more and more. I think I'd like to end this course with a huge welcome to the Cassandra community.